Hi, today we're going to execute a project on linear regression using Python. The difficulty level of the contents below is intermediate to advanced, depending on your exposure to data science and machine learning. The minimum prerequisites for the course are familiarity with Python for data science, including various Python libraries, NumPy, Pandas, scikit-learn, etc. Also, awareness of machine learning and statistics is preferred. The objective of this discussion is to execute a machine learning project on linear regression to solve a real-life problem. We shall predict the mileage of a car model using historical data. By the end of this project, you will have learned how to understand and interpret a business requirement, apply machine learning to solve real-life problems, know how to prepare the data, perform the machine learning process, and validate the results. Approach to improvise the model performance. So let's move on to slide number 5 now. The plan for today's discussion is, first we shall describe our use case, then understand what is a linear regression by analysis by single variable followed by what's multivariate linear regression. Next we shall move to project details, part 1, requirements and design, followed by part 2, project execution using Jupyter Notes IDE. Use case. First, let's understand the use case driving this project and its importance in daily life. The project is about predicting the mileage of a car model given the past data of various parameters that potentially influence the mileage. Let's imagine that we want to purchase a bike or a car. We know that there are dozens of models in the market that we can choose from. Each one comes with some or the other tall claims from the manufacturer. In case of bikes, some makers promise 100 km per hour pickup in 3 seconds. Some others claim 300-400 cc engines, delivering heavy duty performance. Some others promise so much mileage. Now, mileage is a sensitive issue for everyone. Each one of us wants to know what mileage my favorite car or bike will actually give me. My friends who have used the model say, no matter whatever the claims, in reality, the petrol bill is cutting a big hole in their pocket. So is there a way by which I can predict, at least at a reasonable accuracy, how much mileage my favorite car or bike will actually give me? And this, given my style of driving, my route and traffic conditions. More importantly, can I know these details before making a purchase? Now the answer is yes. We are going to apply data science principles and machine learning techniques using Python to solve this problem. Regression analysis, single variable. Let us say we are trying to calculate how much distance a car will travel in so many hours. Assuming it's running at a constant speed s kilometers per hour. We know that the distance d in kilometers traveled by car in time t hours is given by speed s multiplied by time t hours. Given the constant speed of 40 kilometers per hour, we can simplify this saying d is a function of t, or by an equation d equal to 40 into t. Graphically, this looks like what is shown in figure 1. In this graph, the distance traveled is plotted on the y-axis against the time taken t in hours to cover that distance on x-axis. A straight line given by y equal to 40x plus 25 exactly represents this relationship. Constant speed of 40 km per hour is the slope of the line. 25 kilometers was the distance previously covered when the journey started. That becomes the y-intercept. This is an example of very simple regression equation with one dependent variable, the distance traveled, and two independent variables, speed and time. Out of the two independent variables, we held the speed at a constant value. Now coming to a real life scenario. Let's say we want to know the mileage of a car. Now there is no simple solution for mileage like the one above. Why? This is because the mileage of a car depends on many factors. Therefore, we cannot solve the problem by using simple algebra. This is where machine learning comes in. Such real-life problem can be solved using machine learning algorithms. Today we shall develop a project that uses linear regression. It is simple enough to understand, but very much useful to solve real-life problems in predictive analytics. Some common examples are forecasting future sales of a company, predicting the trend in stock market, anticipating next day's call volume in a call center, so on and so forth. Of course, we must keep in mind that there are many flavors of regression analysis besides linear regression, like non-linear regression, auto-regressive time series forecasting, seasonal ARIMA, triple exponential smoothing, and the recent neural networks with LSTM feature, etc. However, many real-life situations can very well be solved satisfactorily to the desired level of accuracy using vanilla linear regression. Now coming back to our today's topic, we are going to predict the mileage of a new car model that we are considering to purchase. Now linear regression multivariate. Let's see figure 2 to get an idea. In this graph, we see that mileage of various car models is plotted on y-axis against the respective weights in kgs on x-axis. What is the relation between mileage and weight? We can imagine that as the car becomes heavier, it burns more fuel. So obviously mileage goes down. But we also see that the points are scattered much more than the earlier example because of other factors besides weight that influence mileage. So obviously in this case, the solution cannot be just a simple straight line passing through all the points, like the one we saw above. We also realize that there are many other factors. So what next? How does machine learning using regression analysis helps us in solving this? Let's see. In general, in linear regression, what happens is that the machine learning algorithms finds the best fitting straight line to model the relationship between input and output variable or variables. Remember that the algorithm really understands only the numbers and is designed to find the best fit given any such vectors or arrays of numbers. Normally numbers denote points in space. Just to get an idea, in figure 2, we can see that one such base fitting line generated by Excel along with the regression equation y equal to 0.0077x plus 46.273. We should remember that this correlation is only between two variables, weight and mileage. However, we have seen mileage does not depend only on weight. In general, the input variables are called predictors or independent variables. Now let's look at figure 3. The vehicle weight, horsepower, displacement, year of manufacture, etc. are shown as the predictors. By the way, why year is a factor here? Because here the year for us represents the state of the technology. In other words, the models in earlier years were comparatively less fuel efficient. With every passing year, the designs became more and more advanced, and so the vehicles became more and more fuel efficient. Now it's somewhat simplistic to map advance in technology to year as a number, but in absence of better information, we are at least a step closer to reality. Continuing with the discussion, the variable we're going to predict is called the target variable or the dependent variable, which in our example is the mileage. For easy understanding, the charts are showing each pair of variables in a separate diagram. But in reality, they all act together. When there are three such variables, they can be represented along three dimensions. In that case, the regression line becomes a plane. For more than three dimensions, we have to imagine a hyperplane that human eye or mind cannot visualize. Essentially, what we do in machine learning is we try to minimize the error between the predicted and the actual value to fit the ideal equation y equal to a0 plus a1x1 plus a2x2 plus a3x3 plus anxn by trying out various combination of coefficients a0, a1, a2, etc. of variables or the factors or features as they are called in machine learning x1, x2, x3, etc. This is called optimization technique. So we are using one of the most commonly used optimization techniques, that is stochastic gradient descent optimizer, to predict our target variable, mileage of a car. In short, today we are going to solve a multivariate linear regression. That brings us to discussing our project. So problem statement. First comes the problem statement of the project. We define it as to predict the mileage of a car given the past data of various parameters that potentially could influence the mileage. Input data. Let's look at the input data. Figure 3 in it has 394 rows and 9 columns. Each row represents an instance of a car model with its own feature value. Each column represents a particular feature, listing the individual values for the various car models like model name, the number of cylinders provided with the engine, then the displacement, namely the total volume of gas pumped into the chamber of combustion engine, the horsepower of the engine, the weight of the vehicle, the average acceleration the driver uses, the year of manufacture, and the country of manufacture. For example, if we look at one such model Toyota Corona, it has 4-cylinder engine, 113 cc displacement, namely total volume displaced in 4 cylinders, 95 HP engine, 2228 kgs weight, 14 miles per hour acceleration, it gets on an average, manufactured in Japan and in year 1971. The introductory remarks given with the dataset tell us that it's an old data in the early 70s. During that decade, there was a big change in the car manufacturing industry in US. Technology changed from heavy and powerful 6 and 8 cylinder cars with poor mileage to lighter, less powerful 4-cylinder cars with higher fuel efficiency. The global automakers, mainly Americans, Europeans, and Japanese, all wanted to excel in fuel efficiency. Now the solution. Understanding the requirement, analysis of data, and design. It is important to remember that any data science project must be driven by a business requirement. The first thing we should do is understand what the customer wants. That is, to interpret the requirement from a user's perspective. At the same time, the scope of the work is limited by whatever data is available. Therefore, we work on the requirements side by side. We must also study the given data. We should not immediately jump to conclusion and somehow try to fit a machine learning model to get an output. Every data has a story to tell, and to establish that, a lot of preparatory work must go into the development. Studying the data is a lot of visualization and slicing and dicing of the data using various tools. We shall explore this practically when we execute the project. We see that MPG, miles per gallon, that is kilometers per hour in Indian context, is our target variable we want to predict. All the rest of the fields are the candidates for predictors. As part of our application design, we need to select relevant features by analyzing the behavior to decide if they impact the predictor or not. Many times using intuition, we can drop some of the variables upfront that have no relevance to target variable. For example, some of the fields have identical or marginally varying values across the column. We can drop such variables outright. Some of the categorical variables like name, serial number, ID, etc. do not add value as a feature and can be considered for being dropped. In contrast, if the names occur in multiple rows and can be represented as a logical group, like we have US, Japan, etc. in our data, it can serve as a filter, say to form homogeneous group of items that belong to category. We find that technical definition of the term displacement of an engine tells us an important point. In the literature, the displacement is defined as the swept volume of all the pistons inside the cylinder of a reciprocating engine. Since displacement is the total value of gas pumped, it already includes the number of cylinders. So the column number of cylinders becomes redundant and need not be included in the input parameters. We'll see how we can make use of this information in our application design. The data contains a mix of US models, 8 6-cylinders, and higher horsepower, and higher displacement, and low mileage on one side, alongside newer trends of lightweight 4-cylinder, lower cc, lower HP, higher mileage cars. We can segregate and process them separately as we shall see. We shall also make use of the fact that in the chart years versus mileage shows in line with the above observation that mileage improved over the years. Summing up, we see that by using intuition and careful study, we can derive a lot of value from the data. Project details, part second. That brings us to step-by-step execution of the project. At this point, I'm going to open my Jupyter Notes IDE and we should execute various steps as shown in there. To begin, let us first take a look at what all steps are involved in executing our project. As we do each step, we shall review the tasks that are involved in that step in detail. First, we shall import the necessary Python libraries. Then we shall load the input data. This step internally sets up Python's data structure called data frame for our processing. Thereafter, we pre-process the data, which includes cleaning and exploring the data. Under cleaning, we shall cover how to handle bad data and the data with incorrect format. Under exploring, we shall understand how to visualize the data. The topics in this are univariate analysis, that is analysis of one variable at a time, and bivariate analysis, where we shall study the correlation between two variables. Both of these can be either numerical or with graphs. Next, we build and execute our machine learning model. This is the well-known standard machine learning process. Under this step, we shall first set up the input and output variables, then divide the data into train and test sets. Thereafter, train the model, predict the output by running the test data, and lastly, validate the accuracy. Lastly, we shall explore the various alternative approaches to the solution with a view to improve the result. Under this, we shall repeat the above process with a new approach and compare the results. Also understand what can be done in future to get higher accuracy. Now we are moving to the first step, that is importing the libraries. Importing the libraries. As we know, Python derives most of its power and flexibility from the large number of supporting libraries. Each library contributes a particular functionality to Python's collection. Let us first run the instructions. I am going to type each instruction and run it one by one. You can also do the same as we go. Import pandas as PD. Import pandas as PD. Import numpy as MP. Import numpy as NP. Import matplotlib.pyplot as PLT. Matplotlib.pyplot as PLT. Import cbon as SNS. From sklearn.linear model, from sklearn.linear underscore model, import linear regression. Linear regression. From sklearn.model selection, import train test split. Train underscore test underscore split. Split. From sklearn, import matrix. Matrix. Percent matplotlib space inline. percent matplotlib space inline. Now let's run this, shift enter. So as they are running, we will see what each one of these are. Now quickly review the role of each of these libraries we are loading. Pandas is for handling data structure. NumPy for arrays and scientific calculations using numbers. Matplotlib and Seaborn help us with charts and data visualization. Scikit-learn is designed for supporting machine learning operations, including algorithms. As we can see, train test split does the routine job of splitting input data into train and test sets. We are using linear regression model from Scikit-learn's linear model package. Metrics are for accuracy calculation. %matplotlib inline is a magic command that includes the plots in Jupyter Notebook next to the command. Now we see that all the libraries are loaded. So moving on to the second step, loading the data. So loading the data. As the input data, we are going to use Excel sheet cars.xl. This is one of the publicly available datasets that comes loaded with our library when we installed it. Here is the link we can download it from. http://courses. I have shared the link with you and that is available here, so you can download it from there. The dataset available at this location is fairly clean, but in real life, every now and then we run into bad data with junk characters like star, dollar, hash, question mark, so on and so forth. As we get missing data in the form of zeros, blanks, nulls, etc. Again, it's common to get data having incorrect format. Sometimes we can also get unwanted rows, etc. All these imperfections hamper our data processing. So for the purpose of demonstration, I have added such contents in my copy of the above dataset that we'll load now. The name is carseditdemo.xls. We will see how we can get rid of this defective data. I'm sharing this modified Excel sheet separately. However, you also can add the defects yourself and test how you can remove them as an exercise. We shall use pandas method readExcel to read the input dataset from the local path where I have saved it. Now let's run the instruction. So we're going to load the library now. df_cars equal to pd.readExcel open parenthesis c:/users/ so this is the path where I have saved it. You can put your path in instead. Cars underscore edit underscore demo dot xls close quotes, go one step forward, then comma, skip rows equal to open bracket 0. So let's press shift enter. So it has accepted the instruction. Now as we know, this step has internally set up a data frame we named as dfcars for our internal processing. We have dropped the row with the URL by using pandas option skip rows, row number. Specifically, we have used skip rows equal to 0, which is the very first row with URL. With this now, we are ready to go over to the third step, pre-processing and exploring the data. Pre-processing and exploring the data. Most of the data handling operations require data that is clean and in correct format. Pandas provides many convenient methods that help us to visualize or correct the data anomalies. These steps are essential prerequisites that we must perform before data analysis or data modeling. Here are some of these methods that we shall study now. Pre-processing, checking and cleansing the data. Head method. Pandas provides head and tail methods to view the top and bottom few rows of the data frame. Using this, we can check the data format, number of decimals, etc. The default is 5 rows, but we can specify any other number if so preferred. For example, we can specify dot head into parenthesis 10 or dot tail into parenthesis 25 if we want to look at so many more rows. Now, how do we make use of this feature? We can visually check the contents of the top or bottom few rows and make sure that there is nothing unusual to the eye and data format etc. looks as expected. So let's now run the instruction. I'm going to type it now. df underscore cars. This is the name of our data frame. df underscore cars dot head. Shift enter. So this gives the top 5 rows. Now we try the next one. df underscore cars dot tail. Let's say we want to see 10 rows. Shift enter. Okay. So now pandas returns top bottom 10 rate because we are saying dot tail. So it returns the bottom 10 rows. We see that the column horsepower is showing all integer values but is defined as float. So we may consider changing the data type as integer. Now next we look at dot is null method. When the data contains a mix of irregularities like missing data, showing zero values or blanks or non-alphanumeric characters like star, dollar, etc. How do we handle that? Pandas provides us with dot is null method. Here is how we can use the method. So what do we want first here? First and foremost, we want to locate where exactly the bad characters are lying. Dot is null method allows us to get a column-wise summary of these anomalies. Normally, it's sufficient to get a total count in a column. So dot sum method gives a total count in the column. So we combine these two into one instruction that will give us column-wise total counts. So let us try the below instruction. So I'm going to type the instruction now. You also try. df underscore cars dot is null. So we are asking pandas to pull out the null columns dot sum. So tell me how many bad instances are there. So shift enter. So now let's see what is showing. The response tells us that the column horsepower contains 3 cells where we have some unwanted characters. Now we have identified the columns of the problem. Now what next? Next we want to reach the exact rows where the bad data are lying. For this, we look up the rows where the content is other than a real number. So how does the code look like? So let's try that out. df underscore cars, this is our data frame's name, dot loc. Then into square bracket tilde not equal to df underscore cars dot horsepower dot apply. So apply is the standard pandas method to apply individual cells into parenthesis np dot is real. So we are asking everything that is not is real to pull out. So it will pull out all the rows that are exactly showing. Shift enter. So now if we see, it is, so we have a summary of the row wise exact bad data. We find that it's a mix of many types. Our next task is to replace all these mixed types of bad characters by a uniform pandas standard NaN value. We can use below instruction to achieve the same. The first part of the instruction is same as before, followed by comma column name. So I'm going to copy it from here. We need not retype the whole thing. So I will copy this part, Control C, reproduce here, is real, comma, then I extend it from here. Single quotes, horse power equal to np.nan. Shift enter. Here we have converted all mixed types of junk characters into standard uniform NaN format. Note that 0 being a real number, it will escape the not real filter when we replace the rest of the types. So it must be replaced separately as follows. So this, just to make sure that we do not have any 0 values, we can just type this out here. And now we want to be sure that the entire bad content was in fact replaced by a null nan value. So here it is. We shall check the one of the bad rows to verify that. Now we know among the rows above that row number 13 has a bad character. So we will look for contents in number 13. So how do we do that? df underscore cart dot loc square bracket 13. Shift enter. So now if we check, so here it is shows that the bad content is already replaced by NaN. So now if we check again by repeating the earlier instruction for not real numbers, you know this instruction already, we find that all the data is clean. How do we do that? Let's get back here. So it's the same instruction as above. We have typed it earlier. So I'm just going to copy it from there and bring it here. So what do we see here? We see that there is not a single row that contains a non-real number. It means that we have completely converted mixed junk characters into standard null format that Python understands. At this time, we can apply one of the many alternative strategies of imputing the data. That is, we can replace the uniform NaN values by either the mean of entire column or the median or mode, or maybe we can drop bad rows altogether. So which one should we go for? The answer is there is no single right solution. We need to take a call from case to case. Let's replace nans with say mean value of the column and recheck the summary. So here is the instruction that will do the job for us. So let's type this one now. df underscore cars open bracket horsepower equal to df underscore cars square bracket horsepower dot fill NA. So we are asking pandas to replace our earlier horsepower column wherever there was bad character by standard NA, and dot fill NA should replace by df underscore cars square horsepower dot so it has done the job for us. It has already accepted the instruction. Alternatively, we could have used the median of a column or as a substitute. A median is a value located at middle position in the data rather than the arithmetic mean. The instruction is identical to the above with dot mean replaced by dot median. There is also a third option of dropping a row if there are too many NaNs. Let's say we have a row where more than 50% of the values are missing. So in that case, it makes no sense to reset so many values that are means or medians. In such case, it may be a preferred option to drop the rows with too many NaNs altogether if such rows are few in numbers. I am providing these useful instructions under the notes for a handy reference, so you can use it wherever you want. So right now we are good. So we are next instruction dfcars.loc13. Again our earlier instruction where we checked the content of row 13. df underscore cars dot loc 13. Shift enter. So what do we see here? In horsepower, in row 13, now we have replaced NaN also by the mean of the entire horsepower's column. Now we have cleaned the data, so we can move on to the next part of pre-processing, which is getting all the data in the right format, checking and correcting the data format. .dtypes and .stypes method. Pandas .dtypes method allows us to check the data type of a column. So let's run the instruction. What is the instruction? So simply df underscore cars dot d types. Shift enter. Okay. So what do we see here? We find that the data contains horsepower as integers, but it is set up as float in the data frame. We need to take a call based on analysis of the content. Let us say we want horsepower to appear as integer or vice versa. Maybe we want the integers to be converted to float. Pandas provides a method .astypes that lets us change the data type of a variable. So let's modify and then recheck the data types. So how do we do that? So let's do the next instruction now. df underscore cars square bracket horsepower equal to df underscore cars square bracket horsepower dot hash type round bracket or parenthesis int 64, and we change the format and then we check again df underscore cars dot d types. This is the same as our earlier instruction. Shift enter. So now we see, what do we see? We see that horsepower is converted to int like we wanted. So what all have we done so far? We have completely cleansed the data. We have corrected the data format. In short, we are done with the pre-processing and are ready to explore the data. That is to do data visualization. Now moving over to exploring the data. Some instruction for overall view of the dataset. .shape method. This is the instruction to check the size of the dataset. Let's run the instruction. df cars.shape df underscore cars dot shape. Shift enter. We see that our data frame df cars has 394 rows and 9 columns. Length data frame method. To know only number of rows. Earlier we saw rows and columns both, but let's say we want to know only the number of rows. Then we use length data frame. So how does the instruction go? Let's see this here. Len parenthesis df underscore cars. Shift enter. So it answers 394. There is one more important instruction, .describe. To get the statistical summary of all columns like count, minimum, maximum, quartiles, etc. we have .describe method. So let's type the instruction df cars .describe df underscore cars .describe open close parenthesis. Shift enter. Right. The response is showing us a quick statistical overview of each numerical column in the dataset. Remember that it talks only of numerical columns and not the categorical ones. Number 1, count tells us the number of rows. Mean tells us the arithmetic average, while the median tells the middle value. Median and quartile values tell us how the values are distributed. Min and max tell us the range of the values within the data. The information will be clearer when we see box plot of these fields. So that we'll see as we go forward. So now that we have an overall view of the data, we shall study the pattern in detail. This is done by various types of visualizations. First, we shall look at the numbers, that is numerical analysis, followed by the look and feel of the data. So let's see how we do that. Non-graphical univariate analysis. Univariate analysis is analysis of one feature at a time. Non-graphical means it contains only summaries in numbers, that is no charts. It helps us as a quick check in understanding the distribution pattern within a single column. It also allows us to divide the data into logical groups on the basis of some column, say as in our example the number of cylinders. Now let's see dot unique method. Method dot unique returns a list of unique values. Let's see how we can use it. df underscore cars, open bracket, single quotes, origin, bracket close, dot unique, open close parenthesis, shift enter. The response shows a complete list of countries whose car models are included in the dataset. Now, value counts method. Method value count gives us complete details of each unique value within a column with its respective count. So let's run the instruction and study the response. So how does it go? df underscore cars, open bracket, let's say cylinders, single quotes, cylinders, get across the bracket, value underscore counts, open close parenthesis, shift enter. The response tells us that maximum models present in the data have 4 cylinders 201, followed by 8 cylinders 103 and 6 cylinders 83. 3 and 5 cylinders models are insignificant and can be ignored from analysis. Using this information, we can filter and subdivide data into logical groups of interest. Let us see how we can do this. Let us say we want to study the behavior of one or two specific items that are most frequent to represent the data. For example, we can select all cars with 4 cylinders, or maybe all models that were created in USA. Below instruction uses a filter to segregate all 4-cylinder car models in the data. So let's run it and view the response. So let's type the instruction now. df underscore 4cyl. So this is the name of new data frame we are creating because we don't want to disturb df cars. df underscore 4cyl equal to df underscore cars, open bracket, parenthesis, df underscore cars, open bracket, single quotes, cylinders equal to 4. So we are asking pandas to pick only all those car models who have 4 cylinders and not 6 or 8 of this earlier df cars data frame and segregate them, put them together in a data frame and name that as df underscore 4cyl. Now, just to check what we're going to create, we also do a follow-up instruction df underscore 4cyl dot describe, open close parenthesis, shift enter. So see that we have created a separate data frame by the name df underscore 4cyl that has got number of cylinders only as 4 and all the rows are segregated like we wanted to do. So we have done this part now. As you can see, 4-cylinder car models across all countries from a homogeneous group as it was created with a common intent of high fuel efficiency. Summing up, we have separated 4-cylinder car data and created a separate data frame by the name df4sil. We shall use this in the part 2 of this project execution, as we'll see later. Now, graphical univariate analysis. So far what we are looking at was non-graphical analysis. That was only numeric summaries. After non-graphical analysis, let us now study the visual side of univariate analysis called graphical analysis. This gives us a more detailed information and it's easier to visualize. So first one comes is the histograms. Histogram is the most commonly used graph to represent numeric data. Histogram provides a graph of some feature like say MPG shown below, plotted against its frequency of occurrence in the data. In histogram, we divide the total range of MPG column values into number of bins of equal size and study the frequency in each bin. So let us run the below entry to generate a histogram for MPG, that is miles per gallon, as it is our target value of this project, right? So using matplotlib library. So how do we do this? Let's try this instruction. df underscore cars, open bracket, MPG, get across, go next position, dot hist. Hist is histogram, round bracket, bins equal to 12. So this number can be anything. So we are telling pandas that you divide the entire data into 12 such bins and create a histogram of MPG values of df cars. So shift enter. So see that it has generated a histogram here for us. The second type of histogram shown below is an alternative to the one above. It is generated using Seaborn package and it's a bit more sophisticated and gives more statistical detail. So this is only standard syntax, so we will not waste a lot of time in typing each instruction. I will simply copy it from here and run it. So let's do it here. So plot.figure, fixed size. We are telling 8,5. This is the figure size. Tight layout. This is the type of layout we are looking at. This is the standard syntax. sns.displot df cars mpg. So we are asking it to create such a histogram using Seaborn package. Shift enter. So look at this. Alongside the histogram, it has also given a curve which clearly shows how the statistical distribution looks like. We can derive following information from histograms. How the data is distributed. For example, whether it is normally distributed or skewed. Normally distributed data speeds up the machine learning process and can get better accuracy. We can also get an indication of outliers, that is values isolated from majority trend. The above diagrams show this data is skewed to the right hand. We see the long tail that is appearing, that we indicate as the skewed right. So this you will see maximum number of columns on the right hand side. So it is the right skewed. This skewed distribution could be due to mix of 6 and 8 cylinder engines, which show a distinctly different behavior than the majority 4-cylinder engines. That is, the higher frequencies are more concentrated towards the lower displacement. This is because lower displacement indicates 4-cylinder engines. In other words, data shows that 4-cylinder engines are more common than the other types. In case of skewed data, as we will see, sometimes can group data differently for better uniformity. So the next one coming up is the box plots. So what are box plots? A box plot is the visual representation of statistical summary of given data set. The summary includes minimum value, the first quartile, that is the point below which 25% of data lies, median, that is the second quartile, 50% of data lies below the median, third quartile, 75% data below the third quartile, maximum, then the outliers in the data set. So let us run the below entry to generate a box plot of horsepower. So let's type the instruction df underscore cars dot box plot round brackets, column equal to horse power. Shift enter. So what does it tell us? The above graph clearly shows the collection of points above the maximum value, which are the outliers. So in this figure you can clearly see that all these points here on top, this is the maximum, this is the upper quartile, this is the median, this is the lower quartile, and this is the minimum value. So all these points are outliers. Below entry generates a more classified information of horsepower distribution grouped by cylinders. We can also break this down by the different types of cylinders. So that will give us the clearer distribution how each of the group by cylinders is distributed. So let us run the entry to generate it. So how do we do that? df underscore cars dot box plot parenthesis column equal to horsepower. Close single quote by equal to single quotes cylinders, cy cylinders. So let's try this out. Shift enter. Okay. So this has generated us like we wanted the classified by cylinders. The multiple is below is another alternative box plot representation by Seaborn. Box plots. Box plot is a visual representation of the statistical summary of the given dataset. The summary includes minimum value, first quartile, that is the point below which 25% data lies. Median, second quartile, 50% of data lies below median. Third quartile, 75% of data lies below third quartile. Maximum, and the outliers of the dataset. So let us run the below entry to generate a box plot of horsepower. So let's do this part now. df cars dot box plot open round bracket column equal to open square bracket horse power. Shift enter. So what does it say? The above graph clearly shows a collection of points above the maximum value, which are the outliers. Below entry generates a more classified information horsepower distribution grouped by the cylinders. So let's try to generate this. So let's try out the next instruction now. df underscore cars dot box plot open round bracket, same as earlier, same instruction as above, almost same, only grouped by cylinders. Column horsepower, go next position, y equal to cylinders. So shift enter. So here we have the another one. Dealing with outliers. Now here is some consideration of what should be our strategy in case of outliers. Outliers are exceptional data points lying outside the maximum or minimum limits, and often they adversely affect the machine learning performance. So should we remove outliers from data? The answer is it depends on the data pattern. Many times it's a good idea to simply remove the outliers, especially if the rest of the data is homogeneous. Let us say in our earlier example, the distance traveled. If the vehicle had halted a couple of times for a few minutes, that would have generated an outlier. There we knew for sure that this was an one-off issue. Therefore, we could easily drop that outlier and forget about it. This is because the rest of the data is consistent and homogeneous. But in many situations, it's not a good idea to indiscriminately drop the outliers because they have some important fact connected with them. For example, in banking transactions, frauds appear as outliers. In aircraft signal processing, outliers give indication of some technical snag, which can lead to an emergency. In ECG, heart problem appears as an outlier. So basically, There is no one golden rule on this, and we need to study the root cause of the outlier before deciding on it. So today, just to know the process, we will first see how to remove the outliers and then come back and see another approach as to how we can group the data differently to get better results than removing the outlier. So removing the outliers from data frame. In the below example, we are setting a mask of upper cutoff point at 20% from top and then simply removing the data lying outside. So let's first check the initial number of rows. So here the instruction, we check len open bracket df underscore cars square bracket horse power. So length is the number of rows. Shift enter. So we have 394 here. So let us set the upper cutoff limit. So that is upper. Let's define a field called upper. Upper equal to df underscore cars open bracket horse power dot. Now close bracket and dot quantile round bracket 1 minus 0.2. So we want to cut off the limit, set the cutoff limit at 1 minus 0.2, that is about 20% from top. Then we will check the value of upper. So let's run this instruction, shift enter. So we see that it's 140. So our upper limit is set at value 140. We are removing only, remember that we are removing only top portion where all outliers are located. Now let's set up a mask that will work on this cutoff. Okay. So let's define the mask. Mask equal to round bracket df underscore cars open bracket horsepower. Now where do we want to set the limit? Is less than upper. So we want to keep only so many rows in our data. So mask equal to df underscore cars horsepower. This is our column. In this column, whatever is the content below upper, that is only we are retaining. Shift. So we have done this. Now below entry will knock off the top portion from above the mask. Note that we are creating a copy for testing purpose so as to keep the original data intact. We don't want to disturb the original data. Simple as that. df underscore cars 01 equal to df underscore cars mask. So this will operate on the mask. Now we check the effective length, how much we have cut it off to. Okay. So length of df underscore cars 01. Shift enter. So 314. So now double check. We have 394 on top and now we have 314. So we have removed the data points between, that is top 20%. Now there is one more box plot, that is another option to how to check the box plot. Now this truncation part we are not doing actually. Let's check the next instruction, SNS dot box plot round bracket x equal to, see here we have an option of setting which axis we can have the box plot horizontally or we can have it vertically also. X equal to df underscore cars 01 open bracket horse power. Shift enter. Okay. So here we see the box plot. Now what do we see here? The response shows that the earlier outliers are now removed. So now this demonstrates how we can drop the outliers. Now there is something new we want to know. This is SNS count plot. All these plots that we have seen so far, they process numeric values. A count plot, in contrast, can be thought of as a histogram for categorical variables. It is used to find the frequency of each category. So the only categorical variable we have in the data are the origin. For example, the origin country. The country is US or Japan or Europe. So let's see how we can get how many data points, how many car models in our data of each type, like US model, Japan model and Europe models. So SNS dot count plots, like box plot, this is a count plot. Round bracket df underscore cars dot origin, shift enter. So we have this count plot here. So we can see that how many European models are there in the data, how many Japanese are there, how many US are there. Next we see what are non-graphical bivariate analysis. Bivariate analysis by definition means analysis of correlation between two variables. Non-graphical, as we know, is the numerical summary. So .cor method provides a summary of correlation coefficients between given pair of variables. Below instruction will generate a summary in reference to MPG with all other variables. For example, weight, displacement, etc. So let's run the below entry and analyze the output. So let's do that now. df underscore cars dot cor is correlation. Next, go one position forward, open bracket, single quotes, MPG, because we are doing in reference to MPG, dot sort underscore values, then open close parenthesis, shift enter. Right. So what does it say? The above response gives a quick numerical summary of how mileage is correlated with each one of the listed numeric variables. As expected, weight, displacement, cylinders, horsepower all show a strong negative relationship. That is, as these increase, mileage drops. This is understandable as they all are logically connected. Car weight is primarily driving the horsepower, which in turn drives the displacement and the number of cylinders. Acceleration, on the other hand, behaves differently depending on the range of values. On the lower side, it improves mileage with higher acceleration. Beyond some optimal mileage, we know all this, right? So raise the higher acceleration to a very high value, the mileage goes down. So higher acceleration reduces the mileage. Year shows positive correlation because with increasing year, the technology improved and so did the fuel efficiency and mileage. So now the next one is graphical bivariate analysis. Plotting of two variables against one another reflect the correlation between them. Conceptually, bivariate correlations extends into multidimensional patterns. Since MPG is our target variable, so we can check the correlation between MPG versus rest of the fields like weight, horsepower, displacement, etc. We can check a few bivariate scatter plots against mileage to know what factors influence mileage. As expected, weight, displacement, cylinders, horsepower all show a strong negative relationship. As these increase, mileage drops. So I'm going to give you one type variation of horsepower with MPG. Now remaining you can replicate. Now this is a standard syntax, so let's not spend a lot of time in typing it. So I'm just going to copy and run it here. So we are here. So here, what are these instructions do? So we are df cars dot plot. Along the x-axis, we put the horsepower. Along y-axis, MPG, style equal to output. Plot title we are giving, and x label, y label, and plot dot show. Shift enter. So we have generated a scatter plot. So this is how we show the bivariate relationship, correlation between two variables. Now here is something very important instruction which will be all-in-one solution. So let's see scatter matrix plot. Now here is an all-in-one quick visualization tool called scatter matrix. It includes each bivariate plot and each histogram we studied above all together at one place. Having seen each plot individually, in practice we can simply run scatter matrix plot and get a full view of the data. So let's run below instructions to generate a scatter matrix of our DF cars data frame. So let's do this part. Scatter matrix plot MPG. Here is one field we need to define. MPG equal to DF underscore cars MPG, because we'll be referring to this variable as such. Now note that here we are importing another library, pandas.plotting for scatter matrix. So let's do that part. From pandas.plotting, pandas.plotting, import scatter matrix, scatter underscore matrix. Next, scatter matrix, scatter underscore matrix, round bracket, df underscore cars, comma, fig size. This is the figure size. However big or large, small we want, we can. Here is an option to specify that. How much dimension on x-axis, how much on y-axis. So I will choose 16,10. I want a smaller one. We kind of have an idea what the content. So let's create a smaller one. You can increase this or you can play with the dimension to get a feel of it. So alpha equal to 0.5. Diagonal. This diagonal says either we can give an option as a curve or it can give it as a histogram. I'm going to give it as a histogram. So we can give it as a KDE. That's another option. If you press Shift Tab, it will show you various options and it will give all nice documentation of the whole information from Pandas application. It's online available. So you can just press Shift Tab and do that. So let's generate this. Are we correct? Scatter matrix, DF cars, fixed size, 1610. Shift, enter. Now it's running. It is going to generate a graph like this. So this big graph is here. So let's see what this graph tells us. As we see, scatter matrix is giving us all possible combination of univariate histograms and bivariate correlation plots that we have been looking at so far, all at one place. So we have MPG, we have cylinders, we have displacement, we have horsepower, we have weight, acceleration, year, everything. So you can check and you can get familiar with this. This is very important and useful tool and you can make use of this. So as we see, we got all this information and now we are ready to set up our machine learning model. At this point, let's review our work so far. Like we saw, we began with understanding the business requirement. We interpreted the requirement in customer's perspective. Then we gathered the domain knowledge so that we understand our system better. Our scope of work was limited to whatever data contains. So we kept mapping requirements to the data available. Then we identified MPG as our target variable and the remaining features as potential predictors. We decided to drop some of the features like model name, number of cylinders, etc. Then we moved on to data pre-processing, cleaning and getting the format right. Finally, we use visualization techniques to understand each feature individually as well as the correlations between various parts. Now for a quick recap, as we know our regression equation, now this part I'm going to repeat one more time so that we to emphasize on you what exactly is the business we have on hand here. So for quick recap, please pay attention to this. As we know our regression equation is defined as y equal to a0 plus a1x1 plus a2x2 plus a3x3 etc. And like this so many variables n xn, where y is our target variable and the label mileage, which is our label mileage, we know. X1, X2, etc. are predictors like weight, displacement, horsepower, year, all that we have seen. In machine learning, we are going to use gradient descent optimizer to find the optimum values of coefficients A0, A1, A2, etc. of variables X1, X2, X3. This gives us minimum error. The combination that gives us minimum error will be found out by gradient descent optimizer. It will do trial and run with a number of samples and arrive at the best combination of values. So minimum error between predicted value and actual value. So let's see how we do this. So next section, machine learning base run. So here we come to the most important point of our project, that is machine learning. So first thing, we set up the data, predictors and target variables. First we shall convert categorical data into numeric format. So we have only one field, which is origin. We have seen that the column origin has values US, Japan, Europe, etc. Now since machine learning understands only numbers, we need to convert them into numeric format. So we use pandas one hot encoding method getDummies. .getDummies is the method to convert them into numeric format under new columns origin Europe, origin US, etc. etc. It will automatically create the name and it will create the columns also for us. We have seen that cylinders are already a part of displacement, so we exclude them. Also, car model names do not help us in machine learning process, so we drop them from our list of input variables. So this is about the feature selection that we are doing for this model, which we had discussed when we discussed the design part. Now let us execute the below instructions to select our features and convert categorical variables into numerical format as I told you. So let's do that part. df cars, df underscore cars equal to pd.getDummies, pd.getDummies, get underscore dummies, round bracket, df underscore cars, column equal to open bracket, caps O, origin. Okay, so we have in here, let's run through whether we have typed it correctly. df cars, these are important instructions, so please pay close attention to this. df underscore cars equal to pd.getDummies, df cars, comma, columns, origin. So origin we're going to convert. So let's try this, shift enter. So it is accepted. Now which columns we are considering? So as we discussed, columns to consider, this is another field we are defining. Columns to consider, to underscore consider equal to, let's type one by one, displacement, go one position forward, comma, single quotes, horse power, next position, single quotes, WEIGST weight, next field, acceleration, next one, single quotes, year. Now this one is going to getting fall through to the next line, so let us press enter here. Let's go over to the next line, origin Europe. After year comes, maybe we should put the graph backspace, origin Europe, EUROPE, origin underscore Japan, origin underscore US, shift enter. Good. So it is accepted. So columns to consider we are defined to the model, right? Next, let us define our features and labels. So what are, we know now, X are our features, Y is our label. X is an array, so we give a capital X. That is a convention. X equal to df underscore cars, open bracket, columns to consider. Go next position, dot values. So what does it do? It will drop the index. Pandas will drop the index and it will only give the values. So we are getting an array with of all the variables that we have selected and as X. Next, enter, small y, this is our label or the target variable. df underscore cars, open bracket mpg. So this is our target variable dot values. Shift enter. So this has accepted. So we have now what we have done, we have defined our features and labels. X is a, like I already explained, X is a two-dimensional array representing inputs to the model. Each row represents a car model and Y is target variable. So each row actually it is called as a sample. So let's keep that in mind. Split the data into train and test. Now here is the instruction to split the data into train and test sets. So let's do that part now. So we have utility given by scikit-learn train test split, that is a library, and we're going to make use of that. X underscore train comma X underscore backspace X underscore test comma small y underscore train comma small y underscore test. So we are dividing it into all X into train and test, Y into train and test. So we define all the variables at a time. Now equal to train underscore test underscore split round bracket X comma Y comma test underscore size equal to 0.2 comma random state underscore state equal to 0. Now test size 0.2, it says we want 20% as test data and remaining 80% is trained data. Random state equal to 0 is the seed we give to the model. So these are standard Python seed which you know about. So X train, X test, Y train, Y test. Okay. Train test split. This is the library we're calling. So you split this into, we are telling the pandas to split this into X, Y test size. We are telling this to scikit-learn to split this into train and test. Okay. So shift enter. So it has happened already. X test dot shape. Now let's see what is the outcome. So 0.2 of 394. So let's see how much is that. X underscore test dot shape. Shift enter. So it has 79 rows and 8 columns. So that's correct. So here we are using scikit-learn's library model selection that support splitting data into train and test sets. We need to define necessary parameters capital X, capital small y, test data fraction. We have specified 0.2 as I told you, that ensures test data 20% to the input data randomly selected. Now one more point to remember is all these rows, all these values they are randomly selected. So that gives good effect to the machine learning model. Rest 80% is trained data. Now this is all our setup ready for linear regression model. Below is a standard syntax from scikit-learn for defining machine learning model. So below instruction will initialize and train the model. So define and train the model. So that is the next step we do. So let's do that. Regression model. Regression underscore model equal to linear regression. As we remember, this was one of the library we imported. Linear regression shift. Okay. So that initializes that, and next instruction is regression model dot fit. Regression underscore model dot fit. Fit is finding the best fit. X underscore train. So we are keeping the test data untouched and we are running the sample on the training. So we are training the sample machine learning model to learn this relationship between X and Y variables. Y underscore train. So let's try these two entries. Shift enter. So it has already done it for us. Linear regression, copy x equal to true. This is the response we got. N jobs done. Normalization false. So this normalization will come to in the end. We shall discuss this in what this is. Right now we are not doing any of those. We are just doing the plain regression model. Now the fit process, what it has done, it has used the samples from the trained dataset to train the model, which is basically finding the optimum values for various coefficients. Like I said, I'm going to repeat this so that you remember this very well. Okay. So column optimum values for various coefficient a0, a1, an, etc. in the below equation that will minimize the error between y value from the test data y test and predicted y value in the hyperplane y pred as we discussed earlier. Y equal to, so this is the equation, y equal to a0 plus a1 x1 plus a2 x2 plus a3 x3 till an xn. A0 is, now this is again, this is important. A0 is a y-intercept, which is the value of y when all x are set to 0. So this is basically like we in the initial example we saw that the distance 25 kilometers that model had traveled, that was a y-intercept. So this is like that. So the output we get out of running this equation will be coefficients a1, a2, etc. and intercept a0. So we also, just to verify, we define 20% of total rows as test. So let's check what we have. So x test dot shape. We know this instruction already. Shift enter. So we have 79 rows and 8 columns. Below instruction will define an intercept that will be populated by a0 value returned by the algorithm during training. So columns to consider, columns underscore to consider dot append, round bracket, intercept, column to consider append. So what we are doing, we had defined the columns to consider right on top when we started with the machine learning process. So there we had defined each of the variables like whatever weight, displacement and all that. Now in the end we are also going to add one more value, which is the intercept. That intercept will be returned by the model and it will be stored in the value intercept. So let us check. Okay, let's run this instruction first. Shift enter. It has accepted it. Let's check what all our columns look like. Columns to consider. Columns to consider. Let's check which all we have. So this is the complete list of columns we have created. Displacement, horsepower, weight, acceleration, year, origin Europe, origin Japan, origin US, intercept. Now we'll check the output of this model. 1 minute. So below we define a table which is again pandas data frame coefdf that has the above column names listed in a column called predictors. The respective coefficients in a separate column called coefficients. A0 will appear as intercept in this label. This part we have already discussed. So this is a long instruction. So I will just do this one quickly here. So we can type we could have typed this out. So here what we are basically doing is we are defining data frame coefdf pd data frame. This is actually a dictionary in definition of pandas. Predictor, I mean Python definition. Predictor is columns to consider and coefficient is np.append regression model coefficient. So regression model, whatever coefficients are there, they will be the best optimum values. They will be appear in this column regression model coefficient and regression model intercept. This is the initial a0 value. So let's run this. Shift enter. So now we will see how this column looks like. So let's add one row here. coefdf. coefdf. Shift enter. Okay. So here we see whatever is the finding of the model is the displacement. It has how much is the impact it basically shows how much is the impact each variable is having on the predictor on the label, on the target variable. Displacement 0.018. So all these fractions, these are say horsepower, weight, they are all going negative. Acceleration is showing so much importance here. So this is actually it's a finding of the machine learning model. Now predict output. Run the test data using our trained model. This is what we'll do now, and generate the predicted y value. Now what we'll do, we have test data which is 20% of the total data. We had kept it separate. When we split the data, now this test data is something we're going to run now using our machine learned model, and we're going to get the results. So y underscore pred, this is one more field we're going to define, equal to regression model. This is our model we generated, dot predict round bracket x underscore test, shift enter. There is some typing error, something happened here. Let's copy it from here to save time. Let's see what has gone error. Regression underscore, maybe some typing error. X test is not defined. Did we not run X test somewhere? Let's check. Maybe there is some typing error somewhere. X test, the shape, X test, train X test. This is all correct. I think I got it. Probably what had happened was X was caps and I did it small. So shift run. Okay, good. So it is accepted now. So predict output. So we have got the y predict run already. Now in this equation, ypred is the predicted value column. Regression model is the regression model we generated by training the data, and xtest is the test data array. So below we define another table data frame df that has actual test values listed in a column named actual and the respective predicted values in a separate column predicted. So let's do that part now. Df, let's define a new one. Df equal to pd dot data frame, d caps data frame round bracket. Now we define a dictionary here. So open braces, open quotes, actual. This is the column name, is to y underscore test, comma, single quotes, predicted. This is another column. These will appear as column names, and under predicted column we will have all the y underscore pred values, right? Now let's check first 25 rows df1. df1 will define another. Now we know already this instruction df dot head 25. So what we are doing here, so we are just comparing actual values and predicted values. In a data frame we are going to create called df, and out of that 25 rows will be another copy called df1. So let's do that part. Shift enter. So we have created this part. Now evaluation of the performance. We have already run the model. We have generated the output values. We are going to evaluate the performance now. Essentially, under validation, we want to check how accurately the algorithm has predicted the mileage. For that is, compare predicted values with the actual values from the test data. We shall do three types of validations. First one is the visual check. Second one is the percentage predictions, where the predicted versus actual error is say within plus or minus 10% variance. See, normally this will be defined by some user, some client, that we want so much accuracy within this limit, and you should have so many percentage of samples at least which will conform to this accuracy. So we are setting up a 10% variance and we'll measure this again. This is the benchmark we'll set and we'll compare against that. Then third one is the excuse me, root mean square error percentage, which is the statistical benchmark. This is actually universally accepted one. So now we will do a visual comparison. Below bar chart represents a comparison between individual and predicted value and actual value to get an idea. This is a standard plot syntax. So let's copy this instead of typing it one by one. So I do copy and the first part will simply paste here. Okay. So let's go run through that instruction. df1.plot. Okay. So this is matplotlib which is going to plot it for us. Then kind equal to bar. We want it as a form of bars. Okay. Figure size 10,6. This is the size. You can change this option to whatever numbers you want. Now, which is major axis, which is minor axis. These are all finer points we want to set there. The different colors. What colors of bars we want? Green, black, blah, blah, whatever. So this is all standard process. You would be knowing this. So I'm just not going to go into the details. And then plot plt.show. Shift, enter. Okay. So here is the bar plot. This is actually giving us just a quick check, a visual representation as how the predicted and actual values, how close or how far these are. Okay, actual and predicted, we are just comparing. So this was the first type of check we did. Now these two are important. Percentage prediction within tolerance. Now this I found in the industry, this is most relevant. We shall record the entire test output generated and calculate how many predictions are within plus or minus say 10% variance as we discussed. See, this will generate an Excel sheet which will be saved on my C drive. Similarly, you can give a path where you will want to save it on your drive. Okay, and then you can open and take a look at how the different columns are appearing. I'm going to give a snapshot below, which is the performance we are expecting to get out of this data. So initial performance. So let us do this part first. Prediction with tolerance. Okay. Now within tolerance, df0, it will define another data frame here. df0 equal to df. This was our above data frame, earlier one. df.head 79. Why 79? Because we have 79 test samples. df0 dot 2 underscore 2 CSV. This is a standard method. You must be knowing this. df0 dot 2 CSV, and then I'm going to give the entire path. So I will just copy this path. You can whatever path that suits you. Control C. I'm going to put this path here. C:/users was cars out base. So this is the base run. So you can name it as cars out base, and this will keep record. We'll compare as we improve the performance. Now shift enter. So this instruction is run. It has generated an output here. So instead, I won't spend time in looking at that. I have given a quick summary here to save the time. So this is the kind of look we are getting at the Excel sheet. Actual, predicted, error percentage, percentage prediction within 10%. So this is not a very great accuracy we are getting here, but we are going to improve this by a couple of changes that we will discuss it next. Okay. So this is now saying 57% of the predictions are right and 43% are off. They are outside 10% variance. Now the third type of thing that we are going to do is, again, this is a standard syntax, so let's not spend a lot of time on typing this. So there are three things: mean absolute error, mean squared error, and root mean squared error. Our main interest is root mean squared error. So these steps are just to know step by step how things are there, and so that we can look back and check. It's not so this is something that you can try it out by yourself and get a feel. Right now I'm going to get the numbers finally. Shift enter. So mean absolute error is matrix.mean absolute error. So this is matrix is one of the libraries. I will just we must take a note of this. Matrix is the library we imported from pandas Python standard libraries. Matrix.mean absolute error. So this is their own field, and we are going to compare y-test, y-pred. So likewise we have matrix mean squared error and matrix.mean squared root mean squared error. np.sqrt will get the square root of this. Now we'll run this instruction, shift enter. So we will not go into all the details. We just look at the final value, that is 2.978. That's almost like 3. So 3% is a root mean square error we are getting. This was our like baseline performance. We just did nothing special. We just ran the train data set, split into train and test. We ran the model, we generated the output, and these are the results. Okay. So now we are going to do first level of improvement in the performance. Now let's see how we will do this. First, now, okay, one more thing. We have gone instruction by instruction. So the same instruction will be repeated again and again, couple of times. So we will not type each and every instruction one by one because we already seen it up there. So I'm going to copy a bunch of instructions and run it straight away. So we quickly generate an output. So improvise performance. First approach, select only 4-cylinder data. You remember that up there we created a library called 4sil. Let's check we have done that part or not. So let me try one thing. I do not remember if we ran that instruction or not. df underscore 4sil dot shape. Shift enter. Okay, so we have it here. So as we remember, we had split the data, that is 394 rows, into the maximum number of 4-cylinder car models. Okay, so these are about 50%, 201. So we have picked up a section of that data of 201 rows and 9 columns. So we will straight away plot a scatter matrix here that we have seen to save our time. This will kind of show us the behavior, but we kind of know how they are related. So I will just, remaining is going to be repetition of what we did. All we are doing, what special we are doing is, we are, instead of having a mix of 4-cylinder, 6-cylinder, 8 cylinders, we are segregating 4 cylinders together. They are machine learning. Normally the principle that we need to remember is, the more homogeneous data we have, the better results we get. So by keeping 4 cylinders separate, we are expecting to get a better result. So let's see how this happens. So I copy this here. So we generate a scatter matrix for df4sil, shift enter. Okay, so it is generating the matrix for us. So we can take a look. Okay, if we scroll down here, now this is showing us the behavior. Now here this is showing, what we is showing is, we are having only half of the data here, but more uniform data. And we are seeing that the displacement, these are all displacement, these are bivariate plots. Mileage is plotted with displacement, then number of the year, the weight, the displacement, and all these fields. And we're going to repeat the earlier process once again. So set up the data. So I will just execute a bunch of instructions here. Set up the data, predictors, and target variable. So this is a repetition of what we discussed earlier. For df4sil is our, then we are pd.getDummies. Again we are going as before. Origin field, we are going to get the categorical into numeric values. Then we are defining x, we are defining y, we are splitting train test, and we are setting up the data for the model. And finally it will check the xtest.shape, that will give the shape of this. Shift enter. So out of this, what comes out is, we have 41 rows only and 8 columns as the test data, and remaining out of 201, that's roughly 160 are train data. So define and train the model. So let's go to that step now. So again we will execute a bunch of instructions here. We will not waste time in typing this once again, because you can try it out yourself and see how it improves the model performance. Control V. So shift enter. So here are the coefficients. We have generated the predictors and the coefficients. Next one is predict the output. So these are again repetition of what we did earlier. Control C. Now quickly come to the evaluation. So evaluate the performance of algorithm. So we have made one level of modification, that is we have kept only 4 cylinders samples. Essentially under validation we want to check how accurately the algorithm has predicted the mileage and compare. Just a minute, let me get to the right place here. So we'll check the visual comparison. So this I'm going to run all at once. Copy from here and I'm going to paste it here. I would like you to try out all by yourself to get a feel. Okay. This we have done before. We are redoing it. Shift enter. This is for the improved performance. We visually see that the values are coming pretty much a bit closer. Then we'll see the second type and we'll analyze what was our findings. So predictions within tolerance. So let's check how we are doing on this front. So we copy these ones and run it here. So this is going to generate like above 4cl out is output. Now below I have given a snapshot how that looks. So this has improved, not a lot but somewhat, at least about 10% of more accurate readings, predictions. Now let's check on the root mean square performance. By regrouping data, what we find here, into a homogeneous group of 4 cylinders, we have improved the accuracy from 56 to 63% prediction and within 10% tolerance. Also, maximum deviation has dropped from earlier highest 65% to a new lower value of 27% of the mark. So the highest deviating point it has come closer. So we are improving somewhat, but we'll still do better. So we'll see how. So again, I'm going to do this RMSE thing, which we did earlier, and we'll see the values once again. In the end, we will take a stock how we fared. Shift enter. So this actually it went a bit higher if you see, due to insufficient training data. Now this is an important point you want to learn, because this experiment and doing multiple trials, what we are trying to do is how we are improving it. But everything will not work exactly the same way. Due to insufficient training data, the RMSE error in this case is marginally higher by 0.4%. Not 0.4%, but 0.4. That is 3. It has now increased to 3.39 minus 2.98 earlier. So let us see how we can improve this. Now improve the performance second approach. In the above trial, we found that the data became more homogeneous. These conclusions are important to learn from this. In the above trial, we found that the data became more homogeneous when we applied filter to select only 4 cylinder data. However, the training data also reduced to half the size. Smaller data sets resulted in insufficient training during machine learning. This is called underfitting. You don't give sufficient number of samples to the model get trained, so that does not give a great performance. So since we cut down the samples from 79 to this 40 something, so almost half the size, 41, so it was almost half the size, so that has deteriorated the performance. So let's see how we can make this better. Secondly, there was considerable variance in the data. So data also had a lot of variance. If you see the scatter matrix that we generated, there we see there is a lot of scatter in the individual values. So that also causes a lot of variation. It is now we'll discuss all of this in the end. So this has resulted in higher RMSE. Therefore, to check whether the accuracy could improve using larger data set, I have added some dummy data. So there are some scientific methods of doing this, but right now I have added some dummy data just to get a feel, just to tell you how we can improve by giving more data. So let's execute these instructions. So this is one more data set. You can just add some dummy rows to that. What I have done is I have actually sorted the data and took more of a later part of the data. Okay, so the period that was covered by the data was from 1972 to 1982. So what I have done is to add some more samples, I have copied some rows from 80 to 80, from year 80 to 82, and which then that time maximum are showing Japanese ones, and they are more uniform and they are kind of better with fuel efficiency. So we have more uniform data and we have more samples now. So that is in a nutshell what I did to create the data. You can create similar thing or I can share this with you. So let's execute this instruction. I'm going to now load and prepare also in a quick shot. This is again we did earlier and we are repeating it. So I'm going to redo this. So just copy these instructions. We have done it earlier. Control V. So df4 dumb is having some dummy sample. That's why I named it as like that. This is the data frame. pd.read excel from my path. This is the Excel sheet with the added rows. I have created comparable rows almost equal to our original sample, but all with 4 cylinders. Skip row 0, again first row to drop the first row, and df4 dot shape. Shift enter. So this I have created sample. Earlier was 394. This one is 396, almost same, and 9 columns as before. So next instruction, df for dumb is null.sum. I'm going to save time now. Just copy the earlier instruction. We have done all of this earlier. So here we see in the horsepower there is some bad data. So we're going to visualize that. We have visualized this and we're going to remove this. Now to remove this, we are going to change this by fill na dot mean and then create the sum once again. So this we have seen earlier. I'm only doing something we did earlier once again. So copy paste and run it again. Shift enter. So now I have corrected all of them to 0. So all data is good. Now set up the data. So like the above one, we'll also visualize this once. I'm going to create one more scatter matrix plot just for our visualization. So this is the standard process. You must not skip this just to get a feel. But you can, while you do this, you take a look. You try to learn how those things are, the various correlations between variables. This scatter matrix basically is for correlation. So here we are seeing some scatter, some more concentration of some data. So similar pattern like we have seen earlier. Here are the histograms. So where incidentally what you should remember is when the column and row are same, MPG versus MPG, there we have the histogram. So all this we are seeing here. So each histogram and each bivariate variables. Not all variables correlations are important. We need to stay focused on what is our predictor variable and what are the impacting variables we need to look at. So again we set up the model like before. These are the same bunch of instructions. We're going to re-execute. Set up the data, define and train model. So here we have 80 rows. Earlier we had 79. Here we have 80. So it's almost comparable. So all are 4 cylinders and all are more uniform kind of. Let's see how this performs. Define and train model. So regression model we're going to define and coef we're going to generate. So I'll add one more row here below this to run this bunch of instructions. Control V, Shift enter. So these are the coefficients. Now we are hoping for a better output. Let's see how it comes. Predict the output. Y pred equal to regression model dot predict x test. So same process again, and pd.data frame we're going to create another data frame actual versus predicted and we're going to compare the results. Control C. We're going to predict the output now. So now visual comparison. So let's see if this looks better just to get a feel. Visual comparison. Let's do the visual comparison now. Pretty close. They are looking much better now. Now let's see how they are faring on the other fronts. As expected, by increasing the input samples, we have substantially improved the prediction within tolerance. Let's see that now. Now, this is an important thing for us to observe and learn from. So this is now executed. Now what we see is the accuracy is very much improved now. Why it was improved? Because all the data is homogeneous and we have given more samples, right? So we have percentage 22.5% are off and 77.5, nearly 80% have come closer. Now if we have more, you can even extend this concept to more closer and more homogeneous data. We'll discuss this in the end. So how we can do better and better on this performance. So root mean square error, let's see how it is. So we are a bit better on this front also. Earlier the very first was 2.98, then we improved it, we made it worse by cutting down we are giving insufficient training machine learning samples. So that went to 3 point something by 0.4 higher. Now it has come to really in good values. We are getting 2.78. So again it has become 2.78. So now this is most important. Let's come to the conclusion and roadmap for future improvement. So is this all we can do as improvement? Not at all. Rather, this is only the beginning of the infinite opportunity of handling real life use cases. Note that by better grouping of data and then by adding sufficient number of samples, we reduce the highest error percentage from 65% max to 27% max to 17% max. Then this was the highest deviation from the between predicted and actual. So that we reduced considerably. Improved the number of accurate predictions by initial low 56% up to 63% and then finally 78%. So which is pretty good. Improve RMSE from 2.98 to 2.78. There is a lot more that can be explored. For example, increase the number of samples. We should remember machine learning performance improves by large number of samples. Try for uniformity of data. Like for example, we get larger number of US models. Could we get data covering a year or two? We have 10-year data. So maybe if we have narrow range, there's a better chance of predicting closer. Then can we have a single model? We had whole lot of models that we are putting in the data. So maybe we could try out for single model. Another area to explore is use of scaling to make the data same order of magnitude. So this needs some explanation. So if we just scroll up, let me take you up a bit. If you see, these are this predictor and coefficient. If we look at this table, we see that 0.02%, 0.06%, these are the importance that model learning is indicating as how much a variable is important. Now you see here that the year is giving 1.0006. Then these are the importances it has given. So actually what we should do is the numbers, basically as we discussed, the machine learning model only understand the numbers. So the order of magnitude matters here. See, in the case of weight, it is the numbers are 4-digit numbers like 2000, 3000 kgs, right? Then in the case of MPG, we have like in the tens, like 30, 40, they are the mileages. So year is 77, 78. These are the numbers. If we see in the machine learning, the standard processes, normally if you bring all this to the same scale, then the machine learning model will learn better. So these are the things that can be explored in detail, but I'm just giving you pointers here, but these are the things that can improve. So scaling is one of the things that can go on. Then scaling, okay. Then consider additional parameters to classify data like distance traveled, time taken, age of vehicles. So we have taken only weight, whatever was available. So this list can weight and displacement and horsepower. These are the factors we considered, but there can be few more which are actually impacting. So this is how we solve the real life problem. The list can go on. On the final note, we could also extend the application for a car manufacturer or some third-party application to conduct large number of tests and say in an area-based or city-based to advise more realistic estimates to the customer on the mileage on the basis of road conditions, traffic jams, signals. So all these factors also contribute in terms of time taken and mileage. So with this, we conclude our discussion here.
The project title is Face Detection using OpenCV and Python. In this project, we are not going to only perform the face detection, but also we will perform smile detection and eyes detection. The difficulty level of this project is advanced. To do this project, you must have the following skill set. You should have basic knowledge about OpenCV and also about Python programming. The objective of this course is the participant will be able to implement face detection module. Participant will be able to implement not only face detection but also eyes detection, smile detection with images, videos, web camera and URLs. The participant will be able to implement all this logic using OpenCV and Python. What you will learn in this project? You will learn to code using Python programming. You will learn different commands of OpenCV. You will learn face, smile and eyes detection algorithm and also to set up OpenCV environment. Now what are the prerequisites for this course? The prerequisites for this course are basic Python programming knowledge is expected. Then the student should have good understanding of algorithms, especially higher cascade algorithm. And the hardware requirement for this course is camera. The target audience is the participant working in IT sector, computer science students, image processing enthusiasts, and the students who wish to learn OpenCV tools. Now by the end of this project, you will have the following skill set. You will be able to implement face detection code for images, videos, URL, and as well as real-time face detection code. You will be able to read, write, and save images. Good understanding of drawing commands of OpenCV and also about algorithms. And you will understand face detection algorithm, how to perform smile and eyes detection. Now what are the project contents? So we will start with how to load images, videos, URL and how to start a web camera through code. We will learn how to read images through URL. We will understand the setup installation of OpenCV and different algorithms. We will learn how to save a video. We will also learn to count number of people in images using OpenCV and Python code. And at the end, we will learn to detect human features like eyes and smile detection. Now, let's understand the case study. So, we will start with, we will load image and we will perform the face detection. Second, we will count the number of people in the image. So, this system, like counting the number of people in images, is used in attendance recognition system. So, in the attendance system, you can use this code. The next, we will learn to read the image from URL and we will perform the face detection using URL. Then we will learn how to perform real-time face detection. We will start the camera and then we will perform the face detection. Also, we will learn to save the output. We will learn to load a video from the current folder and then we will perform face detection. And at the end, after learning all the face detection techniques, we will perform smile detection and eyes detection. So, in this course, we are going to learn how to perform face detection using images, using videos, using URLs and using real-time camera. Now let's understand the different applications of OpenCV. First is facial detection. So the object of interest, that is face, is detected real-time or through using web cameras and various algorithms can be applied for it. And face recognition system. So in face recognition system, it's not just about detecting the face, but it tells who is in the picture. So if a picture is of some actor, then this system will tell the name of the actor as well. The next is emotion detection. So there are algorithms which detect different emotions of a person, whether the person is happy, sad, frown, etc. And these applications are used in various domains. The next is gender detection. We can also perform gender detection and can also predict the age of an individual using OpenCV techniques. The next is object identification. It tracks object present in the images or videos and filter out the object of interest from images with the help of this object identification technique. Then motion detection. So it is performed by observing the difference between the two consecutive frames, and this motion detection technique can be used in surveillance systems. The next is augmented reality. So augmented reality is a combination of real and virtual environment, and it means you add the digital information layer to real world images. So these are the different applications of OpenCV. Now let's learn what is Haar Cascade Classifier. So it is a machine learning object detection algorithm. Haar Cascade is a model which is trained using both the positive images and the negative images. It is a classifier which is used to detect the object for which it has been trained for. So there are different logic behind face detection, smile detection and eyes detection. So let's learn all this logic through code. Now let's understand what are the software requirement of this project. We are going to develop this project using Jupyter Notebook, and we are going to install now Anaconda distribution. So this is the Anaconda distribution. To download this, visit the website which is anaconda.org, and in this is the website from where you can download Anaconda and all its tools. So this is freely available. Click on the download Anaconda button. And from here, you can download this Anaconda distribution. Click this download button. So this Anaconda is available for different operating systems. It is available for Windows, Mac OS and Linux. So there are two versions, Python 3.7 and Python 2.7. So you can download as per your system requirement. So this is the latest one. Click on the download button and just save this file and it will start downloading. I'm going to pause this because I have already downloaded this software. To download this software, it takes few minutes. Okay. So once you download this software, this is the software which I have downloaded. Double click this and click next button. This is the agreement. I agree. Then install for just me recommended. And this is the path where your Anaconda will be installed. Just press the next button and your installation will start. I'll show you because I have already downloaded this folder. I've already downloaded this software. So I'm just going to change the name of my folder now. Next. Okay. So you need to give some location and press next. Okay. My location is not empty. So you can install it at any other location. Okay. Now you can add path or you can just register as my default Python 3.7. So I'll take this option and press this install button, and the installation will start. Okay, as I have already downloaded this software, so I'm not going to install it again. After proper installation, you can type here Jupyter. So this is the Jupyter notebook, and here we are going to write our code. So this is the Jupyter notebook, and you can create a new file by clicking on this button, new, and click Python 3. So this is our new file. You can rename this file and you can start writing your code here. So this is the Jupyter notebook. Now, along with Python, we also need OpenCV tools. So we are going to develop our code using Anaconda distribution. So in this environment, we need to install OpenCV. So to install OpenCV, you have to install it in the Conda environment. So there is one Conda prompt. After installing this Anaconda navigator, Anaconda, you will get a Conda prompt. Like command prompt, there is a Conda prompt as well. Anaconda prompt. So this is the Anaconda prompt. So from here you can download different libraries, different packages to your system. To install OpenCV, you have to write the command in the Anaconda prompt. The command is conda install c conda forge OpenCV and hit enter. It will take few minutes to download this package. Okay, so collecting package metadata, solving environment. You can also install this OpenCV using Anaconda Navigator. If you don't know what is the command and if you want to install it through Anaconda Navigator, then you can do that as well. Anaconda Navigator, to open Anaconda Navigator, type, this is Anaconda Navigator. Just double click this button. The Anaconda Navigator will pop up. So it's taking time to download. So this is Anaconda Navigator logo. It's loading. Okay. So you can also download different packages in Anaconda using this environment tab. So click this environment tab and from here you can install different packages. So these are the list of packages which are available in Anaconda. If you want to install any package, for example, let's try NumPy. So NumPy is already installed. So you can check uninstalled package, not installed packages. Click here, not installed. And these are the different packages which are not installed. So this orange 3 is a data visualization and data analysis tool. So if you want to install any package using this Anaconda Navigator, you can just click here and press the apply button. So the package will be installed directly. Here also you can check OpenCV. It's not there in my Anaconda, but in your computer there might be this package already there in Anaconda. So just click, if you find that package here, just click here and press the apply button. So this is also another way to install OpenCV package. And if you don't find that package in Anaconda Navigator, then you can do that by writing this command in the Anaconda prompt. I have already installed this package and also my internet is slow, so it will take time to install this package. Once this package is properly installed, you can check that by typing the command which is import cv2. This is the command to check whether the cv2 is installed or not. We can import this package in our code by writing this command and just run this. Okay, so this package is successfully installed now. When you get this, okay, so this is how you can check whether your OpenCV is installed properly or not. Now let's start with the code and understand how to perform face detection using OpenCV and Python. This is the Jupyter notebook which I have opened. Click on the new and create a new file. I have already created a new file. Now just rename this file. The name I have given is face_image. Now let's start with the code. So the first step is importing the required libraries. Now we are going to import OpenCV package. So it is a computer vision library. In simple language, the library which is used for image processing. All the operations which are related to image are easy with this library, and this library is free for use. After importing the library, the next step is just run this line. Okay, so this library is properly imported now. Now the next step is we are going to load the cascade. Load cascade. Okay, so whatever the classifier which we are going to need now for face detection, we are going to load that. To load any classifier, there is one method which is cv2.cascade classifier. So create any variable, okay, and use method cv2.cascade classifier, and here we need to pass the path. Now this is the path of my cascade. Just copy and I'm going to paste it here. So this is how I'm going to load the cascade classifier. Okay, now if you want to check this cascade classifier, if you want to locate this cascade classifier, this classifier is located in your Anaconda folder. So this is my main folder. This is the main folder, and in this folder, in Anaconda 3, in libraries, then so this is where all the classifiers are located. So this is the path which you have to copy paste, and you have to paste this path in your file. So these are the different cascade. So this is cascade for eyes detection. This is cascade for eyeglasses. This is full body cascade. So this classifier is for smile detection. And so these are the different classifiers which are there. So you just need to copy paste the path and append the name of the classifier which you are going to use with extension which is XML. Okay. So if you want to copy paste the path, you can do like this. For example, now we are going to use hair cascade underscore frontal face underscore default. Okay. So right click here, go into the properties, and from here you can check the location of this classifier. Just copy paste this, and this is the name of the classifier. From here you can copy paste the name of the classifier, and you just need to add the extension which is .xml. Okay, so that's what I have done. So this is my classifier. So this is the path of the classifier till data, and this is the name of the classifier which I'm going to use now with the extension which is XML. So either you can directly give the name of the classifier if this classifier is present in your current directory. But since my classifier, this classifier is not in the current directory, I need to pass the path. Okay. Current directory means, for example, if my classifier is here in this folder, okay, this is the current directory. If my classifier is here, then I don't need to give the entire path. with the help of just the name, I can load the classifier. So just load the classifier, run this command. Okay, the classifier is successfully loaded. Okay. The next is we are going to read the input image. Okay. So whatever the image is there, I need to load that. So before that, what is classifier? Let me explain you this in brief. So OpenCV provides pre-trained models that can be used to read the image, and this is the method which is used to read the image, and you can use this method to detect for face detection. So here we are going to use hair cascade model to detect the face. So this is the model which we are going to use to detect the face. And after the installation of OpenCV, these pre-trained models are located in the installed folder. As I showed you, after the installation, you will get to see all these hair cascade classifier in that particular folder. Okay. Then, so this is what hair cascade classifier is. So these classifiers are all XML file which we saw just now, and our input image will be compared with the data in this class, and then the face detection will be performed. So whatever image you are going to use now for face detection, that image will be compared with the data in this classifier, and then the face is detected. Okay, so this is how our classifier works. Next step is we are going to read the image. We are going to read an image. Okay, so for this we have a method which is ImRead. So image is equal to cv2.imread. So in this method you can pass the name of your image, or you can pass path of your image, and there are two parameters you can pass. One is path and second is flag. So the syntax of cv2.imread is cv2.imread. You can pass path and flag. Okay. So if your image is in the current working directory, then you don't need to pass the path. You can just pass the name of the file. And if your image is somewhere else in some other folder, then you need to pass the path as well. So this method loads an image from the specified location, and if the image is in current directory, you just give the name of the image. As my image is in current working directory, so I am just going to pass the name of my image, which is team.jpg. jpg is the extension of my image. Okay. Then as well as you can also give another parameter which is flag. For now I'm not going to pass that parameter, but flag is basically an integer value which specify how you want your image. For example, if you want to load color image, then here you can specify 1, and if you don't specify 1, by default it loads the color image. If you want to load grayscale image, then you can specify 0. If you want to load some unchanged image, then you can load you can write -1. So in this way you can provide different integer values for the flag, and you can load image as you want. Then just run this. Okay, it means that my image is now successfully read. The next step is I am going to convert this image into the gray color. Okay, so let's convert it. To convert any image, there is one method which is cvt color. Okay, so cv2.cvt color, and here we will pass our image, and we will pass the conversion method. So conversion code is cv2.color underscore bgr to gray. Okay, so this is the color code. This is the conversion code. So what I'm going to do here is, so cv2 color helps to change the color space of an image. So there are around 150 color spaces method in OpenCV. So we are going to convert this image into the grayscale, and we are converting this image to grayscale because as grayscale contains less noise. So that's why we are converting. In the CV2 color, you can pass 4 parameters. Like first you can pass the name of the image. Then then second parameter is the conversion code. Then there are 2 more parameters like output file and some optional parameters are there. For now, I am going to use the 2 parameter, which is the image and then the conversion code. The conversion code, there are almost 150 color spaces. So you can also write code like color underscore BGR to HSV. So this is the another code which you can use. So just run this. Okay. So in this way, we have successfully converted our color image to gray image. Detect multiscale. Now this method actually detects the object. Here we want to detect face, right? So the method is cv2.detect multiscale. First we will write code faces is equal to face dot detect multiscale. And here we will pass certain parameters, like first we will pass the image, grayscale image. Then we will pass the scale factor. So here scaling factor is 1. Scale factor means which increases or decreases the image according to the algorithm requirement. So here you have to provide the scaling factor. Then minimum neighbors. So here minimum neighbors is 4. Our classifier contains too many images. So here if we specify 5, then algorithm stop comparing after finding the 5 equal images. And if you set this to, for example, 6, then if you set 6 images, so it requires 6 images that must match with our provided image to detect a face. Then next parameter is minimum size. Minimum size means if object is smaller than minimum size, then it will be ignored. For example, if the face is smaller than the minimum size which I am providing here, then that face will be ignored. So in this way you can set different parameter. For now I am going to set grayscale, image, then scaling factor and minimum neighbors. So here let's set it 4 and just run this code. Okay. Now the next step is I am going to draw the rectangle around the face. So after detecting the face, my algorithm or my code will draw a rectangle around the face. So I'm going to write one function which returns the rectangle where algorithm found the face. Okay. So write a for loop and then cv2 dot rectangle. I want to draw rectangle on image, right? So pass the image, the name of image. So here is my image, right? Then pass the coordinates x comma y comma x plus w comma y plus h. Then pass the color code. I want green color, and then pass the thickness of the rectangle. Let's run this. Done. Next is I want to print the number of faces found in the image. For example, if my image contains 4 people, then it should return 4. If my image contains 10 people, then if I want to count the number of people in my image, then there is one method which is length. With the help of length method, I can count the number of people in my image. So it's very simple. What I'll do is I'll write faces found and length of faces. So here I'm going to pass this, okay, length of faces. I'm not going to run this code right now, just keep it here. Okay. Now next is, now I want to display the output. To display the output, there is one method which is cv2.imshow. And here you need to pass, you can give the name to your window. For example, faces found, I'm giving this name, or faces in the image. Okay, so this is what title I have given to my window, and then you need to pass the image, and finally cv2 dot wait key. So wait for user key to terminate the program. Okay, now let's combine this code so that, okay, now run this last few lines. Okay, we got some error, cv2 dot wait key. Okay, so key is capital. Close the program. Close the program. Okay, the kernel is restarted. Run this line, run this line, run this line, and just change here K is capital. Okay, K is capital, and run this code. See, so this is the output of our program. Okay, so in our image there are 5 people, that's why faces found 5. In this way you can calculate or you can count the number of people in your image very easily. And this is the rectangle and the color is blue. Okay, this code is blue. So if I just change this code, let's see what is the output. First I need to close this program and then run this code. Now see, the color is changed. Also you can change the thickness too, and just change color. Run this. See, the color is changed. Okay. So in this way you can easily do face recognition using hair cascade frontal face default .xml classifier, and you can use different color and a different thickness, as well as you can draw circle around the faces. So this is how you can build your simple face detection classifier. Now we are going to develop a code in which we will convert the URL to image format, and after converting the URL to image format, we are going to perform face detection on that image. So first we need to import certain libraries. So first library is import URL library. So it is a package which is used for opening URL. It is a Python module, and with the help of this URL package we are going to process the different URLs. Then the next is we need import cv2 to perform face detection, because all the classifiers cascades are present in cv2 module. So we are going to import that. The next is we need one more library, which is numpy. Numpy is numerical Python library. So all the numerical operations which we are going to perform now, with the help of numpy we are going to do that. So these are the 3 libraries which we require. Now just run these lines. Okay, now it is successful. The next is we need to load the cascade. Okay, so next step is load the cascade. Now there are pre-trained models which are present in cv2. So here we are going to use hair cascade model to detect face. After installation of OpenCV, these pre-trained models are located in the installed folder. We just need to give the path of the algorithm. So here I am going to use hair cascade frontal face default.xml. Okay, so this is the path. So this is the line of code which I am going to include now. cv2.cascade classifier is the method which is used to load the cascade, and this is my cascade, which is hair cascade frontal face default.xml. So our input image will be compared with the data in this classifier, and these are the pre-trained models which are already present there. The next is we need a URL right now. We are going to read a URL and we are going to convert that URL to the image format. So this is the URL, HTTPS. This is the URL of a Tom Cruise image. Just remember one thing, if you are including URL, if you are writing URL, then it should end with the image extension .jpg. Otherwise it will throw an exception. So URL should end with an extension. Then the next step is we are going to open that URL, right? So URL underscore response, which is equal to URL library dot request dot URL open. I want to open this URL. So this is the URL which I want to open. So I'll pass the URL name here. So this method will open the URL. It will process the URL. So run this. Now let's convert this response into the NumPy array. So let's take one variable, and here we are going to use np.array byte array and pass URL response variable dot read comma pass the data type now. Use the decode function. Now cv2.imDecode function reads data from specified memory cache and converts the data into image format. It also recovers the image from network transmission data. So we will now use the method which is cv2.imDecode, and here we will pass our data. So here we are going to pass this array and we are going to get the data from network transmission data. So basically we are going to get our image from the network transmission data using the imDecode method. Similarly, there is another method which is imencode, which converts the image data to streaming data. If you want to convert your image data to streaming data, then you just need to change this line, that is instead of imDecode write imencode. So here we are using imDecode because we are reading the image from network and converting it into image format. That's we have written imDecode. So after reading the data from the network, we will perform face detection now. Now this img contains my image, this image. Now this URL is converted to image. Okay. Now let's perform face detection on this. So the typical steps for face detection are, first we will convert that image to grayscale. To convert the image to any other format or any other color, so we need a cv2.cvt color, and here we will pass the image and we will also pass the color code conversion. Here I am converting my image from BGR to gray. Okay, and then we will perform face detection. So here we have converted our image, converting image to grayscale. Why we are converting our image to grayscale? Because if the image is gray in color, then it contains less noise and it's easier for face detection. Then for face detection, one method which is used is detect multiscale. So this detect multiscale actually detects the object. So let's perform face detection. Faces is equal to, name of cascade is face underscore cascade. So this is the cascade which is loaded in this variable, and dot detect multi scale. Okay, and here we need to pass certain parameter, that is the name of image. Now my image is gray. Then scaling factor, which is 1.1, and minimum neighbors 4. Scaling factor increases and decreases the size of image, and this is the minimum neighbors which is used for comparison purpose. You can specify any number like 4 and 5. So the classifier will stop comparing after finding 4 equal matches. So this is the face detection code. So after detecting the face, we will draw rectangle on that image. Draw rectangle on the faces found. For that we need one for loop where we need certain coordinates like x, y, w and h. In faces, and we are going to draw a rectangle. So cv2 dot rectangle, and in this I'm going to pass my image. Image is gray, right? Image, then, or I can also pass img, then my coordinates x, y, x plus w comma y plus height, and then color code and thickness of the rectangle. And finally cv2 dot imshow will give me the output. URL image is the title which I am giving to it, and here image, and cv2 dot wait key is it wait for user key to terminate the program. Here x indicates the location of rectangle on x-axis, y indicate the location of rectangle on y-axis, w indicate the width of the rectangle, and h indicate the height of the rectangle. Let's run this code. It's showing some error. URL open error. So let's check the output. Run this. Okay, so this is our output. This is the image of Tom Cruise. What we did, first we imported certain libraries like import URL lib, then import cv2 and import numpy as np. URL lib is to read the URLs, we need this library. cv2 to perform the face detection, and numpy to perform some mathematical operations. Then we load the cascade. So here we are going to use higher cascade classifier. So this classifier is already installed when in your system. When you install OpenCV, you just need to give the path here. I'm going to use higher cascade. So this is the path of the higher cascade. If your higher cascade is in your current directory, so if this file is in your current directory, then you don't need to pass the entire path. But if your higher cascade classifier is in some another directory or in some another folder, then you need to specify the entire path. Then after loading the classifier, you need a URL, right? So this is the URL. This is the image of Tom Cruise, and this Tom Cruise image is present at this URL. So pass the URL of the image, then you need to open that URL. To open the URL, we have one method which is url.request.urlopen, and just pass the URL here, and whatever the response we get, we will take that response in this variable, that is url underscore response, and then we will convert that URL into an image format. So this is the method how we can convert the image into URL format, and this is the data type of that image format, which is np.unsigned integer 8. Now this image underscore array contain my image format. Now I will decode that image, because I am going to read that image from a specified memory location, and this IM decode will convert that data into an image format, and it recovers the image from the network transmission data. Now let's convert the image which is obtained from the URL to a grayscale. Okay, so cv2.color is used to change the format, change the image format. If your image is color, you can change it to grayscale, you can change it to HSV format. I am converting this to grayscale because it reduces the noise of the image. Then we will perform face detection. Detect multiscale method is used for face detection. Here we pass the name of the image, then the scaling factor, if you want to increase or decrease the image based on the algorithm, then the minimum neighbors. After detecting the face, I want to draw the rectangle on the image. So for drawing the rectangle, I need the parameter like x, y, w, h. X is location of rectangle on x-axis, y is location of rectangle on y-axis, w is the width of rectangle, and h is the height of rectangle. Then I'll pass the color code here and the thickness. And cv2.timeshow method is used to open that image in a window, and wait key waits for user key to terminate the program. Now let's close this, and we will change the color of the rectangle, and we will also change the thickness of the rectangle. See, this is the image of Tom Cruise. Now I have obtained this image from URL, I have converted it to image format, and this is the output. We can also perform face detection on videos. So the code is, first we need to import certain libraries. The first one is CV2. CV2 is open source library which contains the face detection classifier, and second is NumPy library which performs all the numerical computation. So CV2, it is a computer vision library. In simple language, the library which is used for image processing. All the operations which are related to images and are easy with this library, and this library is free for use. But now we are performing the face detection on videos. Video is again a sequence of frames. So it's easy to perform face detection on video as well, because video is nothing but it is a collection of frames, collection of images. So first we will import two libraries, which is import CV2, OpenCV library, and we will import the NumPy library. The second is we will load the classifier. Our classifier is hair cascade frontal face default.xml. So this classifier I'm going to use. This is the path where this classifier is present. When you install OpenCV, then in Anaconda 3 package, in Anaconda 3 folder, in library, site packages, CV2 and data, this hair cascade classifiers are there. You can choose any classifier, whichever you want. You can also choose classifier for lip detection, smile detection, and there are n number of classifiers. So now we are just performing the face detection on video. So this is the face detection classifier. Now to load that classifier, there is method which is cv2.cascade classifier, and this cascade classifier method will load the classifier. The next is the input. Now my input is video. I'm not performing face detection on image. Now we are performing face detection on video. So for that, I will create one object using cv2.video capture. So this object is created by passing the name of the video. As my video is in current directory, so I don't need to pass the entire path. I'm just passing name of the video. And to capture a video, you need to create a video capture object. It captures frame by frame, and at the end, we release the video object. Here, the video is captured frame by frame, and at the end, we will just release this object, whichever we are creating now. So next step is this is the object which we have created. This object will take, we will read the video frame by frame. Now, if this object is initialized properly, then this function returns true. Okay. So if this function is initialized properly, if the video is if video path is correct, then we can check that with the help of this function, which is capture.isOpen. If this function returns true, then it will jump here and it will start reading the video. But if this object is not initialized properly, then it will throw an error. Okay. So if you want to check if your video is initialized properly, if this object is initialized properly or not, you can check with the help of capture.isOpen. And if it returns true, it means that the object is initialized properly, or else it will throw an exception, an error. Once your object is initialized properly, it will read your video frame by frame. So capture.read method is used to read the video, and if it returns true, if there is some video, if there is some data, then let's convert this frame, all these frames, into a grayscale. Now we are going to convert our data to a grayscale. So gray is equal to cv2.color. cv2.color is a method which is used to convert the data to different formats. For example, here I am converting my video to grayscale. So cv2.color underscore bgr to gray. And here I am passing my data, that is my video. Okay, so it will convert the data to grayscale. And then after converting the data to grayscale, why we convert our data to grayscale? Because it reduces the noise from the data and it gives us the best face detection. Then we will perform the face detection on the video. For that, there is method which is detect multiscale, face underscore cascade dot detect multiscale. And here we will pass three parameters. First, we will pass the gray object. Then this is the video. Then 1.3, this is the scaling factor, and 5 is the number of neighbors. Okay. Then neighbors means if I am specifying 5, then my algo will stop comparing after finding 5 equal images. And if you set it as 6, so it requires 6 images that must match with our provided image to detect a face. So these are the parameters which we can set for detect multiscale. After detecting a face, we will draw a rectangle around the face. So for that, we will initialize a for loop in which we will pass 4 parameters: x, y, w, h. X for location on x-axis, location on y-axis, width of the rectangle, and height of the rectangle. And this is a cv2.rectangle method is used to draw a rectangle in which we will pass our video frame we will pass. Then we will pass the coordinates where we have obtained the face, where we have detected face. And this is the color, like for example, if I want to draw a green rectangle, then in the same way I'll use the color code here and the thickness of the rectangle. Then to show the video or image in a window, there is a method which is cv2.imshow. This is the title of the window and this is my actual video. Then to stop that video, we need some logic. So this wait key waits for the user input. If the user presses escape button, then the video is stopped, the loop is breaks, and then finally the object is released. The object is released when the face detection is done, and cv2.destroy all windows closes all the frames. So this is the code for face detection on videos. Now let's try and run this. So this is the video. This video works for frontal shots. So that's why this girl face is not detected here. For frontal shot, these algorithms work really well. See, this is again a frontal shot. This girl face is not visible properly. That's why the rectangle is not drawn. Okay. Now you can also change the speed of video by changing the value here. cv2.wait key. Here we pass the time. If it's too less, video will be very fast, and if it is high, video will be slow. Now let's change the value here and see the difference. See, the speed is now slow. Okay. So in this way, you can perform face detection on videos. You just need to pass the path of the video here or directly the video file name, and this is the path of the cascade classifier, and these are the steps. First, import libraries, then load the classifier, then create and instantiate the capture object, then check if the object is initialized properly or not. If it is initialized properly, then read the video frame by frame, convert that video to grayscale, perform face detection, draw the rectangle around the face, and with the help of cv2.imshow, create a window, and for termination, there is a key which is escape. So in the wait key, it wait for the user input. This is the time which is specified here. If the time is more, then the speed of the video is slow, and if the time is less, then the speed of video is fast. And finally, you have to release this object, video capture object, and you have to destroy all the windows, all the frames. Okay. So this is the code for face detection for videos. Now we will understand how to perform face recognition using web camera. Using web camera, face recognition is really important task because it can help us in surveillance. So now let's understand and begin with our code. We will create a new file and just rename it face web camera. So we are going to use OpenCV. So first thing is we will import certain libraries. The first library is import CV2. CV2 is computer vision library. Now the next step is we are going to load the cascade. Okay. So face is equal to CV2 dot cascade classifier. Cascade classifier is a method which is used to load the classifier. So here we need to provide the path. My cascade is present in this folder. So in Anaconda 3, library, site packages, CV2 and data. So these are all the classifiers which are present here. I need this one, hair cascade, frontal, face, default. Right click, go into the properties, and this is the location where the hair cascade is located. Now just copy this and paste here, and also the name of classifier slash, and this is XML file. Now put double slash, because sometimes it doesn't take single slash. So whenever you are specifying any path in Python, use double slash. And just run this. It's successfully loaded. Now we will define a method with the help of which we can save our video. Whatever web camera captures, if you want to save that, there is a method. Now we will see that. Suppose if I want to save my video, whatever web camera has taken, I just want to save that. For that, I'll first create an object cv2 dot video writer underscore force cc, and here I will specify xvid. Here we are going to define a codec and will create a video writer object. In order to encode a video in Python, a coding method need to define. To save any image, it's very easy task, but to save a video, it requires little code. So this 4cc is a 4-byte code used to specify the video codec. Here there are actually different types of video codec. So xvid, then wmvi, divx, mjpg. So here I am going to use xvid for my video codec. Now we will create a video writer object. So for that, you can give any name to your output file. Here I am giving out cv2 dot video writer. Here we will pass parameters, like the first is the name of the output file. You can give any name to your output file. So here I am giving face output dot avi. AVI is the extension. Then second parameter is specify the 4cc code. So my 4cc code is xvid. So I am passing that. Then next is the number of frames per second. This is the number of frames per second. The next is frame size. So you can specify frame size 640, 480. So this is the frame size. Okay. Then run this code. Okay, successful. To capture a video, we need to create video capture object. Its argument are name of file or device index, which specifies the camera. So this camera captures video frame by frame. Now let's create a video capture object. So capture is equal to cv2 dot video capture. Here if you are doing face detection on video, then you can specify the name of file here, or you can specify the device index. Device index means you can specify the built-in camera of your laptop or any other camera which is attached to your system. So if you are writing 0 here, it means you are using the built-in camera. If you want to use a second camera, if your laptop has 2 cameras, then 0 specifies the first camera and 1 specifies the second camera. So in this way, you have to create the video capture object and need to specify the device index or the name of the file. Now let's create a while loop. 1 means true. So this loop runs if capturing has been initialized. So this loop will run now. Now let's read the frame one by one. Let's read frame from the camera. capture dot read. Okay, so it reads frame from camera. Capture dot read returns true when frame is read correctly and the end of video is checked by its return value. So it always returns true if there are frames, if there is a video, and when video ends, it is checked by its return value. The next is, let's convert this video to a grayscale. So gray is equal to cv2.cvt color. With the help of this CVT color method, you can change the color space of your image. Name the file, name the image. So my frames are read in this variable. So just specify that and give the color code. Here I want to convert my image from BGR to gray. Okay. Now I can either save my video without the rectangle around my face. So if you want to save your video, you can write out.write. Whatever your camera captures will be saved. But if I write this command here, it will save my video without the rectangle around my face. So we will do it both the ways. For now, write this command here. This command will save whatever the camera captures. Out.write, and here we just passed the frames. Now the next is, we will detect faces of different sizes from an input video. To detect a face, there is a method which is detect multi-scale. So the name of cascade is face, and detect multi-scale. Here pass this gray, then scaling factor, which reduces the size of image, or it scales the image as per required by the algorithm, and then the minimum number of neighbors. The next is, now this line will detect faces from an input image. Now I want to draw a rectangle around the face. Whenever the face is detected, we will draw a rectangle around it. For that, we will create one for loop and we will iterate. So these are the parameters or the coordinates. Now let's draw a rectangle around it. There is a method which is cv2.rectangle, which is used to draw a rectangle on any image. Now different parameters in this cv2.rectangle are, first is image on which the rectangle is to be drawn. So I want to draw my rectangle on image. So I am writing here img, this variable. The next is, you need to specify the start point. So the start point is x, y, and you also need to specify the end point as well. So end point is x plus w, comma, y plus h. The next is, we will pass the color of the rectangle border. So BGR color, you can pass like this, 255, 0.0, and then the thickness of the rectangle border. So this to indicate the thickness of the rectangle border. Now next step is, we will display the image in a window. So the next code is, display an image in a window. Okay. For that, cv2.imshow method is used, and here we will give title to that window and image. Now we will write logic to terminate the program. The window is terminated or closed when the escape key is pressed. So for that, k is equal to cv2 dot wait key. Until user presses any key, escape key, it won't get closed. And this is hexadecimal constant. If k is equal to 27, break. And finally, we need to release both this video capture object and the output object. So release capture dot release and output dot release. And also we will deallocate all the associated memory also. So last command is cv2 dot destroy all windows. Okay, so now our code is ready. Now let's run this code. To close this window, press escape key. Okay, so this is how you can write a code for face detection using web camera. Now we have also done one thing. What we have done here, we are going to save this output. Okay, so whatever output we got now, we are going to save that. So we are going to save that in out file, faceout.avi. So let's check this file in a current directory. So this is the file. Okay, now you can see one difference here. In this video, there is no rectangle drawn around my face because I have written this out.write command here. If I write this command, okay, if I write this command, if I copy paste, cut paste this command here, and now let's check our output. Okay, run this. Now let's check the output. See, here you can see the rectangle is drawn around the face. So in this way, you can create different videos and you can save the output, and you can also change the color of the rectangle by changing the values here, and also the thickness of rectangle you can change by changing this integer value. So this is the code for face detection using web camera. Now we will see how to develop a code for face detection, eyes detection and lip detection. Lip detection means smile detection. So let's start. First, we will import the important libraries. The most important library here in this code are, first is cv2. cv2 is an open source library and it is basically for computer vision. And second is we are going to import NumPy. NumPy is for numerical Python. Whatever the numerical operations we are going to perform, whatever n-dimensional array we are going to use in this example, so all the operations are carried out with the help of this NumPy package. Run this code. Okay. The next is, now we are going to build a model where we are going to detect face as well as eyes and smile detection. So there are three classifiers which are already there in OpenCV. I'll show you that. So here in OpenCV, there are three classifiers, that is hair cascade eye, hair cascade frontal face default, and hair cascade smile. So these three classifiers are present in OpenCV package. For the sake of convenience, I have copy pasted these three classifiers into my current directory. If you want to see the classifiers, go into Anaconda 3, then here in library, then site packages, and here CV2, and in the data. So these are the different pre-trained models which are available in the OpenCV. So now we are going to build a model which will detect the smile of a person, eyes and face. Okay. So I have just copy pasted these three classifier, that is hair cascade smile, hair cascade eye, and hair cascade frontal face default. Just copy paste these three classifier into the current directory. Okay. If you just copy paste these three classifier in the current directory, you don't need to provide the path. But if you don't want to keep these classifier in your current directory, then in that case you need to provide the entire path. Okay. Now let's load the classifier. First I'll load face classifier. Here, if as my classifier is in the current working directory, so I don't need to provide the entire path, I'll just provide the name of the classifier. So just go here and right click this, and this is the name of my classifier. This is eyes. I want this. Frontal face. Copy paste this. .xml is the extension. Next classifier is eyes. Copy paste the name. .xml. And third is, we are also going to detect the smile of a person. Okay. Now the next step is, we are going to do this face, eyes and smile detection using web camera. So for that, you need to create an object for video capture. So cap is the object which we have created. cv2.video capture is a method, and here you need to pass up argument. If you are doing face detection using video, which is already there in your laptop, then you can just provide the name of file here. But if you are using your inbuilt camera of laptop, then type 0. If there is some second camera, then type 1. In this way, you can provide different arguments. For now, I am using inbuilt camera of my laptop. That's why I have written 0. So this is the third step where you are going to initialize, in simple terms, camera. Now next step is, we want to take the video frame by frame. For that, we will first create a while loop, and 1 stands for this loop is true till the end of video, till the end of the program. And here I am going to read the video capture. So cap.read reads till the end and it reads frame by frame. Now after reading the video, after reading the frames, the next step is I am going to convert it into a grayscale. Gray is equal to cv2 dot cvt color, and here you can pass two arguments. First is the name of frame, this is the frame video input, and second parameter is you need to pass the code conversion. Here I am converting this to gray, so the code is color underscore dgr to gray. Okay, so with the help of this line, the image will be converted to grayscale. Now first we will perform face detection. For face detection, there is method which is classifier. Classifier is face, right? Our face classifier is in this variable, that is face. So write face dot detect multiscale, and here we pass three argument, that is the name of name or the variable of our video plus scaling factor, and we provide the number of neighbors. You can change this value as per your convenience. Then we are going to create one for loop and we are going to draw a rectangle when we detect a face. Okay, so for x, y, w and h. Now x for horizontal axis, coordinate on horizontal axis, coordinate on vertical axis, w is the width and h is the height. For x, y, w, h in faces. So we are going to iterate for all the values here. Whatever the values we have obtained here, we are going to iterate all those. Now for this, we are going to draw a rectangle around the face. So one method is there which is cv2.rectangle, which helps us to draw the rectangle. Okay. Now here we need to pass image on which we want to draw a rectangle. Then you have to pass the start point. Start point is x comma y, and end point. You also need to pass the end point. This is my end point. X plus w and y plus h. X plus w means it will draw a rectangle till the last point. So if my x is 0 and width is 3, then it will draw a line from 0 to 3. Okay. So this is the first point, this is the last point, and you can give color to your rectangle border, and also you can define the thickness of the rectangle. So let's give thickness 3. Okay. Now the next part is I'm also going to do face detection. Along with face detection, lip detection, that is smile detection, and eyes detection. Okay. So for that, now I'm going to create a 2 n-dimensional array. So my region of interest. My region of interest is lips, that is smile, and eyes both. For lip or smile detection, color information is important, but for eyes detection, color information is not that important. So we are going to create a 2 n-dimensional array. One will contain the coordinates for grayscale image and another will contain the coordinate for color image. So let's create 2 n-dimensional array. Region of interest gray, and here it will contain all the coordinates Okay. So this is the range. This is the range function. So this is from y to y plus h, from x to x plus w. Okay. Then next region of interest. Now for color. Okay. Now this is code ready for face detection. Now let's do for eyes detection. For eyes detection, again you need to use one method, which is eyes, which is equal to I dot detect multi-scale. So detect multi-scale is a method which is used for detection of eyes as well as face. But what we are going to pass here we are interested in only the gray image. Okay, so that's why just copy paste this and pass all these coordinates, this array here. Then again we are going to create one for loop in whatever the parameters we have obtained here. We are going to iterate them now. And let's draw rectangle around eyes. So here region of interest, comma, we will pass the first coordinate, that is ex comma ey comma last coordinate ex plus w comma ey plus h. Then we will set the color, we will use different color, and also thickness. Okay, now with the help of this code we will perform eyes detection. Now we want to perform smile detection as well. The code is quite similar. Smile dot detect multi scale and pass region of interest, but here we are interested in color image. Okay, so I'm going to pass these parameters. Again same thing we have to do. Let's iterate all the values in. Now draw rectangle around lip. Okay, I forgot to write here region of interest gray. Okay, and here region of interest is color. Then again the first parameter, which is s x comma s y, and then the last parameter sx plus w comma sy plus h, and then set the color comma 0 comma 255 and set the thickness. Okay, so with the help of these three lines we can easily detect the smile. Okay, now let's create one window in which we can see the output. cv2.im show. First give title to that window, which is face, smile, eyes. This is the title, and let's pass our input image, and then finally we will write the termination logic. Until the key is pressed, if k is equal to 27, break. And finally, we will release video capture. This object we will release and we will destroy all the windows. Okay. Now let's review our code. So here it should be image, not color, and EH should be SW, SH. Okay. Okay, now let's try to run this code. We can also change the thickness. Let's make it 3. It's showing some wrong output. There is some mistake. Let's try and figure out. Here, it should be EW. Okay, run it again. Okay. So in this way, you can create face detection, lip detection, that is smile detection, and eyes detection. And there are different cascades which are available in OpenCV. You can try that as well. Rename this file. So what we did, we imported libraries. First step, load the classifier, initialize camera, then read your video input or read from camera, convert that image to grayscale and just use detect multiscale for face. Then whatever the parameters which you obtain, draw rectangle around the face and just create 2 n-dimensional array, one for gray image, another for color image. And for eyes, in detect multiscale, pass your region of interest, scaling factor and thickness. Similarly, create a for loop and take this parameter to draw rectangle around the region of interest. And same, you can repeat this step for smile. And then finally, IM show for the output and cv2.wait key to terminate the program and release all the video and destroy all the windows. So this is how you can implement face detection, lip detection and eyes detection. In this project, we are going to develop a chatbot using Python and NLTK. The difficulty level of this project is beginner. To do this project, you must have the following skill set: Python and NLP. You should have a good understanding of the core Python and also some concept of natural language processing. Now, what is the project objective? The objective of the project is that the participant will be able to implement the Python code. The participant will understand the use of NLTK and the participant will understand the use of regular expression. What you will learn in this project? First, you will understand how to download and import the necessary tools which are required to implement the chatbot, and then you will implement the Python code for the chatbot. You will also understand the NLTK, that is Natural Language Toolkit, and different corpora datasets which are available in the NLTK, how to import them and how to use them in the code. And you will also learn how to use regular expression for pattern matching purpose. Now, what are the prerequisites for this course? The prerequisites for this course are internet availability, because we are going to download different softwares, different tools for this chatbot, so you should have a good internet connectivity. And another thing is, we need all the tools like Anaconda distributions and NLTK. So if you have this tool, it's good, and if you don't have this tool, you can download it from the sources which I'll mention in the project. Who are your target audience? The participant working in IT sector, computer science students, NLP enthusiast, and chatbot enthusiast. By the end of the project, you will have the following skill set. You will be able to set up the environment for chatbot development. You will understand the Python code for chatbot. You will understand the use of NLTK and regular expressions. Now, project contents. The project contents are: we will understand how to install Anaconda and NLTK. We will understand the Python code, and we will implement a simple chatbot, and will understand the use of NLTK. Case study. We are going to create a simple chatbot from scratch using Python and NLP. Following scenarios will be covered as part of this use case. First, we will download and install the tools. Second, we will set up the environment. Third, we will understand the usage of these tools. Then we will implement the chatbot using Python. And finally, we will test the chatbot. Today, we are going to learn how to develop a chatbot from scratch. You can develop a chatbot using different platforms like Google Dialogflow, IBM Watson, and also there are many other platforms. When you develop a chatbot using these different platforms, you can develop a very intelligent chatbot which has rich functionalities. For example, if you want to develop a chatbot from scratch, then you need to do some coding. And to do that code, we need some softwares and we also need some tools. But the chatbot which we are going to develop today will not be as intelligent as the bot which we developed using Google Dialogflow and IBM Watson. But you can create your own functionalities. You can create a bot from scratch as well. So today we are going to develop a chatbot using Python programming language. To develop a chatbot using Python programming language, we need certain tools. I am going to use Anaconda distribution and NLTK toolkit. First, we will see how to download all these utilities, how to install all these packages, and then we will start with the coding part. To download Anaconda, first you have to visit this website, which is anaconda.com. And on this website, you can see a download button. Anaconda is a most popular Python data science platform. You can easily manage different libraries, dependencies, and environment with Conda. And you can easily develop and train machine learning and deep learning model with scikit-learn, TensorFlow, and Theano. And also, it is suitable for many platforms like Linux, Windows, Mac OS X, and with over 19 million users worldwide. So this is a popular platform which you can use to develop your own product. Now to download it, for example, if you're working with Windows environment, click this tab. If you're working with Mac OS, then click here, and same for Linux. Now we are going to download the latest Python version, which is Python 3.7 version. And my operating system is Windows. So download here. And the downloading will start. After downloading this package, I'm not going to show you end-to-end installation part of this package. It's very easy. Just download this, and after download is complete, double click, and it's a normal installation. You just have to click next, 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 and your Anaconda will be installed. After installing the Anaconda, we are going to open the Jupyter file. You will get this Jupyter notebook. You have to write Jupyter, and this Jupyter notebook you will get. So double click this, After double clicking this, you will be able to get this page, which is Jupyter Notebook, and this Jupyter Notebook opens in a browser. So here you can create your files and different projects. For beginner, it's very good to use this, but if you're working on some big project, then you can go for Spider because that is more manageable than Jupyter. So you can use Spider IDE as well. So let me show you how Anaconda Navigator looks. It takes a few seconds to load as it's a big file. Anaconda Navigator contains all the IDEs, all the packages, all the libraries. You can manage environment. You can manage different IDEs with the help of Anaconda Navigator. So you get each and every part and module of the Anaconda distribution in Anaconda Navigator, where you get all the details of the different IDEs, different packages, and you can also set your environment with the help of Anaconda Navigator. So there are multiple things you can do with the Anaconda Navigator. For example, you can use Jupyter Lab. You have to just press this launch button and it will start. You can start using Jupyter Notebook. If you click this button, then this is the Spider IDE. So you can, if you're doing code using Python programming language, then you can use either Notebook or Spider. For our programming language, there is also RStudio, which you can use. And there are different set of frameworks like Orange 3, which is a data mining framework. And this is a VS Code, and which is a code editor which support for development operations like debugging, task running, and version control. So these are the different tools which are there. So for now, we are going to use a Jupyter Notebook because it is a web-based interactive computing notebook environment, and you can just easily write your code line by line and you can run it very easily. Similarly, you can also do it using the Spider IDE. Now, this is the home page of Anaconda Navigator. So if you click this environment tab, you will get to see what are the different packages which are installed and what are the packages which are not installed. So let's check some packages here. We are going to need NumPy. Yes, NumPy is already installed. Now let's check NLTK. Yes, NLTK is also installed. If in your case NLTK is not installed, it's very easy to install all these packages which are present here. What you have to do is click this drop down menu and you will get to see the different status of the libraries. For example, installed, not installed, updatable, selected, and all. For now, I have selected installed packages. So I'll get a list of the installed packages. So just cross this. Okay. So these are the different packages which are installed in my Anaconda right now. So if you want some package or some library to use in your code, and if it is not present, then you can easily install it with the help of this Anaconda Navigator. Instead of searching the different commands or following some difficult procedure to download and install the packages, the best way is you just search the package which you want to install. For example, if I want to install SciPy, actually SciPy is pre-installed with Anaconda. Let's try some other package. For example, TensorFlow. I think TensorFlow is also installed. Keras is also installed. Okay. Let's check some not installed packages. Okay, for example, this YT package, which is Analysis and Visualization Toolkit for Volumetric Data. For example, if this is the package which is not installed, and if you want to install this package, what you have to do is just click here in the checkbox and press this apply button, and your package will be installed within few minutes or few seconds, depending on the size of the package. Now, what we are going to need for this project is NLTK, which is Natural Language Toolkit, and we are going to need some NumPy and SciPy, which is already pre-installed. So to download the NLTK, there are a variety of ways with the help of which you can download the NLTK. The best way is you can go for the Anaconda Navigator. So here you don't write to need a single line of command. What you have to do is you have to just write the name of the package, and if the package is not installed, it will pop here and you can select that package and you can just press the apply button and that package will get installed. And if the package is already installed, you will get like this. So in my case, NLTK is already installed, so my work is done with this Anaconda Navigator. Similarly, you can also create different environment using Anaconda Navigator. To create a new environment, you have to press this create button and you can create an environment, and you can also select which Python version you want, as well as if you are doing code in R programming language, similarly you can select R and you can select the different packages for it. You can give a name to this environment so that your code will remain intact in that environment without any disturbance. For now, I am just creating my code in the base root, that is the base environment. I am not going to create a new environment for my code. So similarly, so these are the different tutorials which are present in the Anaconda Navigator. If you need any help in respect to Python or in respect to pandas or NumPy, you can just click here and read if you want any help. Similarly, there are 20 videos, 1 training and 20 webinars. So also there is a guideline or help which this Anaconda Navigator gives. Plus there are different communities which you can follow and stay updated. So these are the different functionalities of Anaconda Navigator. And if you want to start, if you have installed your Anaconda Navigator, you can open this and you can also launch your Jupyter Notebook by pressing this button. This is launch button. And if you have opened this Anaconda Navigator for the first time, you will not get this launch button. You will get this install button. So you can click the install button and you can open your Jupyter in the browser. For now, I have already opened the Jupyter Notebook. I'm just going to open it now. So this is the home page of Jupyter Notebook. So these are the different files which are present in my folder. So if you want to create your own file or if you want to create your own folder, then there are different options. You can click this new button and click this Python 3 and a new file will be created. So today we are going to develop a chatbot using Python programming language. So remember one thing, this bot will not be an intelligent one because this bot we are building it from scratch. So you need to put lots and lots of efforts to build the intelligent bot. You have to use natural language processing, NLTK, and also you can build a bot using deep learning, machine learning. So there are different methods with the help of which you can create a bot. But for example, if you are creating a bot for some commercial purpose or for some small business, then you can use Google Dialogflow or IBM Watson. If you are building it for some small company and if your purpose is not big. So if you want to build your own customized bot, then you have to go for coding. So today we are going to develop a simple chatbot which will be interactive, which will just converse with the user Now, after creating a new file, we are going to give a name to a file. So click here and give name to a file. So the name of my file is Python chatbot and click rename. So this is how you can create a new file and rename it. Now, as I already told you that we are going to need the NLTK package. You can either download it using NLTK Anaconda Navigator, or another way of downloading this NLTK package is pip install NLTK. You can write this command in the Jupyter and just run this. It will take few seconds. Isn't it simple to write this command in Jupyter instead of writing this commands on terminal? So this is the best part about Anaconda, that it's very interactive, it's very easy to use. So I got this message that requirement already satisfied. So you may need to restart the kernel to use updated packages. So I have already installed NLTK. That's why I got this message. If in your case, if the package is not installed, then it will take few more seconds to install this NLTK package. So this is the second way. I have already explained you the first way of installing NLTK using Anaconda Navigator. The second way is this. You can type the command, that is pip install NLTK, in the Jupyter, and you can download it. Now I'm going to explain you the third way, which is through the Conda prompt. So this is the Conda prompt. So with the help of the Conda prompt, you can install different packages in your system, and this is the terminal which we get. This is the prompt which we get. And to install the command from the Conda prompt, you have to do it using the specific commands. Now in the Anaconda prompt, we are going to type a command to install the NLTK package. First we will try this command. See, we got message that requirement already satisfied. It means that we have already installed the NLTK package. If this command is not working on your terminal, then another command is Conda command. So there are certain Conda command which you can write in this Conda prompt, which are specifically designed for Anaconda prompt. So which is Conda install C Anaconda NLTK. So this is the pip command and this is the Conda command, and hit the enter button. It will take few seconds to download. So this is the third way of installing the packages. So there are different packages which are available in the Anaconda. For example, if you are not able to find that certain package in your Anaconda Navigator, so you can install that package using Anaconda prompt. So for example, here in the environment tab, let's check out some packages. See OpenCV package. For example, if some package is not present in this Anaconda Navigator and if you want to install those packages, then you can do it with the help of the Conda. The only thing you have to do is you have to find out the commands which are the best fit for your Conda prompt, and you can easily find those Conda commands if you Google it, and it's very easy to install it. So it's taking time. So for now we will proceed with the coding part, and we will get back to this Conda prompt. So as we have already downloaded the required packages, which is NLTK, with the help of pip install NLTK. So we will start using this package now, and let's start with the code. Now after installing NLTK package, your work is not done yet. Now what you have to do is you have to install the required data sets which are present in this NLTK. So NLTK module has many data sets available that you need to download to use. So it is known as corpus. So the data sets which are available in the NLTK package is known as corpus. So different dictionaries are present in this NLTK. So let's see what are the different tools which are present in this NLTK. And instead of downloading all the NLTK packages, we are going to download the specific dictionary which we are going to need now. So import NLTK dot download. For example, if you want to check whether your package is properly installed or not, we can do that with the help of import NLTK command. So write import NLTK and run this. Yes, it means that our NLTK package is properly installed. See, now we are going to download the NLTK. And run this. Showing information. We got this information. So this is the new window which pops up, and so in the taskbar you can easily figure out this new window which we have got. So here we got the different collections of the different corporas are present. So all corpora. So if you want to download all the packages at once, you can select this and you can click the download button. Or if your internet connectivity is slow, then instead of downloading all the packages, you can download the specific packages. So these are the different corporas which are present. So this is the brown corpus. So let's download this brown corpus. Downloading packages, brown. So as I selected all, it's downloading all the packages. Download aborted. Oh, let's download this. Package brown is up to date. So different models are also present, which you can download from here. So these are the different models which are present. And these are the all packages. So these are the different corpora which are present. This is the city database which contains all the information about the city. Then there are some name databases also there. Then different data sets are available. So if you work more and more on this NLTK package, you will understand what are the different corporas which are present. So this is the Twitter samples, Twitter sample. If you want to work on Twitter tweets, then the Twitter sample is also present. So this is the WordNet. This is a dictionary which is present. Web text corpus. So different dictionaries, different packages are present in this NLTK downloader, and it's very easy to download. You have to just click here and press the download button, and within a few seconds it will get installed. So it returned true. It means that whatever task we performed with the help of NLTK, whatever download we did, so it's true. Everything is properly installed. Now we downloaded the brown dictionary. For example, if I want to check what are the different contents of this brown dictionary, so we can do that with the help of command which is from nltk dot corpus import brown, and brown dot words, and run this. See, so these are the different words which are present in the brown dictionary. So in this way we can download different packages, different corporas, datasets which are available in the NLTK without creating our own dictionary. So we can easily refer to this dictionary and we can include all these rich dictionaries in our development. Now for the chatbot, we are going to need some dictionary which is chat and reflections. So these are the two libraries or two packages which we are going to need today. So we will start with the main code now. So I'm going to delete all these commands. I have already installed it. So it's time to begin our code. So instead of deleting this, I will keep this and we will create a new file. And in that file, we will start writing our code for the chatbot. So first give name, chatbot Python, rename it from nltk dot chat dot util import chat comma reflections, and run this. Now what is chat and reflections? So chat is a class and it is a generic framework to processes the conversation between the user and your chatbot. So whatever the conversation we are going to do with the bot, so there is a ready-made class which is chat and we can use it in our chatbot. So it is a generic framework basically, and which is used for conversation between the user and the bot. And the next is reflections. So reflection is a dictionary that when a value in a regression group matches a key in the dictionary, the output is the response. For example, if I'm asking you some question, that is, what is your name? And you know what is the meaning of what is your name. So there is a match. And if there is a match, then you will respond, my name is so and so. It means that you know what is the meaning of what is your name. the sentence of what is your name. So when there is a match between the user and the chatbot, then the chatbot responds. So this is the basic thing. So reflections are nothing but it is a dictionary which stores the key value pair. For example, what is your name? Answer is my name is so and so. So when the chatbot encounters a question which the chatbot already knows, and if there is a match, then in that case the chatbot responds. So this is the reflection. In short, question and answers. You can store questions and answers with the help of this chat and reflections. As I said, reflections is a dictionary. So if you want to view the contents of this reflection, then you can type print and type the name of the package, which is reflections. And let's see. So these are the different key value pairs which are present in the dictionary, in this reflection dictionary. So whenever someone says I am, then the chatbot will respond you are. If I say I was, then the chat will say you were. So these are the basic questions and answers, or you can say different response which the chat bot is trained with. So you can also create your own dictionary. So this is the basic dictionary which is present in NLTK. You can create your own dictionary and you can include that dictionary in your chatbot. You can refer the dictionary in your chatbot. So it is easy to create a dictionary. What you have to do is, if you want to create your own dictionary and use it in your chatbot, then what you have to do is you have to just create a new dictionary. For example, a dictionary which is equal to curly braces, and in this curly braces you have to create a key value pair like this. So this is the key value pair which you can create. So for example, if you are creating a chatbot for some specific purpose, for example, if you are creating it for some commercial purpose, for some hospitals or restaurants, then you need to figure out what kind of conversation takes place at such places. And according to that, you can create your own dictionary and you can include it in your chatbot. So basically, for creating a chatbot, coding is not sufficient. So there are a lot of things which you have to work out to start building a chatbot. And primarily, the main thing is which language you are choosing for communication. That is the main thing. So it's very important to have a good study of language as well as you should have a good domain knowledge as well. For example, if you're creating a bot for banking, then you should have a sound knowledge about all the banking terminologies which the user or the bank generally uses. Or specifically, for example, if you're creating a chatbot for some restaurant, then also you should have good domain knowledge. So for creating any machine learning or deep learning model, only the coding part is important, but the domain knowledge is also important. So basically this AI applications, it is an amalgamation of domain knowledge plus coding. So it's very important to have a domain knowledge as well. So in this way, you can create a dictionary. Now let's see whether our package is installed properly or not. So this is the NLTK package. Yes, and it is installed properly. So this is the command which we wrote, conda installed C anaconda NLTK, collecting package metadata, done, solving environment, done. So this is the following package is installed. It's not installed yet, but see, the following package will be downloaded. So these are the packages which will be downloaded. Now you have to write here yes to proceed. So write Y and it will start extracting the packages and it will start downloading the required packages. So this conda is installing the packages from the internet. It finds the source and then it fetches the packages from that source and it starts downloading. So these are the 4 packages which are installed: NLTK 3.4.5, Conda 4.8.1, and it's done. So we have successfully downloaded the NLTK using Anaconda as well. So I have shared with you the 3 ways to download NLTK. The first way is Anaconda Navigator. The second way is using Jupyter. Directly you can type command there like pip install NLTK. The third way is using Anaconda, and using Anaconda, you can type pip install Anaconda in the Anaconda navigator, or if that command is not working due to some reasons, then you can go for a specific conda command which I have shared with you. So in this way you can download NLTK, and after installing NLTK you have to do certain steps which I have already explained you, which is downloading the required corpus. So this is how you can install NLTK and install the different corpus. So let's get back to our code. So now we have installed the libraries, which is chat and reflections. Chat is a generic framework for the conversation between the bot and the user, and reflection is a dictionary where there is key value pairs, which is again contains the question and answers, or you can say the queries and response in the form it is stored there. Now let's understand how to develop a code for a chatbot. As I told you, the one important point is domain knowledge. You should have a good domain knowledge. Now the second important point is you should understand the target audience. For example, if you are building this bot for banking sector, then you know who is your customer. Then according to that, you should train the model and you should feed the required questions. The third important point is understand the natural language in which you are going to communicate. So if you are building a bot for some regional language, then you have to train your bot according to that. If you are using your bot for some British people or for English speakers, then you have to train it accordingly. So second important thing is the language which you are choosing. The third important point is understanding the intent of the user. Now, why we are creating this bot? Are we creating this bot just for information's sake? Are we creating a bot to do some operations? Or what is the purpose of the bot? For what purpose the user will ask questions to the bot? This is the third thing, means what is the intent of the user. And then finally, we have to come up with the good response as well. So for example, if someone is asking questions to the bot, and if our bot is not aware of the certain questions, then we should give a proper response that, sorry, can you please rephrase the question? Sorry, I don't know. So these are the specific response which the bot should give. And at the end, we will calibrate or we will try to improve the performance of the bot so that the communication should look more interactive. Communication should be interactive. So these are the certain things which we need to remember while creating a bot. Now the next thing is we are going to create a different pairs of the question and answers, and we are going to create the different sections of it. So let's do it. So now the next step is we are going to create the pairs. Now pairs are list of patterns in response. So in this pair, we will create a list, and in that list, we are going to create different patterns. Pattern means the questions which the user will ask, and for those questions, we will write the response. So let's start, and we are going to write pairs, and pairs is nothing but it is a list, and in this list, we are going to create another list, and this is the regular expression. That's why I wrote R. For example, if the user types hi or hello or what's up, hi, you there. So these are the set of questions the user can ask. So for these set of questions, the chat must give some response. So now we are going to type a response, which is hello, or you can also give multiple response. You can also set multiple response. Hey there. So if the user writes hi, hello, what's up, or hi, you there, for such questions, the bot will respond either hello or hey there. So bot will randomly pick any response from these two and will give it to the user. So in this way, we can frame the different questions. So this is the greeting. These are the greetings which we will create first. Greetings, okay. So the another greeting question is, for example, if the user writes Namaste. So for that purpose also, we will create the intent Namaste. So instead of writing this thing again and again, what we'll do is we will just copy this and we will paste it here and we will just edit the intent and response. So Namaste. Now our bot will respond Namaste. Similarly, we will do it for Marathi language as well. For example, if the bot writes or the user write Namaskar, then the bot will write Namaskar. So this Namaste thing is in Hindi and Namaskar is in Marathi language. Or similarly, for good morning, good morning, if the user writes good morning, our bot will respond good morning, good night. See, we are creating a very simple bot. So don't expect that this bot will be very intelligent one. You have to make it intelligent step by step. For now, we are creating a bot from scratch. So we will create a very basic bot and step by step, you can add more functionalities to it. You can use different machine learning models, deep learning models to add intelligence to the bot. So this is hard coded. Now, similarly, good afternoon. Good afternoon. Now here what we are doing is we are writing the patterns and we are writing the response. So pair basically consists of a list of patterns and response. So pattern which matches the user input, and if there is a match then the response is given, and you can add multiple responses. So if there is a pattern match then response is chosen at random time. Similarly, you can add more such training phrases or more such intents to the bot. Now, for example, if you want to take the input from the user and if you want to use that, you can do that with the help of regular expressions. Now, let's do a simple thing. For example, if user write my name is so and so, then your bot should pick up the name of the user and should address the person with his or her name. Okay, so what we are going to write is I am, for example, if user writes some names, so we have to take the name of the user and the bot will respond with his or her name. How are you? How are you is a normal response. But for example, if my bot want to respond or to address the person, then what I need to do is I will take the name of the person. So I can do that with the help of person1. Now to understand all this regular expression, if you want to master this regular expressions, then you can go to the official website of the Python, and in the official website, check the regular expression tab, and in that tab you will get to see all the regular expressions. Each and every regular expression is explained here. Why we are using dot? So in the dot means it matches any character except a new line. So that's why we use dot. Then why we are using star, dot star? So star means it causes the resulting RE to match 0 or more repetition of the preceding RE. For example, in case if someone writes my name is Ram Singh. So Ram Singh. Ram is the one word and Singh is the another word. So it will matches both the words. If you want to just address the person with the first name, then you can write plus sign. Instead of writing the star sign, you can write plus sign. So because it causes the resulting RE to match one or more repetitions of the preceding RE. So there are different regular expressions which are there. So what you need to do is you have to go through all this regular expression and you have to try out all this regular expression if you want to master the skill. So here the different list of regular expression is given. These are the regular expression and this is the meaning which is given here. So you can use this regular expression in your code to make your bot smarter. So this is the link. This is the official Python page. So you can go here and you can check all the syntax of the regular expression. So what we are doing here is we are going to match the name of the user. We are going to print the name of the user in the response. So when the person will write, I am so and so, my name is so and so, in that case the bot will respond, how are you so and so. For example, if I write I am John, then the bot will respond, how are you John. So this is how you can create the intent and response with the help of the regular expression. Now we will add more such intents, more such queries to the bot. Now one thing I missed here is I'm creating a list. So instead of just writing like this, I have to create a multiple list. So I need to put everything in a list. So this is one list. Now I have to put another thing. We are creating a multiple list in pairs. Okay. Now this is the greeting part. Now the next thing is general questions which generally the user can ask, like what do you do or how are you. So we will train our bot with these type of questions as well. So just copy paste. Now I'm going to copy paste the entire syntax because it's difficult to write all these things each and every time. So for example, if the user writes what do you do, for example, if the user wants to know what is the purpose of this bot, then the user can ask what do you do. So we are not creating a bot for some specific purpose. We are just creating this bot for the sake of conversation, just for the sake of the time pass. So the bot will write I chat with people, I like to talk, my job is. You will give multiple response. You can also give multiple response by adding this or symbol. I like to talk. So the next is we will add more questions to it. Now, for example, if your bot asks you, how are you? We will add one more regular expression. For example, if the user writes, how are you? Then you will respond. Bot will respond, I am fine. How are you? I am fine. Now in case if your bot asks you, how are you? Then in that case you will write, I am fine, thank you, or I am good. For example, if you want to, like here what we did, we substituted the name with the dot and star. Similarly, you can also substitute the sentence. For example, if someone writes, I am fine, or I am good, or simply write, I'm doing good. So these are the different sentences, right? So you can't just hard code all these sentences in the code. So we can substitute the part of sentence with star and dot. So similarly, what I'm going to do is I'm going to substitute the part of sentence dot and star so that the bot will understand that yes, the sentence is relevant, and instead of just matching each and every parameter, each and every character, each and every word, the bot will just try to figure out the context of the sentence and will respond accordingly. Now let's write. So it means that the preceding sentence will be anything and it will end with good or fine. So if someone writes, I'm fine, I am good. So these are the two different sentences, right? So if the user writes like this, and if the sentence ends with good and fine, then in that case, the bot will respond great or all right. So these are the two different response the bot will give, like great. So what we did, we replaced the part of sentence with the dot and star part. Okay. Now, before adding more questions to this bot, now what we will do is we will create a function for this bot and we will run this code first. And after running this code, we will understand how our bot is talking, and then accordingly we will add more responses to the bot, and we will also learn more interactive features of the Python. So now let's write the function to run this code. So we will create a function, and in this function, the first statement, when the code will run, the bot will flash one message and then the conversation will begin. So the bot will give some information about it, like, hi, I am chatbot, you can chat with me, what is your name? So this is the first thing the user will see when he opens up the conversation, when he opens the chat. Hi, I am chatbot, you can chat with me, what is your name? And then we have to call this chat and reflections, pairs and reflections. So we will call the class which is chat, and in this chat there are pairs and reflections. And then with the help of this converse function, the user can start conversation with the chatbot, and finally we will use the main function. If name is equal to we will call the function which is from the main function, we will call this function, and this function will trigger the chat class and it will start the conversation. Okay, so this is what we have done till now. So we just have created one greeting intent in which contains all the greeting questions and response, and we have created one functions which will trigger this conversation. Now let's see. So this is the parenthesis for the pairs. So this is the main parenthesis, pairs, and in that parenthesis these are the different set of list which contains the question and answers, and this is the closing parenthesis for pairs list. Let's run this code and see how it looks. Invalid syntax because colon is missing. I chat with people. I like to talk. For now, just keep one response. It should be comma, not or. I like to talk. I am fine. String indicate must be integers. Okay, I am fine. String indices must be integers. Great, alright. Comma. Comma is missing. Again, it's showing some error. String indices must be integers. Yes, we forgot to write comma here. And then finally, it is successful. So what we'll do is we will restart and we will again run this because I want to show you the clean output. So we will restart and clear the output. And for now, I'm commenting this line because I don't want to see the reflections. I just want to check the output of my code. So run this. It will take few seconds. Yes. So this is the output which we got. Hi, I am chatbot. You can chat with me. What is your name? So I'll write I am John. So I got no response because see, I have made a mistake. Am is missing. So see, this is a simple chatbot. So you have to write properly. See, I am John. How are you, John? So which response is triggered? So this is the response which is triggered. I wrote I am John and how are you, John? This response is triggered. So you can chat with your bot. Like for example, if I write how are you? I'm fine. What do you do? I chat with people. So we'll try more such queries like, for example, if I write I am fine. I am fine. How are you fine? It is showing how are you fine. See, because what I have written is I am as the sentence which I have created and I have added this thing. So whatever you write here, it will show like how are you fine. Okay. So these are the small things, but this thing matters. So you have to tune your model accordingly. So this is the basic chatbot. So I'm not going to show you how to tune it and all because that will be in the advanced part. Now let's try some more. I am doing good. How are you doing good? See what we got. Again, this is triggered. Now instead of writing star, let's try plus. I just want to see if there is some changes or not. So we will restart this and we will run this code. How are you, John Carter? Again, it's taking the multiple strings with the help of this plus sign. Okay. So similarly, you can try different phrases like, now I'll try this. Hi, what's up? Hi, hello, hello, hey there. So in this way, you can chat with your bot. Now we will add more such intents to this bot. Now we will make it more sophisticated. For example, we will add some negative feedback and reactions to it. In case if the user writes reactions, so we will just copy paste this syntax. We will paste it here, and what we'll do is we will add some syntax to it. For example, if someone writes sorry, and if there are certain phrases or certain words which are preceding sorry or following sorry, then we can cover up that with the help of dot and star. Sorry, if someone writes some sentence and in that sentence if there is sorry, then our bot will respond, it's okay. Okay. So if you want to add star dot star thing, you can add it on both the side of the words so that you get a good range of the sentence covered. And we will also add some reactions, like for example, if the user write wow, or if the user write great, or if the user writes wonderful, or if the user writes superb. So for such reactions, your bot will respond, thank you. So only difference is whenever you are writing multiple queries or multiple patterns, then you have to separate that with the help of or sign. And whenever you are writing multiple response, then you have to separate that with the help of comma. Thank you. Thanks. Okay. So these are the different reactions which the user can give. Now the next is we will add some negative feedback. So let's put it in the list. Okay. Now we will add some negative feedback to it. In the negative feedback, we will add, just copy paste this format. If someone writes, you're bad, then we will give some polite reply. I will try to improve. And we'll add one more negative feedback. You are stupid. Oh, really? Or I am sorry. You can add any response. And finally, we will write a code to quit. So, for example, if the user wants to close the conversation, then in case if the user writes bye, then it was nice talking to you. Okay. So these are the different responses which we have added to the bot. Now let's try and check it whether it's run or not properly. It's taking some time. Okay, let's restart this and then we'll try to run it again. Restart, and let me go through the code. Let me check if there is some error. I think it's good to go. I'll press the run button. Okay, I got EOL while scanning string literal. I will improve. Okay, I will improve. Yes, I need to improve. Run. Yes, it's running. Now let's check the other phrases which we have added recently. We will start with wow and great. Wow. Thank you. Great. Thanks. See, it's working. We will add another one which is you're bad. You are bad. I will try to improve. And we will try this phrase which is sorry. So let's type sorry. Now we will create a sentence of by using sorry. Okay, I am sorry. I am, instead of writing I am sorry, I'll write sorry dear. It's okay. See why it's matching? Because we have added regular expression to it. So I have added this regular expression to it. That's why it's replying me. So let's try to remove this and run this code. So let's remove this regular expression and we'll try to run. Let's see what happens. Still it's giving response. It's okay. We will try the remaining phrases or the intents. For example, you are stupid. Oh really? And the last is bye. It was nice talking to you. But the thing is, we are not able to quit the application or the chatbot. So specifically, we will have to write quit command to close the conversation. So we will make some changes to it. So when someone will say bye, we will respond it with bye. And we will use the regular expression which is quit to close the application. Okay. Now restart it and run. Bye, bye, and if someone writes quit, then the bot is closed. So in this way, we can create a simple chat bot with the help of Python, Anaconda, and NLTK. Python game development training beginner level. In this tutorial, we are going to learn about game development using Python programming language. To do this course, you must have the following skill sets. Python basics and programming knowledge is expected. Now, what is the course objective? The objective of the course is participant will be able to implement the Python game and participant will be able to set up the environment for the game, understand features of the game, and create game with Python and Pygame. What you will learn at beginner level? You will learn how to download Python and Pygame, Pygame basics, setting up Pygame program, pixel coordinates, opening display loops and events and quitting, graphics primitives. Now, what are the course prerequisites? The participant must have core Python knowledge and design skills. Now, who are the target audience? Participants working in IT sector, programming and game enthusiasts. By the end of the course, you will have the following skill sets. You will get hands-on regarding game development. You will understand Pygame features implementation. And you will also understand how to develop the game module. Now let's start with our first chapter, which is downloading Python and Pygame. So there are different Python IDEs and code editors. PyCharm, Spider, Jupyter Notebook, Vim, Visual Studio Code, Thorny, Ideal, Atom. So what is PyCharm? So PyCharm is the IDE for professional development. So basically this PyCharm IDE developed by JetBrains company, and there are two versions of PyCharm, community version and professional version. So community version is free and open source, and professional version is paid version. So you can download the community version of PyCharm if you want to develop a software for your own use, or if you want to develop a software for commercial purpose, then also you can use community version, but there are more features in professional version as well. So if you want to pay, you can pay and buy professional software. The next is the Spider IDE. So Spider IDE is also open source, and it is basically used for scientific development. So it is very easy to download and install the Spider. The easiest way is to install it by installing the Anaconda distribution. Jupyter Notebook is same. Jupyter Notebook is also easy to install, and the easiest way to install it is by Anaconda distribution. So Jupyter Notebook is also open source, and you can create and share live codes and do visualization with the help of the Jupyter Notebook. Then Vim. Vim is the text editor which is pre-installed in Mac OS and Unix for Windows. So it's already pre-installed, so you don't need to install it. The next thing is Visual Studio Code. So Visual Studio Code is open source, and it is Microsoft. The next is Thorny. So Thorny IDE comes with Python 3, which is built in, and next is Ideal. Ideal is also installed by default when you install the Python 3. So these are the different IDEs and Python editors, code editors. You can download it, or some of them are pre-installed, some of them you need to download it. So now let's see how to download this Python IDEs and code editors. And after downloading this, the editor, we are going to install the Pygame. So basically, the Spider and Jupyter Notebook are the easiest way to install if you are downloading the Anaconda distribution. So first we will download the Anaconda, then we will start with the code. So Spider and Jupyter Notebook are the two IDEs which are already present in the Anaconda distribution. So we are going to use Jupyter Notebook. So let's install it and also install the Pygame. Now we will first install Anaconda distribution, and then we will open Jupyter Notebook. So to download the Anaconda distribution, type anaconda.org. So this is the official website of Anaconda. Okay, so this is the official page of Anaconda distribution. So where there are different packages, notebook, projects and environments which are shared in the Anaconda cloud as well. Click on the download button here. So this is the Anaconda distribution, which is the world's most popular Python R data science platform. So press on this download button. So there are different platforms for which you can download this Anaconda. So this is the Windows platform, Mac OS platform and Linux platform. So click your platform. My platform is Windows. So Windows is by default selected. Now there are two versions of Python, which is Python 3.7 version, which is the latest version, and Python 2.7 version. So you can download the latest version, which is Python 3.7 version. So click on the download button. So the download will start, Now I will pause this download because I have already downloaded this Anaconda distribution. So the size is almost 462 MB. So if you are downloading it, then it will take at least 10 minutes, minimum 10 minutes. Okay. So after downloading the Anaconda distribution, double click this. So you will get this type of icon. So double click this icon. So welcome to Anaconda 3. This is the 64-bit setup. Click on the next button. This is the license agreement. Just scroll down and press I agree. Install for just me recommended. Click this button. And this is the folder where you can install your Anaconda. So you can change this folder. You can write any other name and just press this next button to start the installation process. So these are the environment variable which you can set, which is generally not recommended. And after setting this option, you can either click this or untick this. So I'll not do anything. I'll just press this install button to start the installation. As I have already installed this Anaconda, so I will stop this installation. Once this installation is completed, you can open Jupyter Notebook by typing here. So this is the Jupyter Notebook which is already installed with Anaconda distribution. And another way of opening this Spider and Jupyter Notebook is by using the Anaconda Navigator. So once you have properly installed the Anaconda distribution, type Anaconda Navigator. So this is the Anaconda Navigator. So double click here and start the Anaconda Navigator. Okay. So this is the Jupyter Notebook. So this Jupyter Notebook opens up in a browser. So this is the browser where it opens up. So this is the home page of Jupyter Notebook. So these are the different file names, folder names, and you can create your new file by clicking this button which is new, and from the drop down menu you can select Python 3 to create a Python file. You can also create text file, folders, terminals. So just click Python 3. So it's still getting installed. I have already installed Anaconda. That's why I'm showing you the further steps. So in this way you can create a new file in the Jupyter Notebook. So this is Untitled 15. So you can rename this file. So basically we are going to develop Pygame application. So first we will see some basics of Pygame and then we will proceed with it. Okay, and rename this. So this is the Pygame. This is the new file which we have created. Now if you want to install the Pygame library, so you can do that with the help of pip command. So pip install Pygame is the command to install the Pygame library. Now the thing is, you can directly write this command here and press the run button. So this is the easiest way to install any library here in Jupyter Notebook. So write pip install Pygame and run this command. It will take few seconds to install Pygame. So these are the pop-ups for Anaconda Navigator which we are getting right now. So wait for some time. So this Pygame is getting installed. Meanwhile, I'll show you Anaconda Navigator. So this is the Anaconda Navigator which is getting initialized. Pip install Pygame. We wrote this command to install the Pygame and we got the message which is requirement already satisfied. It means that I have already installed this Pygame package. That's why I got this reply that the Pygame is already installed and you need to restart the kernel to use the updated package. If you have already installed the Pygame, update it if you write this command. So this is one way of installing the Pygame in Anaconda. The another way of installing any library is through the prompt. there is a Anaconda prompt. When you install Anaconda, you will also get an Anaconda prompt. So this is the Anaconda prompt. So double click here, and from this console, this terminal, you can also install the different libraries and packages in the Python. So instead of writing the command in the Jupyter, you can also write the same command here, which is pip install pygame. Again, it will take some time to check. See, we got the message which is requirement already satisfied. If in your case, if you have not installed the pygame, then it will take some amount of time to install the pygame. But the command is same. Just write pip install pygame and wait for some time, and the pygame will be installed in your system. In my case, it is already installed. That's why I got message which is requirement already satisfied. Now let's check if the pygame is properly installed or not. To check any software or library if it is installed properly or not, you have to write the command which is import pygame. So now we will try to import the pygame, and if this pygame is properly installed, then it will be successfully, we will get the successful output. That is, there will be no error while running it. So write import pygame and just run this cell. So it's taking some time to verify. Star means it's running. So pygame contains different features which you require to create a game. Pygame is a library of Python which we have just downloaded, and now we are trying to import it. So usually it doesn't take so much time. Actually, I'm running multiple processes. That's why I think it's taking time. What I'll do is I'll just close this, and now we will restart the kernel and we will again test. Okay, restart and write import pygame. Okay, it's taking some time. So meanwhile, I'll show you what is Anaconda Navigator. So just minimize this. Okay, so this is the Anaconda Navigator. After installing the Anaconda, you will get the Anaconda Navigator. You can open that by writing here like Anaconda Navigator. So this Anaconda Navigator homepage contains different IDs like Notebook, Spider. So these are the two IDs which are already come pre-installed with Anaconda. And these are the different ID like Orange 3, R Studio, VS Code. So if you want to use R programming, then there is a tool which is R Studio which comes with Anaconda distribution. So this is the environment tab. So you can create your own environment in Anaconda. Okay. So if you want to check the different libraries which are installed or not installed, just click this drop down menu, and from this drop down menu you can check different commands which are installed, the commands which are not installed, updatable commands, then selected commands. Okay, so let's check if we get pygame here. So write pygame and here click not installed. Okay, so pygame is not present here. So that's why we used the command which is pip command. So in case if there are many libraries which are there here in this Anaconda Navigator. For example, if you want to install the TensorFlow is the framework for deep learning. So you can directly install any software by just clicking here and press the apply button, and that particular library gets installed very easily. So if you want to install any library, first check whether it is present in Anaconda Navigator. If it is present, then your work is easy. You just have to click here and you just have to press the apply button. Or in case if you are not able to find that particular library in Anaconda distribution, then you can use the Anaconda prompt. From there you can write the command to install the particular library, or you can directly write a command in Jupyter Notebook if such type of command is there. Okay, now let's go back and check if it's installed or not. See, we got the message that pygame 1.9.6, the version is 1.9.6. It is successfully installed. So we got this message. It means that it is successfully installed. Pygame is installed. So in this way, we learned how to install the Anaconda distribution, that is Python. We also checked out different IDEs like Jupyter Notebook, and we also installed the pygame, which is the necessary library for the programming. Now let's check the Spider IDE as well, and you can choose any one. Like you can also use Jupyter Notebook, or you can use Spider IDE, and if you want to use PyCharm, then you can also go for it. So if you want to open this Spider IDE, you can press this launch button, but it will take some amount of time to open because launch this type takes time. So you can write here like spider and click here to open the spider ID. When you use any software for the first time, it will take some time to load. You can also press this launch button. Now let's check another ID, which is spider. So you can open spider ID by typing here. You will get that application, that editor. You can double click and open. And another way to open that spider ID is using Anaconda Navigator. So this is the spider ID. If you want to open this spider ID, you can also click here on the launch button and it will get launched. So this is the spider ID which I have already opened for you. So this is the area where you can write your code, and this is the console area where you get the output. So you can also write the code here. So there are different tools and support which is available. You can debug your code, you can run your code. So there are different options which are already given in spider IDE as well. So you can also use this spider IDE for the development of the game. So whichever is convenient for you, you can go for it. PyCharm, Spider, Jupyter, Sublime Text, anyone, whichever is convenient for you. So in this way we learned about different IDEs, as well as we see how to install Anaconda distribution, how to install Pygame. So now let's start with the another topic. Now let's start with some of the basic commands of Pygame. The first is initialization. To initialize a program, to create the instance of the program, we are going to use pygame.init method. So this pygame.init method is basically used to initialize all the Pygame modules. So it initializes all the imported Pygame modules, and it is also possible to initialize the individual modules manually. But if you use pygame.init, it initializes all the module at once. So basically it returns the tuples which contains the number of successful and failed initialization. So if you want to start your program and if you want to use all the modules within the program, you can use a pygame.init method to use them. Until and unless you initialize the module, you won't be able to use them. And you can also use individual module as well. But if you feel that instead of initializing all the module at once, instead of consuming so much of memory, you can also initialize one module at a time. But this is a convenient method where you can just initialize all the module at once and you can use them in your program. The next is quitting. So quitting is opposite to initialization. So when you're done with using the Pygame modules, you can quit or you can uninitialize all the Pygame modules which are initialized previously. So basically it deallocates all the Pygame resources. You can do that with the help of pygame.quit. So this pygame.quit doesn't actually exit the entire program. It just deallocate the Pygame resources, and as well as it uninitializes all the Pygame modules that are initialized previously. This is the Pygame quitting, where we are just delocating, we are just uninitializing all the Pygame resources. Then next is system.quit method, exit method, system.exit method, and os.exit method. So these are some of the exit methods of the Python. Okay, so this is the exit method of Pygame, pygame.quit. So it quits only the Pygame, but it continues the program. It doesn't just exit the entire program. If you write pygame.quit, it will just uninitialize all the initialized modules, but your program will continue. But if you write exit or system exit or os exit, so in this case your program will exit. Okay, so if you want to exit your program, then you can write exit system exit or operating os.exit. So basically when your program ends the last line of code, basically your program terminates. But in case if you want to exit the program prior to that, you can use these commands. So these are some of the exit commands of the Python. So the Python interpreter exits and cleanup activities are performed when we write system.quit, exit, system.exit and os.exit. Any one of this command if you are writing, then the Python interpreter exits and cleanup activities are performed. There is a difference between pygame.quit and these four methods. So pygame.quit just deallocates or uninitializes the pygame module, and this 4 actually exits the entire Python program. So these are the first two pygame basics, that is initialization and quitting. Now let's understand this display module in detail. So when you want to set the screen, when you want to set the window, in that case this display module helps us. So basically it controls the screen and window. So there are different methods which are available in the pygame.display. So these are the list of methods: init, quit. So these are the methods. So I have shortlisted some of the methods which are generally used in any pygame. You can say these are the mandatory methods which you have to use in your display. Apart from this, which is pygame.display.setCaption, these are the basic methods like init, set mode, update and quit. So these 4 methods are very basic and you have to use it in your game application. I'll explain you all the uses of this different methods, as well as I'll give you a brief about these methods. So the first method is pygame.display.init method. Init is again an initialization method. So whenever you want to initialize any module in the pygame program, you can do that with the help of init method. So there is a shortcut. For example, if you just write pygame.init, it initializes all the methods, all the modules in the pygame are initialized. But if you are writing specifically like pygame.display.init, it just initializes the name of the module which is given here. Okay. So if you have not written pygame.init at the start of the program, then you have to write pygame.display.init to initialize the display module. The another important thing is pygame.display.setMode. So setMode method is used to set the size of the window, the color of the window. So with the help of the setMode, we set the window. Here the size represents the width and the height of the window. So here 200 and 300 are the size of the window. This is the width, this is the height, and this is a tuple. This is given in the form of a tuple. If so, in the tuple we pass 2 arguments, which is width and the height, as well as these are some of the optional parameters which you can pass. Depth represents the color of the window. You can set the color. Then the another parameter is pygame.display.update method. So this method is used to update the screen. So there are 2 methods basically, pygame.display.update and pygame.display.flip. Flip is used when you want to update the entire screen, and the update method is used when you want to update the specific areas of the screen. So these are the methods which updates the screen. Then next is pygame.display.setCaption. So setCaption is used to set the title of the window. So for example, if you want to set the title for your window, for example, my first game, if there is some game name, you want to show that game name in the top, at the top of the window, then you can do that with the help of the setCaption. The another is pygame.display.quit method. So like it is opposite to initialize method. With the help of init we initialize this, and with the help of quit we uninitialize it. So this quit method deallocates all the resources which are acquired by the pygame, and basically uninitializes all the modules which are initialized. It just doesn't quit the entire program, but it just deallocates or uninitializes the modules which are initialized previously. Okay, so these are some of the basic, or you can say mandatory methods which we have to use for the pygame. So let's see some other methods which are here. The first method is pygame.display.init. So I have already explained you, which is used to initialize the pygame. Pygame.display.quit, which is used to quit the display, which is used to uninitialize the display mode. Then getInit method. GetInit method is used. It returns true if the display module is initialized. It returns false if the display module is not initialized. SetMode method is used to set the window or the screen. Then the getSurface method is used to get the reference of the currently set display surface. Then flip method is used to update the entire screen, and update method is used to just update some portions of the screen. Then this is the method which is used to get the name of the backend pygame drivers. Then this display information gives us the information about the object it creates a video, a display information object. There are different methods for different purposes, like set caption is used to set the caption for the window, and get caption is used to get the caption of the window. Set palette is used to set the color palette for indexed displays, and window size is used to return the size of window or the screen. So these are some of the methods which are there in the display module, and these are some of the basic methods or the mandatory methods which you have to use for creating a game. Now let's understand about events, states and loops. The event handling in the Pi game is performed with the help of class which is events. So event is a class that contains or stores information about all the events which are happening in the Pi game. So event is a Python module, and pygame.event. These are the different methods which are used to control the events. Now, what is state? So game state is updated each and every time. So you can update the game state, which is used to basically track the progress in the game. For example, if there are two players, then you can track turns of the player, then positions of the player, as well as points of the player. And if there are different stages in the game, then you can track the stages in the game as well. For example, if the user just pauses the game for some time, so basically you are saving the state of the game. So handling the state of the game can also be performed with the help of this event class. So event handling is performed where the screen is updated based on mouse clicks and keyboard presses. So to get those events, we use pygame.event.get method. So this is the first method, which is pygame.event.get method, which is used to get all the events which are happening a background. For example, on the screen, if you are clicking, if you are just hovering the mouse, or if you are pressing the keyboard, so a queue is created, and in that queue these events are logged one after the another in a sequential manner. So to get all this event, pygame.event.get method is used. So this is the first method which is used to save all the events. In this way, we can also get the status of the game as well. So Pygame also has some other logic based on that, and it updates the game. So whatever the logic we write that logic in a loop. So with the help of for loop, we can get the status of the game. So here you can see for event in pygame.event.get. So this method is basically used to get all the events. For example, someone is clicking, someone is just pressing the exit button or anything. So all the events are logged here, and with the help of for loop, we can iterate all the events, possible events, and thus we can take action. So pygame.event.get method is used to get all the events which are happening, and then according to that we can perform the event handling. When user perform any action such as mouse click or keyboard press or just hovers mouse on window, pygame event object is created to record this particular event. So whenever we perform any action, the event is created, and one object is created which stores whatever is happening. So this event is created with the help of another method, which is pygame.event.event. So this is the method which is used to create the event object, so that all the actions are recorded in that particular object. And to check all the events which has happened, we call this method which is pygame.event.get method. So to record any event, we use pygame.event.event, and to check, we use this pygame.event.get method. So for loop is used to iterate to the list of event. So basically a list of events are created, and based on the sequence of event, list is created, and if no events are logged, then blank list is returned. For example, if there is no action, then in that case the blank list is written. Similarly, there are different types of methods which are available. So another one is pygame.event.event type. This is the another method, pygame.event.event type. So this method is used to tell us the type of the event. So based on that, we can take the action. For example, if someone has pressed the quit button, or if someone just closes the window, so there are certain types which are already there in the Pygame. We can just do some matching with that with those events, and we can take action. So there are different event types as well, so which are there in the Pygame. So this event types helps us to filter out some events. Other methods are listed here. So there are different methods, like first is this is the event.poll method, and this method is used to get a single event from the queue. Another event is set allowed, set blocked, and set allowed. So these set blocked, set allowed methods are basically used to filter the events. For example, if you want to block certain events, if you don't want to see those events, you can do that with the help of this method. So we can block certain events from the queue to improve the performance. So in case if you want to improve the performance, if you don't want to check all the events from the queue, you can do that with the help of set blocked and set allowed method. So this pump method is used to handle all the internal actions which are taking place. And as I said, poll method is basically used to get the single message from the queue. For example, if you want to just clear out the entire queue, then clear method is used. So these are some of the methods which are used. For example, if you want to get the name of the event, then you can get that with the help of event name. The string is returned, so you will get the name of the event. And there are many more options, methods which are available. So this is all about events. So this event handling are performed with the help of the event class. Now the another thing is loop. Now the loops in Pygame. Each and every concepts are interrelated to each other. We just learned what is event handling and is how to update the screen. You can update the screen with the help of pygame.display.update method. But why we should update the screen? For example, if player 1 score is 3 and if that player qualifies for the next stage, then we have to update the screen, right? So basically first we learn what are the events which are happening. Based on that we update the game, and based on that we update the screen. So this event handling part is performed with the help of event class, and this screen is updated with the help of pygame.display.update methods. So whether you want to update the entire screen or the part of screen, for example, if you want to update the entire screen, then you have to use the flip method, and if you just want to update the part of the screen, then you can use just update method. So this event part and display. So you can just now see how there is a relationship between the event handling and the display screen. Okay, so whenever the event happens, the events are logged in the queue. Then based on the events, the game is updated, and based on the game, the screen is updated, the display is updated. And this is a kind of a loop which occurs in a game. Okay, so this loop continues until the game is terminated. So here you can see that for any event to occur, you need the event class. If you want to check what are the events, we use the for loop to check the events, and based on that we take the required action. Now we will start with the second chapter, which is Pygame basics. So I will take one program, and with the help of that program, I will explain you how to set up a Pygame program and some of the important steps to create a Pygame program. So let's start with Pygame basics. And here we will learn how to set up the Pygame program. So we will learn the structure of Pygame program, how to write a code for it, and also we will learn some of the basic commands, or you can say the basic structure of the game. Now first, for any program, the first step is we import the necessary modules. So here we are going to import the Pygame. So this is the first step. Now Pygame is a module which is basically designed for creating video games, and it has different features, like you can add colors, animation, music, graphics, fonts. So these type of all features you can add to your game, and you can make your game more attractive. So all these features are there in the module Pygame. So first step is we will import the Pygame. Now after importing the Pygame, we need to initialize the Pygame. So basically we initialize this Pygame because it initializes all the Python modules. So whatever features you want to use in the Pygame, if you want to use that, you need to initialize them. Instead of initializing all the different modules one by one, we can do that with the help of pygame.initialize. So it initializes all the modules, all the features which are available in the Pygame. This is the very important step in the Pygame program structure, that you need to initialize the Pygame module. So this is the important step. So first what we did, we importing libraries, and the second step is program Pygame initialization. Now after initializing the Pygame, this is the steps which you have to write in each and every program. This step, Pygame initialization and importing library. Now after initializing the Pygame, we are going to create a display. So whatever things you want to put on the display, you can do that. So we are going to create a window, and on that window we will draw different things, we will put different functions. So let's create one window. So to do that, need to write the variable name game display, game d, and I'm going to use the Pygame library, which is pygame.display.setMode. SetMode is the command to set the resolution of the window. Okay, in this set mode you have to pass the tuple. So in this tuple we are going to pass the width and the height of the window. So 800, or for example let's take 400, 200. So this is the height and the width and the height of the window. So our window will be 400 pixels wide and 200 pixels tall. Okay, so this double round bracket indicate that we are passing these two value as a tuple. If we don't pass this two value as a tuple, it will treat both of these parameter independently. So that's why we have to pass these two values in a tuple. Okay, so after setting the resolution, we are going to set the title for our display window. For example, if you are creating a game, then you need to write something on the window. Okay, so for that reason, I'm going to create a caption. So here in the Pygame, like in Python tkinter, there is a method which is called as set title. So that title method helps you to write a title on the window, but in Pygame, there is a caption. The name of that method is caption. So where you want to put that caption, I want to put that caption on the display. So pygame.display.set caption, and here in this round bracket you can give the name. For example, my first game application. Okay, now what we are going to do is we are going to set the clock. So to track time within the game, we use game clock, and this game clock is works like frame per second, so that we can tweak this value later. Basically this clock parameter is used to set the timings in the game, to set the frame per second parameter. If you want to speed up game or if you want to slow down the game, so with the help of clock parameter you can do that. First what we are going to do is we are going to set the clock parameter, and then we are going to tweak its value. So based on that value, the game will slow down or game will gain a speed. Okay, so in this way you can also track the timings within the game, and you can trigger certain event based on the timings. So for that reason the clock is basically used. So I'm going to create one parameter which is clock, and pygame dot time method is used, and here from time I'm going to use clock. Okay, so sometime you can also use this tab in the Jupyter to auto complete some syntax. For example, I'm going to press tab now. So see, it gets auto completed. So instead of remembering all the syntax, you just need to remember some of the methods. Okay, now the next thing is we are going to create some variable which is stop, and we are going to set its value to false. Okay, so what we did till now, we first imported the libraries, then we started our Pygame program with the help of initialize method, then we set the display, then we set the title For the window, set clock. Okay, I will tell you the use of this clock later. Okay, as well as we have created one variable and value is false. Okay, now the main loop is important. So we are going to create one main loop, and in that main loop all the game logic will be there. In your game application, whatever code you are going to create now, you have to write a loop. So that loop contains all the game logic. So basically now we are studying the structure of the Pygame. Okay, so what is the structure of the program? The first thing is you have to import libraries, then you have to initialize the Pygame, you have to set the display, and in the loop you can write your business or game logic. Okay, so we are going to create one main loop, and that is while loop, and this loop will run until some event triggers or until someone closes the application. So I want to keep this loop running until someone closes it, so not stop. So this loop will run unless it is not stopped by someone or by some event. Okay, so I want to keep this loop running. Now after creating the loop, we are going to write some event like for event in Pygame dot event dot get. Okay, so Pygame dot event dot get. So this method is used to get the events, whatever events are running. We can get those events with the help of this, and with the help of for loop we can check that whatever events are there which are running in background. So it is a kind of a queue which is created. This queue is checked with the help of the for loop. So after checking all the events in the for loop, for is again one loop for events in event dot get. So this is kind of a queue. I'm going to check all the events with the help of for loop for event in this queue. I'm going to do if any of the event type is equal to Pygame dot quit. Okay, then I'm going to change the value of stop to true, and I'm going to exit the application. So what I'm doing here is, for example, if any of the event in this event queue is equal to quit, this is the method, this is the type of. So for example, if any of the event is equal to quit, then we are going to change the value of true and this loop will terminate. Okay, so whatever the events are happening in the background, we are going to check those events one by one with the help of pygame.event.get and this for loop. And if any of the event type is equal to quit, then we are going to change the value of this stop and we are going to terminate this loop. Okay. So you can also check print all those events. Whatever the events are happening in the background, you can also check those events with the help of the print statement. We are going to update the background. Okay. So this update parameter is basically used to update the specific area of the screen. So if you want to update your parameter after some time, then you can do that with the help of pygame.display.update. So there are two methods which are basically used to update the screen. One is update method and another one is a flip method. So this is pygame.display dot see, there is one update method and you can also use flip method. Flip method actually updates the entire screen and update parameter only updates the specific area of the screen. So if you want to update the entire screen, you can use flip, And if you want to update the specific areas of the screen, then you can just write the update statement. And then you can set the timing. Like for example, if you want to update the screen after some specific time, like for example after 3 frame per second or 4 frame per second, so you can set that value here as well. So this is the parameter where you can set the value where you want to refresh the screen. For example, if you want to increase the speed of your application, if you want to increase the speed of the game, then you can just set the update speed to 40 frames per second. So basically human eye perceives 25 to 30 frames per second. So according to that, you can set the display. Like if you want to 40 frames per second, then you can do that with the help of clock.tick method. So as per your need, you can set the frame per second rate. And then finally, we are going to quit the application. So to quit the application, we will write pygame.quit, which is again an inbuilt method. You just need to call that method to quit the application. So this ends the pygame instance. So whatever the instance we have created here, we started the pygame application, like we created the instance for the pygame. In the similar way, we need to kill that instance, or we need to stop that instance. So this quit exits the Python application. Okay. And also you can write quit to quit the program. Okay. So in this way, we have created one pygame application. So now let's run this and check what output we get. Invalid syntax. So this is the window. Okay. We got error. That is clock error. Pygame.time has no attribute clock. Okay. So this C should be capital. If you want to refresh this page, or if you want to restart the kernel, then you can do that. Just press kernel here and just restart, and it will kill the previous instance of the program and it will start fresh. Okay. As well as there is one more option like restart and clear output, so that this output will be gone. Okay. Now run this. See, finally, these are the events which are happening in the background, and we are getting these events here. We are getting the log of these events. So this is the window. Now I'm going to hover my mouse on the black screen here. See, these are the events which are happening until and unless I press this cross button. So it will take the log of the events. So in this way, we have created our first window. This is the caption, my first game application. This is the window, and as I'm hovering mouse over the screen, the events are getting logged. And if I press this button, see, the last event is quit event. Okay, because I pressed the cross button. So in this way, you can log different events and you can keep track of the events, whatever the events are happening, and you can trigger some functionality based on this. So in this way, you can create your first program structure with the help of pygame. And in this way, we have set up our first pygame program. Now let's understand the drawing primitives. So we are going to learn about python.draw. So there are different drawing primitive like lines, rectangles, polygons, circle, ellipse. So these are the different primitive functions we can perform with the help of Python pygame. So if you want to draw a line, rectangle, polygon, circle or ellipse, there is a defined syntax. With the help of that simple syntax, we can create drawing. So there are different functions which are already present, like pygame.draw.rect for drawing the rectangle. To draw a polygon, we have pygame.draw.polygon. Then to draw circle, we have pygame.draw.circle. Same for ellipse, arc, lines, For single line, we can use pygame.draw.line, and for multiple lines, there is pygame.draw.lines. Okay. So these are the two different types of line, that is AA line, which is known as anti-aliasing line. So what is anti-aliasing line? Anti-aliasing is generally used in fast game so that curved edges, shadows, filters look smooth and realistic. For example, if you want to draw a smooth line, in that case, we will use AA line, anti-aliasing line. So when high resolution images are presented in a low resolution, then these lines are basically used. And aliasing means stair step line or jagged object or edges. When the line is smooth, it is known as anti-aliasing, and when there is a stair step lines, then those lines are called as aliasing lines. Okay, so when we want to draw a smooth line in our game, so that it should look smooth and to get a good graphics, we will use AA line. Now these are some basic syntax of rectangle, polygon. So we will go through this syntax and then we will start with the code so that you will better understand how to use this different functions. So the first is rectangle. So pygame.draw.rectangle. So this is the syntax to draw a rectangle. So in this parenthesis, what are the different arguments which we need to pass? So the first is the surface. So surface is the screen surface on which we are going to draw certain object. So first we need to pass the screen surface. Then the second thing is we are going to pass the color. So either here you can directly write the name of the color, or you need to pass the tuple of the RGB format. RGB means red, green, blue. So three color coordinates you have to pass here in the form of tuple. And then we will pass the rectangle object which takes the two arguments, and then line is optional. Okay, so then we need to pass the position and dimensions of the rectangle, and then the last parameter is width. Width is optional. So basically this width is used when we want to fill the rectangle, and there are different functions, like if width is equal to 0, it fills the rectangle. If width is greater than 0, it is used for line thickness, and if width is less than 0, nothing will be drawn. So whenever we want some hollow rectangle, in that case we use width, and when we want the solid rectangle, we don't use this width function. Similarly for polygon, the first parameter is the surface, which is the screen surface. The second parameter is the color, in which color we want our polygon. So here we can pass either tuple RGB format, or we can directly write the name of the polygon, and then we will pass the points through which we want to draw a polygon. Basically polygon is the enclosed area, so points should be more than 3 or more than 3. So you have to pass the coordinates either 3 or more than 3. And similarly the width is the optional parameter. If you want to fill the polygon, then width is 0. If you want to use the line thickness, then width is greater than 0, and if it is less than 0, nothing will be drawn. The next is the circle. To use circles, we have pygame.draw.circle method. Here again we will pass certain arguments here. The first is the screen surface, like where you want to draw the polygon, so that is the surface. Second is the color, which is the RGB format. You can pass tuple or the name of the color. Then the next is the center, and then radius. And again the width is optional parameter. So when you want to, that width is used in case of solid circle or only the hollow circle. So width parameter plays that role. The next is pygame.draw.line. So line is drawn with the help of this function, and here again some parameters are passed. First is the surface on which we want to draw the line, that is the screen. The second is the color of the line. Then we have to pass the starting position of the line and the ending position of the line, and then width of the line, thickness of the line. Then arc, we can draw arc or tick arc with the help of this function. Surface, color, then rectangle coordinates, and then the starting angle and the stop angle. Okay, to draw a rectangle, we have to pass the screen surface on which we want to draw the arc, color of the arc. Then these are the rectangle coordinates, 4 coordinates we need to pass, x and y, and starting angle and the stop angle. So these are some of the basic functions of line, rectangle, polygon, circle. Now let's see how to use these different functions, different graphics primitive in our code. One more parameter which is remaining is ellipse. So let's see that one and then we'll start with the code. So basically here in the ellipse parameter, it is same. There is no such difference as such. Here first thing is we will pass the surface on which we want to draw the ellipse. Then the color tuple, like which color we want, RGB tuple. And then the rectangle parameters. And then the optional line width if stated will be drawn, or a hollow ellipse instead will be drawn. For example, if you want to draw the hollow ellipse, then we don't need to pass the width parameter. But if you want to draw the filled ellipse, solid ellipse, then in that case, the width parameter value is changed. So these are some of the basic drawing primitives. Now let's start with the code and let's understand how to use these different graphics primitives. So I'm going to create a new file, and in this file I'm going to write a code for drawing the graphics primitive. Now let's start with the code. So we are going to write the code for drawing primitives. So let's rename. Now the first step is we will import the necessary libraries which are needed to draw the various shapes on the screen. So first library is Pygame. After importing the Pygame, it's very important to initialize all the modules within the Pygame. To initialize all the modules within the Pygame, we write pygame dot init method. Okay, so you can also initialize one module at a time, but if you write python.init, it will initialize almost all the modules in the Pygame. After initializing all the modules in the Pygame, we will create the display. We will create the display for our game. Okay, so let's create the display. So for that, first we need to set the size of the display. So let's create the size of display. So this is the size of our display, and to create a display there is a method which is pygame dot display. Okay, so we are going to create the display which is equal to pygame dot display dot set mode. Here we are going to pass the size of our window. So this is the parameter which we have passed here. You can also set other parameters also. So if you want to check any parameters, then you can also do that with the help of the tab. So tab is basically used to auto complete any of the command. So this is the command to set the screen, to set the surface. Now after creating the display, now let's put the title on the window. To put the title, we have another method which is set caption. So this set caption method is the method of display function. So pygame dot display dot set caption. Okay, so with the help of set caption we can set the title of the window. So you can give any title. I am giving drawing primitives. Now after creating window, setting the title, now it's time to create the main game loop. So this main game loop contains all the logic of our game, all the drawing primitives. So whatever logic you want to put, you can put that in the main logic. First we will create two variables, that is finish. We will set this variable to a boolean value false, and we will create another variable which is clock, which is used to update the screen. So this clock basically provides us frame per second rate. So after the frame per second, the screen gets updated. Whatever the value we have set for the clock, after that much amount of time, the screen gets updated. Pygame dot display, pygame dot time dot clock. So we are going to create the instance of the clock. After setting the clock, we are going to write the main game loop while not finish. So this loop will run until the value of the finish is false. Okay. So this loop will run until someone terminates the program. When someone will terminate the program, the value of finish will change. So value of finish will change to true, and then this loop will break. Okay. The next thing is, we are now going to check the events. So whenever someone performs some events, we need to check that whether the event is properly triggered or not. So we are going to check each and every event. So whenever the quit event happens, we are going to shut down the program. We are going to close the program. So for that, we need to check each and every event. So we are going to write the loop, which is for event in pygame dot event dot get. So this pygame dot event dot get method is used to get all the events. So whenever we hover a mouse on the screen, whenever we click something, whenever we presses a keyboard button, so these are all the different events which gets queued. So in a queue, these all events are lined up according to the sequence, and with the help of this for loop, we can check each and every event and can take actions accordingly. So if someone presses exit button, quit button, or if someone just closes the window, so we can check the type of event also. So if event dot type is equal to pygame dot quit. So quit is a constant which is used in the pygame. So if someone presses this button, then the application will get closed. So this application will be closed if and only if this while loop is terminated. So if you want to terminate this while loop, then you need to change the value of finish. So this loop will terminate only if the value is changed to true. So whenever this quit constant is called, in that case we are going to change the value of finish to true. So whenever the quitting events occur, then we are going to change the value of true, which will terminate this loop and our application will get closed. Now, you can also set the clock tick. Okay. Here we are basically setting the frame per sequence. So after how many frames you want to update the background. So in this way we set the frame per second rate. So after 20 frames per second, our background will get updated. Now let's clear the screen and set the screen background. Now let's clear the background and set the background color. So we can do that with the help of screen dot fill, and here we are going to set the color which is black. Okay, you can choose any color. Now whatever the code we will write for drawing primitives, we will write it outside the for loop, but we will write that code inside the while loop. So we will continue from here. So let's draw some of the shapes. So let's start with rectangle. Okay, so the syntax: pygame dot draw dot rectangle, and here we are going to pass some parameters. The first parameter is the surface on which you want to draw the rectangle. Now our surface is this. We have created a display like pygame.display.set mode and we have passed the size. This is our screen. Okay. So I'll change the name of variable. I'll keep it simple, DISP. So this is the surface on which I want to draw the rectangle. So first you need to pass the surface. The second thing is you need to pass the color. So either you can pass the tuple like 0, 255, 0, or you can directly write the name of the color which you want to use. Okay, so I'm just going to write the name of the color here directly. Then you have to pass the x and y coordinates for the rectangle. Here we are going to pass the top left corner and bottom right corner coordinates. So let's pass any coordinates for now. Okay, so after setting the coordinates, then you can also pass the width. So this width parameter allows you to create a hollow rectangle. And if you don't pass this width, then the solid rectangle will be created. Okay, so we are going to create two types of rectangle. One is hollow and another one is solid rectangle. So here we are going to draw the outline of rectangle only. Okay, and the another rectangle we are going to draw is the solid one. The syntax will be same, but we will change the coordinates as well as the last parameter, which is width, will be removed. So if you want to draw a solid rectangle, then just delete this value, and by default the width is set to 0. Okay, so when we pass the value which is greater than 0, in that case the outline of rectangle is created and it is not filled properly. Now change the values so that we get this rectangle at some other location. 160, 20, 70, 30. Okay. So in this way we have created two rectangles. One is outline rectangle and another one is solid rectangle. Now let's create another shape which is ellipse. So let's comment out ellipse. Okay. So to draw ellipse, we again have to use pygame.draw.ellipse. And in this ellipse, we have to pass the same parameter. The first one is the surface screen on which you want to draw the rectangle. That is the display. The second thing is you can set the color. So I want white color. And then you have to pass the rectangle coordinates here. Okay. So let's pass. You have to pass the 4 rectangle coordinates. Okay, so after passing the rectangle coordinates, the ellipse will be drawn accordingly. And if you want to draw a solid ellipse, you know what you have to do now. You have to just change the value of the width. If you keep the value of width greater than 0, then you will get the hollow ellipse. If you don't set any value, if your width is equal to 0, then you will get the solid ellipse. Okay. The next thing is we will draw a polygon now. To draw the polygon, we have to follow the same procedure, which is pygame.draw.polygon. And here we are going to set the value of polygon. The first is the surface. I want to draw a polygon on a display, which I have created now. So the value is DISP. The second thing is I need to pass the color of polygon. So I want to set red color, or you can use any other color, like for example, yellow. Then you have to pass 3 or more coordinates. So polygon is basically an enclosed area. So there should be 3 or more coordinates. So polygons are triangle, hexagon, pentagon. So these are all polygons, enclosed area. So you have to pass the coordinates more than 3 or equal to 3. So I am going to draw a rectangle. So that's why I'll pass the 3 points. So you have to pass that 3 points in the square brackets in the form of a least, like 100, 100. This is the one coordinate I'm going to pass. Another is 0, 200, and third is 200, 200. Okay. And in the similar way, you can change the width size. So I will get a hollow triangle in this case. Now let's draw circle. To draw a circle, we have to use pygame dot draw dot circle, and here you need to pass the first parameter is the screen surface. So this is display. Then set the color. Instead of writing the color name, I'm going to write the color code. So let's try this color. Okay, so basically this is a tuple which is RGB format. So this is R, G and B. So you can set the values accordingly to get the color. Now another parameter you need to pass is the coordinates, the radius, and then finally you have to pass the width. Okay, so center point and radius we are going to pass. Now the next thing is we are going to draw a line. So basically to draw a line, we can create different types of line. So there are anti-aliased line. So anti-aliased line means smooth lines, and aliased lines means the jagged lines or stair step lines. So if you want to create a normal line, then we will go for pygame.draw.line. So line pygame.draw.line, and here first thing is I need to pass the surface, then I need to set the color which is blue, then I need to pass the starting point and the end point of the line. So starting point is 0, 0 is the first point, and the next point is for example 20, 30. Okay, and width parameter which is optional. In the case of circle, this is the center point and this is the radius. So I'm going to change the radius. Okay, this is the center point and this is the radius. So this is the line parameters which we have set. So it will draw a line for us. The next type of line is if you want to draw a multiple contiguous lines, then you can do that with the help of pygame.draw.lines. So with the help of this, you can draw the multiple lines but which are contiguous. Okay, so let's copy paste this and we will do some changes in the code itself. So write here lines and pygame.draw.lines. Okay, so display dot comma, now just change the color here. I'm going to draw this white line, and if you are going to pass more coordinates, then you have to pass it in the double square brackets. So this is the first point, this is the second point, and let's write one more point here. Okay, now after drawing the multiple lines, we are going to draw now anti-aliased lines. Anti-aliased lines means the smooth lines. So if you want to draw the smooth lines, then we can do that with the help of the AA-lines function. So anti-aliasing is generally used in fast game so that curved edges, shadows, filters look smooth and realistic. And also we can avoid the stair step lines or jagged objects or edges. Okay, so AA lines, anti-aliasing lines. So the syntax is pygame dot draw dot AA lines, and here the first thing is surface, the another thing is the color, the next thing is we need to pass the coordinates of the line. So let's draw a straight line. And set the boolean value. Okay, so these are the different parameters which we have set to draw a line. And this is not capital, it should be in small letters. Okay, now finally let's draw the last primitive which is arc. So again we can use pygame.draw.arc, and here we are going to pass the parameter. The first thing is we are going to set the screen, then we are going to set the color. So I'm going to use yellow color. Then you have to pass the rectangle coordinates like x and y coordinates here. So let's pass any coordinates. And then finally, we are going to pass the angle like start angle and end angle for the rectangle. So this is the start angle and this is the end angle for the rectangle, and again the width parameter, which is optional. Now finally, we must need to update the background in the while loop if you want to check the output. So update the screen with what we have drawn. So this must happen after all the drawing commands are done. So this screen will update according to the clock ticks. So the clock tick is 20. After 20 frames per second, the screen will update. So there are two parameters to update the screen. First is the update and another one is the flip method. So you can use any one of these. So if you want to update the entire screen, go for flip. If you want to update just some areas of the screen, then go for update. So it is actually present in the display class. And then finally we are going to quit the game. So pygame.quit method not only just quits deallocates the resources which are acquired by the pygame, and it also uninitializes the models which are initialized before. And at the end you can also write the quit command to exit or to close down the program. Okay, you can also remove this. So this is the program which we have created for pygame. Now let's run this code and see what happens. We got first error, which is unexpected intent. Let's run this. We got another error, which is set mode. So underscore should be there. Let's run this. Name screen is not defined. I have used screen somewhere. Screen.field. Yeah. It should be display.field, not screen. So close this because it's... So in this case, you can restart and clear output and again run the program. Okay. So we got the output here. It's not responding. So let's restart it and check the output. Black is not defined. We are getting this error because we have not defined the color. So first we need to define the color codes as well. So let's define the color. So the color code for the black is 0, 0, 0. The next is for white. The color code is 255, 255, 255. This is the RGB format. We are creating a tuples. Then let's set the value for blue, which is 0, 0, 255. Then red is equal to 255, 0, 0. Okay. So now let's try to run this one more time. First we will restart it. We will clear the output and then we will run it one more time. Let's run it. We got the output. We need to restart kernel. Green is not defined. Okay. So we need to define the green color as well. Let's restart and clear output. See, this is the output which we got. We got ellipse, circle, this is the solid circle, rectangle, solid rectangle, line, this is the smooth line. So this is the AA lines which we have drawn, anti-aliasing lines, and this is the normal lines. Okay. So in this way you can create different color codes and for the graphics, and you can create the drawing primitives. Okay. So as I clicked the cross button, this function gets invoked, which is pygame.quit, and the program terminates and the modules are uninitialized. Now let's learn about the pixel coordinates. So whatever the image or objects we draw on the surface is not moved actually. The value of the pixel is changed if you want to change the color, and if you want to move the object, the pixel are shifted from the previous position. For example, if I want to move an object from coordinate 00 to coordinate 10, in that case, the pixels are shifted from 0th position to 10th position, and the image which is at 0th position is erased. So in this way, we move image or object from one position to another position by just shifting the location of the pixel and erasing the previously drawn picture. Now let's learn about how to use this pixels to move the object, as well as how to add objects on the surface. So first, we need to create a screen. So we create the screen with the help of the display method, and then to put an object or the image on the particular location on the screen, we use blit method. Blit function is used. So the function is blit, and in this blit function, first we pass the background. Background means the display surface which we have created on which we want to put that object, and we pass coordinates x and y. The coordinates x and y are basically in the form of a rectangle which we pass. So to position an object on the screen, we need to tell the blit function where to copy image on the screen. So for that purpose, we pass x and y coordinates of the screen. So Pygame has a container which is a rect container, which represents the rectangular area in this coordinate that helps us to move and position the objects. So this is the rectangle function which we are going to use to move and position the object. So we specify the left position, the top position, width and height. So here you can add all the four these parameter and you can create a blit function. So in graphics, blit means a block of data which is copied or moved in memory to animate the 2D graphics. So that is the meaning of blit function, which quickly moves the object and creates some kind of animation. So here x and y is the position inside the window where we want to put that object to the top left of the surface. Now let's see how to create a blit function and how to put the object on the background. The steps are, first we will create the screen, that is the display surface. So there is a method which we have learned like pygame.display.setMode. With the help of that we can create a display surface. Then we will create the object, like for example, if you want to put image on the screen, or if you want to put rectangle, circle, line, or your some game players or some object, any object, then you need to create that object. For example, if you are creating a game for cars, then you need to create the cars and you have to put that cars on the screen. Okay, so that is the object. Now the third thing is, after creating the object, we need to copy that object to the surface of the screen. Okay, so we can do that with the help of blit method. So just creating the object is not enough, you have to copy that object to the surface also. And the last thing is, we need to update the display to show it. So to show the display surface object on Pygame window using display.update method. So there are two methods to continuously update the display. The one is display.update and another is display.flip method. So in this way, now we are going to build one small program using the blit function to put the object on the surface of the screen. Now let's understand the blit function with the help of a program. Now we are going to create one surface, and on that surface we are going to put two objects. So first thing is we will import the necessary libraries. So we are going to import the Pygame, which contains all the modules for the game development. After importing the Pygame, the next step is we are going to initialize the Pygame. So with the help of this step, we initializes all the modules in the Pygame. If you want to initialize the individual module, then you can also do that by just specifying the name here. But if you directly write pygame.init, it initializes all the modules in the Pygame at once. The next thing is we will create a window and we are going to set the parameters for it. So let's create a display and let's set a parameter for the display. So we need to create a tuple, and in the tuple we will pass the x and y coordinates. Creating the window, we are going to pass this size to the pygame.display.setMode function. So screen is equal to pygame.display dot set mode, and here we need to pass the size. The size is this. So let's change the name here. I'll give size. Now we have created the canvas on which we want to display everything. Okay, so these are the two steps to create a canvas, and on this canvas we are going to put different objects. Now after creating the canvas, now let's create a background on which we want to put these objects. So now we are going to create a surface with the same size. Okay, so we need to create a surface on which we want to put these all objects. So let's create a surface with the help of pygame.surface, and here I'm going to pass the screen. Okay, now after creating the surface, now let's create another surfaces. Surfaces means objects. Now we are going to create some objects, and those are also called as surfaces only. Okay, so let's create a surface or the objects to be displayed on the background. Okay, so let's create different objects now. So create objects. So first is pygame dot. You can use any drawing primitive here, or you can also load image. For now we will use some drawing primitives, like I'll draw the rectangle. So here you need to pass the surface on which you want to draw the rectangle. So this is the surface which we have created. I'm passing that surface here, and I need to specify the color. So let's use white color. White color means 255, 255, 255. It is the RGB format. It is a tuple. And then you need to pass the coordinates here. You can pass any coordinates. The next thing is we will draw the circle. So pygame dot draw dot circle, and again first parameter is you need to pass the surface on which you want to draw your object, and the next thing is you need to specify the color, and finally you need to specify the radius and the center position. Now After creating the two objects, now what we are going to do is we are going to put these two objects on the surface. To do that, we will use the blit method. Screen.blit. So blit method is used. Now what I want to put the surface on the screen. So let's pass the surface here, which we have created, and you can specify the position here, x and y coordinates. So you can specify any position, or you can specify 0th position. So pass the x and y coordinates. The last thing is, now the blend surface is created. Now update the display. To update the display, we will write pygame dot display dot flip. Flip method is used to update the specific areas of the screen. If you write update, then also it's okay, but it updates the entire area of the screen. So according to the computation time, flip method is better than the update method. And also it depends on how you want to update your screen. Now we need to create one while loop so that we can iterate through all these things, and then we can perform the event handling as well. So let's create a variable that is finish. So keep value 0. Now let's create a while loop, while not finish. So until and unless the value of finish remains 0, this loop will run. Now we are going to iterate all the events in pygame.event.get. So with the help of the get function, we are going to get all the events, and we are going to put all those events in a queue. So if you are hovering a mouse on the screen, if you're clicking, if you're pressing the keyboard, whatever you're doing, that everything will be logged in a queue, and you can get whatever the events are happening in the background with the help of pygame.event.get. Now we are going to iterate through each and every event, and we are going to check whether any event is equal to quit. Okay. So if event dot type is equal to pygame dot quit, if someone presses a quit button, then we are going to change the value of finish variable, and the loop will terminate. We will come out of the loop and the game will closed or quit. Okay, so let's quit. So if you want to quit the game, you can do that with the help of pygame.quit, and also at then you can write system.quit to close the program. So as we initialized the different modules, we can uninitialize all the modules with the help of pygame.quit. So now let's run this and see what happens. Invalid syntax, for loop. We got error. S is capital. Size needs to be in width and height. We need to pass the size here. I passed screen, so I should write size. See, we got the output. We got circle and rectangle. Now if you want to change the position of these two rectangles and circle, then you can do that by just changing the size here, coordinates here. Run. See, the coordinates are changed. So you can also dynamically update the coordinates of the blit function, and you can move the object on the screen as well. So in this way you can use the pixel coordinates to put the object on the surface, and you can also animate that. We will learn it in the next chapter. Python game development training, intermediate level. In this tutorial, we are going to learn Python game development using Pygame, and the level is intermediate. The difficulty level of this project is intermediate. To do this project, you must have the following skill set. You must complete the beginner level first. You should be clear with Python basics, and programming knowledge is expected. The objective of this course is the students will understand the features of the Pygame. They will understand the implementation of advanced graphics. They will also be able to develop a mini game application. What you will learn at intermediate level? You will learn how to accept the user inputs, how to create and load visuals, how to create different graphics rectangle like clip, inflate, move rectangle. You will learn about images like how to load them, move them, rotate and scale them or flip them. You will also learn about different fonts, text, cursors, different colors, and at the end we will learn how to animate the object. What are the project prerequisites? Core Python knowledge is expected, completion of beginner level, and design skills. Now, target audience is participant working in IT sector, programming and game enthusiast. By the end of the project, you will have the following skill set. You will have hands-on regarding game development. You will also learn how to implement the Pygame features. And finally, a mini game implementation. Now let's start with the first topic, which is accepting the user input. There are a variety of ways in which user can interact with the game, either by using mouse or by keyboard or by joystick. So there are different ways with which the user can give input to the program or to the game. So it's very important to poll the state of these keys or buttons to take the required action. There are two ways with the help of which we can handle these events. The first thing is we need to check the state, and second thing is we need to perform the event handling. To check the state, we need to poll the state of the keys or button, and there are different types of events which are already present in the module of the Pygame to handle the events. So by calling the function, we can check the status of the input device or the values and their current position. So we can get the current state of these input devices by polling the devices. Now there are different input modules like keyboard, mouse and joystick. So with the help of these three devices, we will take the input from the user and then we will take the required action. Now let's see what are the different modules, what are the different functions and events which are present for keyboard, mouse and joystick. The input device keyboard. So with the help of get pressed and get modes, we can get the input from the keyboard. For example, keyboards has different keys and every key has a key constant associated with it. So to identify which key is pressed, there is a special constant which is assigned to each and every key, and that constants begin with k underscore. So the keyboard constant begin with the k underscore and each key has a special identifier. So we can easily identify which key is pressed with the help of this special k underscore constant. Now there are different modules in the pygame.key. Pygame.key is a module under which there are different functions with the help of which we can get access to keyboard and we can get to know which type of keys are pressed and what are the functions are triggered. So get press function returns the tuple and it gives us the status of the pressed key on the keyboard. So whatever key is pressed on the keyboard, we can get the input with the help of get underscore pressed. Another thing is get underscore modes. So get underscore mode is used to get the status of the modifier keys. So different modifier keys are alter, control, shift, locks. So these are the different modifier key. So if you want to get the input from the modifier key, we will use get underscore mode. And if you want to get the input of just keys, then we will get that with the help of get pressed button. So whatever the keys are pressed, accordingly we will write the code for the specific buttons and we will perform the action. So all this functionality like get pressed, get modes, and there are many other functions also are all present in pygame.key module. So to access keyboard and to understand what the user is trying to interact with the game through the keyboard, we will use the module which is pygame.key. And under that there are different functions. With the help of those functions, we will manage the interaction between the user and the game. The next input device is mouse. To get the position of the mouse, there are many functions actually. So pygame.mouse is a module which contains all the different functions with the help of which you can handle mouse. So to get the x and y coordinates of the mouse position, get_pos is used. Basically, it gets the position of the mouse. It returns the x and y coordinates of the mouse in respect to top left corner of the window. When we hover a mouse on the screen, basically it gives us the coordinates. It gives us x and y coordinate. It returns x and y coordinates. So whenever you will move mouse on the screen, so this get_pos will return the x and y coordinate of the mouse. The next is get_rel. REL stands for relative. So this also gives us the position of the mouse on the screen, but it gives relative position based on the previous calls. So if you want to get the relative position, then you can use get_rel relative and it gives you the position based on the previous call. Now there are different buttons on the mouse as well. So if you want to get the positions or if you want to know the status of these buttons, we can get that. Mostly there are 3 buttons. So if you want to check the status of this button, whether it is pressed or not pressed, then we can get that with the help of get_pressed. So this is the get_pressed. So if the mouse button is pressed, we can know the status using this function which is get_pressed. So there are many functions associated with mouse, but these are some of the basic functions which I have discussed with you. So basically we are discussing the functions which are used to check the status of the input devices. The next is joystick. So if you are playing a game with the help of joystick, then there are also different functions which are used to check the status of the joystick. So get_axis. So this returns the position of a specific axis on the joystick. Then there is a get_ball. So to return the trackball x and y coordinate, this function is used. Then to know the button status on the joystick, get_button is used. And hat control status, for hat control status, get_hat is used. So these are the different functions which we have discussed for keyboard, mouse and joysticks are related to checking the status. So if you want to check the status of these input devices, these are the different functions which are present in different modules like pygame.key, pygame.mouse and pygame.joystick. You can use it and check the status and can take action accordingly. But in case if user clicks 2 or 3 buttons back to back, then there must be some order to determine the sequence of events. So that can be done with the help of event handling. So it's very important to know the sequence of event, in which order the user has pressed the keys, and accordingly we are going to take the actions. So there is a queue, and in that queue all the events get logged, and one by one the event is taken out of the queue and it is executed. Now let's understand what is event handling. So till now we have discussed how to check the status of the input devices. After checking the status of the input devices, it's very important to take the required action. So we can take the required action with the help of event handling. Now let's understand first different events which are triggered for mouse, keyboard and joystick. So whenever there are 2 events for keyboard, that is key up and key down. So key up event is triggered when the keyboard button is pressed. So if user presses any key on the keyboard, then the key up event is triggered, and then the program will know that some key is pressed, and according to that the logic will be triggered. The next is key down. Key down is when the user releases the key. So that is the key down event. So there are the 2 main events, key up and key down for the keyboard. The next event is for mouse. So there are 3 events for mouse, that is mouse button up, mouse button down and mouse motion. Now what is mouse button down? Mouse button down is when the keyboard mouse button is released. So whenever the mouse button is released, that is mouse button down, and whenever the mouse button is pressed, that is mouse button up event. The another event is mouse motion. So if you want to know the current location of your mouse, then you can detect that with the help of mouse motion event. So when the mouse is moving on the screen, you can get the location of the cursor based on the mouse motion event. So these are basically three events under mouse input device. The next is joystick input device. So again, there are different events for joystick. The first one is joy axis motion. So it tells you whether the axis is changed or not. The next is joy ball motion. So it tells you whether there is a movement, whether the ball rotates or not. Then joy button down. Joy button down is used when the joystick is released, and joy button up when the button on the joystick is pressed, and then joy hat motion when there is a changes in the hat. Similarly, you can also create your custom events. So there are some reserved ID which can be used to create the custom event in the program. We will write a code in which we will take the input from the mouse. We will draw a rectangle or a circle, and we will learn this through code now. How to accept the input from the input device. Open Jupyter, click on new and create a new file. The first step is importing the necessary libraries. So whatever the necessary libraries are, we will import that. But in our case, there is only one library, which is Pygame. After importing the library, we need to initialize the Pygame module. This step initializes all the modules in the Pygame at once, so that you don't need to initialize it individually. The next step is we will create a display for this game. To create a display, first you need to define the size of your window. So we will create a tuple, and in that tuple we are going to set the values, that is 400 by 600 or 600 by 600. Keep it as your wish. Now to create a display, there is a function which is display.setMode. First, create the variable pygame dot display dot set mode, and in this set mode we pass the size of the window. So here I can directly pass the size of window. This is the one way of setting the display. Another way is you can directly write the size here. You can directly pass this tuple here instead of creating another variable and passing it here, so that you can create the code in one line. After creating the display, we are going to set the clock now. So this clock helps us to speed up the game application and also used to update the screen, so that the screen gets updated according to the set frame per second. So whatever the frame per second rate we set, according to that the screen get updated, and for that we need this function, that is pygame.time.clock. Then we need to create one loop, that is while loop, and that loop will run until we are done. Okay. So while not done. So this is one condition we can apply, like this loop will run until some action is triggered, or we can also do like this. We can also set the value here to true and while done. So this is the another way of doing it, while done. So we are going to write the code which is try and accept So in the try block, we will put our code, and in the except block, we will put the exception code. So try. Now we want to check the status of the input devices. Before that, whatever the events happen are stored in the event queue. So we can check the event queue directly, and according to that, we can take the action. So if you are clicking mouse, if you are pressing keyboard button, if you are just hovering the mouse on the screen, these are all the events. And these all events are logged in the event queue. So you need to check the event queue first, and based on that, you should take or you should write the code. For event in pygame.event.get method. So with the help of this get, we will get all the events in the queue, and we are going to iterate through each and every event. And then we will check the type of event. So if event.type is equal to pygame.quit. So if someone terminates the program, in that case we are writing this code. Someone just presses the cross button, and if someone just close down the program, then in that case we are going to terminate the loop. Okay. But if someone doesn't shuts down the program, and if the program continues, now we want to get the position of mouse on the screen. Our use case is whenever the user presses or clicks the mouse at a particular location, on that particular location, the circle should be drawn. So for that, we need the X and Y coordinate of our mouse. So to get the current position of the mouse, it means that we are checking the status of the mouse. So to check the status of the mouse, there is a function which is known as get_position function, which gives you the current location of the mouse. So first thing is, we will check the position of the mouse, we will get the X and Y coordinate, and on that X and Y coordinate, we will draw the required object. Now we want the coordinates, that is X and Y. So here we want to get the position of the mouse. So we need to write pygame.mouse.getPosition. Now let's check the if and else part. Now let's check the event type. So if event type is equal to, now what is the event we want? We want to check whether the mouse button is pressed or not. Okay, so we are gonna check that with the help of the event which is mouse button down. So mouse button down basically tells you whether the button is released or not. So when the button is released, the object will be drawn. So mouse pygame.mouse button. So these are the different events: button down, button up, mouse motion, and mouse wheel. Okay, so button down. So if this kind of event happens, then we are going to draw the circle on that particular location. For example, this is my mouse. I am clicking here, right? So I'm clicking here. The cursor is here now. So at this position, the circle will be drawn. So for that, I need to take the X and Y coordinate of my cursor, and on that position, I'll put the object. So now let's put the object on that particular location with the help of pygame.draw.circle. And here the parameters are, first parameter is we need to pass the display, like the screen on which we want to put the object. So we have already created the display, this surface. So this is the screen where I want to put my object. Then set the color. This is the tuple which is in the RGB format. You can choose any values to get a different shades of color. Now you need to pass the coordinates. So basically in the circle syntax, we pass the center coordinates. So let's pass px comma py. Px comma py are the mouse positions. These px and py will give me the current mouse positions, and I will pass the radius. Now after getting the mouse position, drawing the circle, now it's time to update the screen. So let's write one more event which will help us to update the screen. Mouse button up and press is equal to false. Now let's update the screen. So this update function will update the screen according to the clock ticks. So we need to define the clock ticks, which is basically the frame per second rate. And after writing the try block, we will write the except block to avoid the exceptions or to handle the exceptions. Now we are gonna print whatever the exceptions are thrown, and also we are gonna quit the game in case if there are certain exceptions. And finally we are going to write the quit, which quits the entire program, and pygame.quits just uninitializes all the initialized modules, and this quit actually exits the program. So let's run this code. First we'll rename the code. Event mouse, and let's run this code. Invalid syntax. So let's check what is the error. Px comma py pygame dot mouse dot get position. We are getting this error because we have not given a proper indentation. So let's press tab here because we have written this code outside the try loop, which is wrong. So let's give some indentation and it will be fine. So let's put this entire code in the try block, and now just run the code. Okay, we got some syntax error here. Just delete it and run. And we got the screen. So this is the output. Now the use case is when I'll click on the screen, when I'll press button, then at that time the circle should be drawn. See, again I'll press the button, mouse click. So in this way you can check the status of your input device, and accordingly you can perform different events. Okay. In this chapter, we will understand about images, how to use images in Pygame, how to load them, scale them, flip them, rotate them. So there are different functions which are related to images which you can use. So when we create a game, there are so many things we need to include in the game, and images also play a very important role. So if you want to zoom on a particular area, if you want to zoom out, or if you want to rotate some object, in that case you need these basics. So we will start with some of the basic functions of images. So the first function is the load. Whenever you want to load any image in your game, for example, if you have created some character for your game, and if you want to use that character in your game and you want to animate that, then you need to load it first. To load the game, to load the image, there is a function which is pygame.image.load. And in this, you have to pass the path of your image, or you can directly pass the image if it's in your current directory. So this function loads new image from a file, and you can directly pass the name of the file or the object, and you also need to pass the extensions of the file as well. Then the next is we convert that image. So basically we create a copy and it helps to draw quickly on the screen. For that purpose we convert it. So in this way you can load image in your system. Similarly, if you have made some changes in the image and if you want to save that, then you can also do that with the help of pygame.image.save. So with the help of that function, you can save file to the disk. So pygame.image.save. With the help of this function, you can save file to the disk if you have created it in your code. Then next is the flip. Flip is used for flipping the image either horizontally or vertically. So if you want to flip the image, then you can do that with the help of flip function, and the flipping takes place based on the boolean values of x and y. So you can decide whether you want to flip horizontally or vertically. So the syntax is flip, then you need to pass which object you want to flip, that is known as surface, and x boolean and y boolean. So based on this x boolean and y boolean value, flipping occurs. So if you set x boolean true, then horizontal flip will take place, and if you set y boolean true, then vertical flip will take place. So in this way you can perform the flipping operation using the flip function. The next is the rotate operation. The rotate operation is used when you want to rotate the image either clockwise or anti-clockwise. So there the syntax is surface, the object which you need to rotate, and then there is a angle. So angle, if you give the positive, then counterclockwise rotation will be performed, and if you give negative angle, then the clockwise rotation will be performed. So this is the rotate function. With the help of this rotate function, you can rotate your image. So you can give any angle, 90 degrees, 100 degrees. So in this way, you can give any angle and you can perform the rotation clockwise, anti-clockwise based on the degree of angle as well as whether it's positive or negative. The next is row to zoom. This is basically the combination of rotation and scaling. So whenever if you want to perform scaling as well as rotation transformation, then row to zoom is used. So scale value is multiplied by the current positions of the value or the current resolution, and angle represents the degree of rotation. So this is the scaling factor and this is the angle, and both the combination transformation you can perform here. The next is the scaling. Scaling is basically zoom in, zoom out function which is basically used. So this function returns a new image that is the size of the original image. So this is 2x. 2x means it's a double scale. So whenever if you are giving image and if you want to zoom it to double its size, then you can do that with this operation, that is scale doubler. Here you need to pass the surface only and destination surface is none. Then next is Laplacian. Laplacian is used to find out the ages in your object or images, and there is an inbuilt algorithm which is Laplacian algorithm. With the help of that, age detection takes place. So this is the Laplacian, where you just need to pass the name of the object which is the surface. There are many methods which can be done on the image, but these are some of the basics functions which I have explained here. Now what we are going to do is we are going to create one program, and in that program we will load image. After loading the image, we will perform flipping, rotation, row to zoom, scaling, Laplacian. So these all operations we will perform on the image so that you will better understand how to merge this function with event handling. Because basically these functions will be performed when we will press some keyboard keys or when we will use mouse. So how to merge event handling and these functions we will learn now. So what we are going to do now, we are going to load an image, and based on that image we will perform some transformation on it. So let's start with the code. Now let's start with the code. So the name of the code is image transformation. The first thing is we need to import the necessary libraries. Import pygame, and we also need to import operating system and math. Then we will import pygame dot locals import all. Star means all. So these are the necessary libraries we will import. The next is we want to use two colors here. So I am going to use pink and black color. You can't directly use the name of color. First you need to define the tuple for the color, that is the RGB value. For example, if you want to use pink color, then you need to define the RGB value for that. You need to create tuple for that. So the value is 255, 123, 255. So this is the value for pink color, RGB. Another color is I want to use black color. The value is 0, 0, 0. So in this way you can create the color codes for whatever color you want to use. The another important thing is initialization. So we will initialize all the modules in the program with the method which is pygame.init. So this init method initializes all the modules in the pygame. After initialization, we want window, and on that window we want to put image, and then we will perform the transformation on that image. So we will create a display. To create a display, there is a method which is pygame.display.setMode, and to that set mode we have to pass the width and height of the window. So let's set the width and height of the window. First, width is 1000 and height is 640. So this is the width and height of the window. Now we are gonna create screen, and on that screen we will put the image. So to create a display, first write the name of variable, which is, let's give some other name, display is equal to pygame.setMode, pygame.display.setMode. And set mode, here we need to pass the tuple which is the width and height. So this will create a window for us of the size 1000 and 640. Now after creating this window, the next thing is we are going to load the image now. To load the image, we will use function and here we will pass the name of image. I have already downloaded one image from Google. Cartoon image I have downloaded from free stock images, which is peng.png. It's a picture of penguin. So I'm going to load that and let's convert it. Now I want to draw pink border around my picture. So for that we will get the rectangular area around the picture, and then we will draw the rectangle around the picture. So rectangular is equal to picture dot get the coordinates with the help of this function, and then we are going to draw the rectangle around the image. Pygame dot draw dot rectangle. Here pass the name of the picture which we have loaded. Set color. Then pass the coordinates which are here, and also set the width. Now after drawing the border around the picture, we will calculate the center of picture. To calculate the center of picture, we will divide the width and height by half. So width divided by 2, height divided by 2. Now whatever we are going to create the copy of picture, so I'm going to assign a new variable here. Now original picture is stored in picture variable. I'm going to copy that object into some another variable which is img, and I'm going to use that throughout the code now. Okay, now let's get the coordinates of this image. And recenter it. Okay, now we are going to create one loop, and using that loop we are going to handle all the events. But before that we also need to initialize some of the variable. The first variable is done variable, and we should set the value of this is equal to true. Then angle, and scale. Scale is 1. 1 means original. Now let's start with the loop. Now we are going to take all the events which are occurring or which has happened, and whatever the event happens are stored in a event queue. So whatever the events will happen are stored in a queue. If you want to read all those events, we can do that with the help of pygame.event.get method. So let's iterate all the event in the event queue. For event in pygame dot event dot get method. So with the help of this we will get all the events from the event queue. Now let's check the type of event. If someone closes the events, just closes the window, then the event is quit event. So if the event is quit, we are gonna stop, we are gonna break this loop and we will terminate the program. So done is equal to false, and we are gonna come out of the loop. Let's check another event, which is if event dot type is equal to key down. Basically we are going to create the events related to keyboard, and if someone presses R on the keyboard, then we are going to rotate the image, and if someone presses shift plus R, then we are going to rotate the image clockwise and anti-clockwise. We are going to set that now. So based on the modular keys and the basic keys, we are going to rotate the image now. You can choose any key. Okay, so basically first we are going to handle the event for key down. So when the key is released, what should happen? So if someone presses key and if the key is released, then we are going to check which key it is. Okay, so event dot key is equal to, so there are different identity given to each and every key, and the name of these identifiers start with k underscore. So let's, for example, if someone presses q, then we will rotate our image. Okay, so if the event dot key is equal to k underscore q, the another thing we are going to check is what is the modular key which is pressed along with the R key. Now if someone presses modular key along with the Q key, for modular key the constant is k underscore modular underscore, and then you can write the name of the modular key like alter, shift, anyone you can use. So let's use shift here, and let's change the name of this key as well. So if someone presses R key and shift key, we are going to rotate the image now. And you can also set the angle, like how much you want to rotate image when someone presses the R and shift key. So you can set the angle as well. Angle plus equal to 20 degrees. So by 20 degrees we will rotate the image, and then finally we are going to use the transformation, which is rotation plus zooming. Okay, so ROTO, row to zoom, we are going to use that, rotation to zoom. So image is equal to pygame dot transform dot row to zoom, and let's pass here picture, then angle which we have decided, which is 20, and scaling factor as well. Okay, you can also use any other key here. You can also write Q here, and instead of shift you can also write alter. So this is how you can handle the key down event, and when the key down event occurs you have to check which key is pressed, and based on that you can decide on which key you want to perform event. So here if someone presses Q key along with the alter key, then some kind of rotation will be performed. Okay, so when the Q key along with alter key is pressed, then we are going to do, I think, clockwise rotation, and similarly anti-clockwise rotation for just Q key. Now let's write another event, which is for scaling purpose. For scaling, if someone presses, let's decide one character. So for rotation we have decided Q and alter. For scaling we will use character T. So when someone presses key T, then the scaling will be performed. Now let's use it in the combination. If event dot mod and k mod is underscore, for example, shift, then let's scale the image. It's a basically zoom in and zoom out we are doing. This is zooming image, scaling image. One is multiplication and another is division. And let's set the image, which is equal to pygame dot transform dot, and again pass the name of the picture, angle, and scaling factor. For example, after performing this rotation and scaling, if you want to get the original image, if you want to bring your image to the original shape, then you have to just set the original picture. So we will change the angle to 0, scaling to 1, and we will just replace the image img with the original variable, which is picture. Okay, so else if event dot key is equal to original, if someone presses O for original, then we are going to set the original image, which is picture, then scale is equal to 1 and angle is equal to 0. Now let's do some flipping. So we can perform horizontal and vertical flipping. For vertical flipping, we will use some numbers now. To flip a image horizontally, we will use number 0, and for vertical flipping, we will use number 1. Now let's flip image. Now you can use any key. Event dot key is equal to k underscore 0. Then let's flip the image. Image is equal to pygame dot transform dot flip. And here we just need to tweak the x and y boolean value. First you need to pass a surface. Then if you write true for x boolean, then it will flip the image horizontally. And similarly, I'm going to just copy paste this code. Copy. Paste. And instead of 0 key, I'm going to use 1 key. And here, just change the y boolean value to true for vertical flipping. Now let's perform Laplacian transform. Laplacian transforms are basically used to detect the edges of the object. So else if event dot key is equal to k underscore L. If someone presses L button, then we are going to transform the image. We are going to perform Laplacian transform on the image, which is pygame dot transform dot Laplacian. Let's pass image here and the image edges will be detected. Now let's scale the image. To scale the image, event dot key to scale the image, we are going to use S, which is double scaler. So just use image is equal to pygame dot transform dot scale 2x. X is smaller and pass the image which you want to scale. So if you will press S key, the image will be doubled. The last transformation is rotation. Now we will rotate the image according to the pass degrees. Whatever degree we will pass, that image will get rotated. So if someone presses K, so here K is capital, K underscore R, we are going to rotate the image now. So image is equal to pygame dot transform dot rotate. Here pass the name of image and degrees. Now let's write the code, get the image coordinates and recenter image. So this is the code we have written to perform the event handling when any button is pressed. We have performed the required actions on the image. Now after writing this code, the thing is I have written this code outside the for loop, so I'll just use the tab button. So let's copy this entire code and press the tab button, because this code should be inside the for loop. Okay. Now we will come outside the for loop and we will terminate our code. So I want black background. So let's fill the background with black color. You can either pass the tuple RGB or you can initialize first and then use the name. Now we will put this image on the screen with the help of blit function. Blit and rectangle coordinates as well. And we will update the screen. You can either use update method or flip method. Pygame dot quit to uninitialize all the resources which are initialized before. So this is the code, and in this code what we have done, let's go through the code one more time. We have imported the libraries. We have initialized two colors. These are the tuple values of the color pink and black. We have initialized all the modules. Then height and width is 1000 and 650. The display is created. And the size is this 1000 by 640. Then we have loaded the image. After loading the image, we have converted the image for better display. Then we used get underscore rectangle to get the coordinates of the picture. We have drawn the pink rectangle around the image. Let's take the center coordinates of the image. Then we have initialized the value like done, angle and scale. We have created this loop, and this loop will run until the value of done is changed, or someone presses the exit button or closes the window. So we will check all the events in this while loop. The first event is if someone presses the quit button, we are going to close the program. If someone releases the key press, any key on the keyboard is released, then we are going to check which key is pressed basically, and based on that we will perform the transformation. So if someone presses the Q key, then we are going to perform the rotation, and based on the combination of Q key and Alt key, we will decide whether we want to rotate the image clockwise or anti-clockwise. And we have also decided the angle, and it will rotate the picture by 20 degrees. The next is if there is a key down event, and if that event is if someone presses T key, then we are going to scale the image. And if there is a combination of Shift key and the T key, based on these two keys, we will decide whether to scale zoom out image or zoom in image. So these are the two keys which will decide whether to zoom out or zoom in. The next key event is if someone releases the O key, we are going to reset the image to its original shape. So we will change the scale value to 1 and angle 0. The next is we are going to check if someone wants to perform the horizontal or vertical flip. Then if someone presses the 0 key, then we are going to flip the image horizontally. If someone presses 1 key, then the image will be flipped vertically. So this flip is based on the values of X boolean and Y boolean. Then the next is Laplacian transform. If someone presses L key, we are going to perform the Laplacian transform. If someone presses S key, we are going to scale the image 2 times. If you want to rotate the image by passing some degrees, then we can do that with the help of rotate function. Pass the name of image and the degrees. And finally, we are going to set the background black, and we are going to use the blit function to put the image on the screen so that we can move the image. And finally, we need to update the display to get a better result. And pygame.quit is used to uninitialize all the model which are initialized before. Now let's run this code to check the output. So this is the image which we have loaded, and the rectangle is pink. Now let's perform whatever the transformation we have created for this image. So let's rotate the image vertical by pressing one button. Horizontal is this. Now we can also rotate the image by pressing the R button. We are rotating this image. Now if we want to bring this image to the original shape, we will press O button. Similarly, we can scale the image, zoom in and zoom out with the combination of key. Okay, and Laplacian transform. We are not able to see the Laplacian transform because the background is black, original. So in this way, you can perform different operation on this image with the help of different functions of images. To make our game attractive, to give captions, titles to the game, and if you want to write something, then you need fonts. So let's understand what are the different functions which are available in the font class and how you can use it. So there are basically these are some of the basic functions. The first one is pygame.font.init method. Whenever you are using any module which are present in some class, then you have to initialize that module first. To initialize any module, you have to use method which is init. So if you are writing pygame.init, it means that you are initializing all the module at once. But instead of initializing all the module, if you think that it's consuming lots and lots of memory, then you can do one thing. You can initialize only the module which you need in your program. So if you want to initialize, the first step is pygame.font.init method. The next is, after initializing any module, when you quit your program, it's important to uninitialize all the module. So when we quit or close down the application, all the resources are deallocated. In the similar way, pygame.font.quit is used to uninitialize the module. So this is written at the end of the program. Instead of writing these two steps, basically we just write pygame init and pygame quit, and we initialize all the module at once and we uninitialized at once. So instead of just importing or initializing one module at a time, it's better to go for this statement which is pygame.init. The next is pygame.font.getInit. So this functions returns if the font module is initialized or not. So if you want to check if the font module is initialized or not, then you can check that with the help of this function. And if this function returns true, it means that the font module is initialized. The next is pygame.font.getDefaultFont. If you want to check what is the default font for your program, then you can check that with the help of this, so that you can use any other font if you want. The next is pygame.font.getFonts. It is not an easy task to remember all the fonts because the names are really complicated. So if you want to get the list of all the available fonts in your module, then you can do that with the help of pygame.font.getFonts. So this getFonts function will give you all the available fonts in the pygame. It will give you in a list format, so you can check out what are the fonts and you can use them to make your game attractive. The next is pygame.font.matchFont. So basically it get all the list of the matching fonts. For example, if you want to check whether the font is available in the pygame or not, then you can do with the help of matchFont. The next is pygame.font.systemFont. So this creates a font object from the system font. So whatever the system fonts are present from those system font, it helps us to create the object and you can use that font in your program. The next is pygame.font.font. So it creates a new font object from a file. So for example, there are certain TFF files. So you can use those font and you can create the object of that font and use it in your program to write some text in that particular font. So these are some of the basic functions of the pygame. Now here I have written one program, and with the help of that program I'll show you how all of these functions work. The first is pygame. You have to import the necessary module which is pygame. The next is we will initialize all the modules in the pygame. So you can do that with the help of pygame.init method. This is the one step. Or so this step will initialize all the modules. Here we learn how to initialize the font module. To initialize the font module, you have to write pygame.font.init method. So instead of writing pygame.init, you can also write pygame.font.init. So this is also one way to write initialize a particular module. Instead of writing this, what we'll do, we'll just comment it out and let's see what happens if we just initialize the font module. Okay. The next is we need to create the display. To create the display, you need to write the statement which is pygame.display.setMode. So this setMode method will create a window for you, and here you need to pass the tuple. The tuple is 600, comma 380. 600 is the x coordinate and this is the y coordinate. You can also do like this. You can write here size, and here you can pass whatever size you want. For example, I want 600 comma 300. So first create tuple here and then just pass the name of the variable here, which is size. So this is another way of setting the values of the window. Pygame.display.set mode and pass the size of the window. Then it's important to create the clock for your program, which refreshes your screen according to the frames per second. So to set the frame per second rate, you have to initialize that with the help of the clock method. So basically it updates your screen. To update your screen according to the frame per second ratio. Now this is the variable which is declared and the value is set to false. Basically this is for loop. I'll explain the use of this variable as well. Now we want to create a window, and on that window I want to create two text. One text is game and another text is pygame. Okay. To do that, we have font which is pygame.font.sysfont. Sysfont means I'm taking the font from some particular system. So that's why these are the system fonts. So Comic Sans SMS. So this is the system font and this is the size I'm going to pass. So for this font, for this particular font, I want to put text that is game. So text is equal to font.render. Render method is used to write the text on the window. So game, true, and this is the color of the font. Okay. This is the another method where we can use this font, which is pygame.font.font. As I have already explained you, this creates a file font object from a file. So this is the file which is free sans bold tf, and from this file I'm going to create the object for this file and I'm going to write some text, and the size is 32. Okay. So I'm going to write pygame here with the help of this font which is free sans bold.ttf. Now these are some of the functions which I'll explain you now. Okay. So we are going to create two text. One is the game and another is pygame. We are going to create a game text and the font is this Comic Sans SMS, and we are going to create another text which is pygame and the font is sans s bold tf. Okay. Now I want to check all the fonts in my system. To check all the fonts in the system, we will use x is equal to pygame.font.getFonts method. So with the help of this get fonts, I'll get the list of all the fonts in the system. So if I'll run this code, I'll get list of all the fonts. So these are the different fonts which are available, that is Arial, Arial Black, Calibri, Cambria, Candra. So these are the different fonts. You can use any of these fonts to write on the window. So if you don't remember what are the different fonts, you can get the list of all these fonts here with the help of the function which is pygame.font.getFonts. I've already explained you this function which is here, that is pygame.font.getFonts. So it will give you the list of all the available fonts in the game. And print text. So here you have to write a variable, and in that variable you will call a function, and whatever the list is there, it will get stored in the variable x, and we have printed that variable here. Now to get the default font, what is the default font? Then you will write pygame.font.getDefaultFont and you will get that value. For now the default font here is this freesansbold.ttf is the default font. This is the last part where you can create a program. We will create a loop and we will update the screen. So here for event in pygame.event.get. So this method, pygame.event.get method, gets all the events which are happening in a queue. So it will returns a queue, and in that queue, whatever the events has happened are stored. So we can iterate through all of these events one by one. And if any of these event is equal to quit, we will come out of the loop. The loop breaks. And if some event is equal to key down, if someone presses the escape key, and then also we are going to terminate the loop. You can also skip this step. There is no need of this step. Then we are going to fill the screen with the black color. No, it's red color, I think. 255, 255, 0. In this way, you have to pass the tuple. Then these are the two important method, which is blit method. With the help of blit, you can add your whatever object you have created to the surface. So this is the object which I have created, and these are the coordinates on which I want to put that object. So I have created two texts, and these two texts, with the help of blit function, I'm going to put it on the window. So this is the flip method. Flip method is basically used to update the particular areas of the screen. If you want to update the entire screen, then you just write update. But if you want to update the specific areas on the screen, then write flip. And then set the clock ticks. Clock ticks is 40. So after 40 frame per second, the screen will be updated. And pygame.quit is used to uninitialize all the initialized method. Now we have made one change here. Instead of writing here, I have written pygame.font.init. So in the similar way, I will write pygame.font.quit. Okay. Now let's run this code to check the output. So this is our output. The background is set to yellow. The one name is in green color and another name is in pink color. Okay. So in this way, you can create text on the window and using different fonts and different colors. Now we will understand how to use and set different cursor. In your game application, if you want to create some animated cursor, then you can also do that. So there are different functionalities present in Pygame. So one of them is cursor functionality. So in this program, we are going to create a cartoon cursor. So let's start and understand how to create a cursor. So I'll give name cartoon cursor. Now you can create any shape of cursor. You can either download an image and you can make cursor of that image, or you can just create your own image in Paint. You can download it and you can use it as a cursor. So if you want to use some image as a cursor, then I have downloaded one image here, which is star, and another I have downloaded the image of penguin. You can also create cursor. If you want to create a cursor, then you can do like this. You have to open the Paint application, and in that you can create your icon and then just download it in the JPG or PNG format and use it. I'll show you that part also, but now I have already downloaded one image which is star, and I'm going to use that now. The first step is basic. You have to import certain libraries. So we will import Pygame, then system. Then we will also import all the local libraries from the Pygame. Now, the second step is initialization of the module. Here we are going to initialize our game application. So pygame.init. So in this way, our game is initialized, or all the modules in the Pygame is initialized. So if you want to use all the modules in the Pygame, then this is the best method to initialize any module. Or you can also initialize the specific module by writing pygame dot the name of the class dot init method. The next important step is we are going to create a screen. We want display, and on that display we will animate the cursor. Okay, so we will create a screen now. So create display, and you are going to create a screen. To create a screen, we have functionality which is pygame dot display. Pygame dot display dot set mode. And here you have to pass the width and height of a display screen. So either you can pass it as a tuple, or you can create a separate tuple for it and then you can pass the variable here. I am directly creating a tuple here, and the size is 1000 by 500. You can create display size. You can set parameter as per your need. Okay, so you can also create a small window, big window. So as per your need, you just set the parameters. Now I'm going to create a cursor using some image. So first thing is I'll load image. So I will load image. So let's take image. I have downloaded one image and which is star shaped. So just load the image. So to load the image, we will use the method which is pygame.image.load. And here you have to pass, you can directly pass the name of image as well, or you can pass this variable img. So pass the variable img. Now we have completed with the initialization section. We have imported libraries, we have initialized all the modules in the Pygame. Then we have created a display and we have also loaded the image which is required. The next step is we are going to create a while loop and all the game logic will be written in this while loop. So whatever operations we will perform, so basic or the game logic, main game logic will be written in this main game loop. So generally we will start with while not false. So this loop will run until this value changes. Not false means true. Okay. Now, first of all, we need to check whatever the events are happening. So we have to keep track of all the events which has happened. So to keep the track of the event, we have the event queue. In that event queue, all the events are logged one after the another in a sequential manner. These events are checked one by one and based on that, the actions are taken. For example, if you are just hovering a mouse on the screen, it means that some event is happening. So the coordinates of the mouse are returned. Or if you have just closed the window, so that is also one of the event. So there are different events which takes place and based on these events, the event queue is created and in that event queue, the events are logged one after the another. So you have to check which event has happened according to the sequence and based on that, you have to take the actions. The first one is if someone just shuts down the program. So in that case, we have to write some code to quit the application. So the event type is quit event. Okay. So we will check all the events in the event queue with the help of a for loop. So this for loop will iterate all the events and to get all the events, we will use pygame.event.get method. Now for event in pygame dot event dot get method. So this pygame dot event dot get method will return the event queue and all the events in the event queue are iterated with the help of the for loop. Now let's check the type of event. So if event dot type is equal to quit, type of event is quit, then we are going to quit the application and all the modules which are initialized before are uninitialized. So pygame.quit basically uninitializes all the modules. Okay. This is not the event which is triggered. Then we will proceed with our game logic and we will write the code now. Now we want to create a screen and on that screen we want to create a cartoon cursor. To create a screen, we have already created a display. Now we will set a color for that screen. So to set a background color, there is a method which is known as fill method. So screen.fill and just write the name of the color. But first you have to initialize that. If you want to skip that step, then just pass the RGB values for the tuple. I want to set white background. So RGB values are 255, 255, 255. So this is the RGB value. Now you have to get the position of the mouse cursor because whenever you will move the mouse on the screen, you have to move the image along with that cursor. So it's very important to get the coordinates of the mouse cursor, and according to that we will paste the image on that cursor and we will move the image along with that cursor. So in this way we can animate the cartoon cursor. Now the background is set to white color. Now let's get the coordinates of the mouse cursor. To get the coordinates of the mouse cursor, we will use pygame.mouse.getPosition method, which is equal to so this position will return the x and y coordinates of the cursor on the screen. So it will continuously tell you what is the position of the cursor, and based on that we can move our image along with that. Now we will calculate the width and height of the cursor. Means we want to place the image in the center of the cursor. So for that we need to find out the height and width of the cursor for an image. Okay. So now let's calculate the x and y coordinate for the image. So we want the midpoint of the cursor. So x minus equal to cursor dot get width, and we are going to calculate the 50% of that width. Similarly, so this will return us the midpoint of the image, this two lines. Okay. After creating any object, the another important thing is we have to put that object on the surface. So we have already learnt about the blit method, so I won't explain you in detail what is blit. So now we are going to put that cursor on the screen. So where I want to put that function, I want to put that function on the screen. So let's use the blit method, and in that blit method I'm going to pass the object which I want to paste along with the position. Now we have to update the screen each and every time so as to get the recent output. So let's update the screen. Unless and until we update the screen, we won't be able to see the output. There is also one more method with the help of which you can update the screen, and the name of that method is flip method. If you are using the flip method, it updates the specific areas of the screen, and if you are using the update method, then it updates the entire screen. So it's totally upon you what you want to do. If you want to do your computation in the less number of steps or in less time, then go for this method, which is dot flip, and if you don't care about the computation time, then just go for update method. So this is the end of our program. So what we have done, we have imported important libraries, then we have initialized all the modules in the program. We have created a variable, and in that variable we have declared our image file. Then the display is created with the help of display.setMode. Then the image is loaded. After loading the image, we have created a loop, and that loop will run until the value remains true. With the help of pygame.event.get method, we have gathered all the events in a queue, and we are going to iterate all the events one by one, and we are going to check what is the event type, and based on the event type we will take the required action. So if the event type is equal to quit, then we will quit the application. If not, then we are going to fill the background with the white color. Then we are going to get the mouse coordinates with the help of getPosition method, and then we are going to put that image on that cursor, and we will update the screen to get the recent output. Now let's run this to see what is the output. For colon quit we should write everything inside the for loop. We got the output. See, we have created a cursor and we have used the star image. As I am moving my mouse, the image is also moving along with the cursor. So in this way you can create animated cursor in your game application. So in case if you are creating a game for kids, so they will be fascinated by such cursor. So in this way you can create the image cursor. Now I will use another image. Now let's use another image. So this is big one. Angry bird. Now let's see how to create our own cursor. So in the Paint application, here you can create your cursor. For example, if you want to create some, okay, let's create cloud. Okay, let's give some color. Fill it with some color. Okay, so for example, icon which I have created, we can also write here something. Pygame. Okay, now let's save this. We will save it as a PNG image. And we will save it in a current working directory. Let's give name custom icon, custom icon. Okay, save it. Now we have created this image, this icon we have created. Now we will use it in our program. Run this program. See, we have created our own icon and we are using it as a cursor now. So in this way you can create your own cartoon characters, your game characters, and you can animate them. We have learned how to create different object, background, text, font, colors. Now let's learn how to move the object. In game, you have to animate the objects, you have to move the objects. Now we will see a small program which will move image. So the name of this program is image movement. Image movement exists, image move. Okay. As usual, the first steps is importing the necessary libraries. Pygame. After importing the necessary libraries, the next step is to initialize all the modules. So pygame.init method is used to initialize all the modules in the program. If you are not using pygame.init method, then you have to import individual modules by using pygame. The name of the function or the class .init. In this way you can initialize the module. But pygame.init method initializes all the module at once. After the initialization, let's create a display. To create a display, we are going to use the size of the window. Size is equal to, let's take 600. We'll create big window, 1000, 500. Okay. Now to create a window, there is a function which is pygame.display, and with the help of that we can set the window size. So screen is equal to pygame.display dot set mode, and let's pass the size. Okay, or you can also write size here directly. We have created a tuple and we are passing the tuple here. Okay, after creating the window, you can load any image. You can create your own cartoon character, game character, and you can load that by game dot image dot load. And here I'm going to load my favorite cartoon character, penguin, angry bird, peng.png, and use the method convert. You can also skip this step. You can skip this convert function as well. The next thing is clock timing is very important because it updates your screen as per the frame per second count. So to set the frame per second count, you have to use the method which is pygame.time.clock method. So let's create another variable which is clock and use pygame.time.clock. Okay, so C is capital here. The next thing is we are going to create some variable which is x and y. Now, the main important thing is we are moving an object. To move an object, we need to change the coordinates of the x and y. So at any position, if you are putting your image, you have to increment that image or decrement that image to move the image to left or right. So based on the x and y, our image will shift to the another location. Basically, when we move any object, we don't literally shift the image. We just recreate the image at some another location and we just erase the image which was at the previous position. So what we are going to do now, we are going to change the coordinates of the x and y, and that coordinates will get updated and the previous image will be erased. So you can move this image based on the increment factor. So if you want to move the image by 1 location, 2 location, 5 location, so it depends on you how you want to move your image. So what we are going to do is the basic thing is we are just going to increment the values of x and y, or we are going to decrement the values of x and y. It's up to you whether you want to move image to left side or right side. Here I'm not going to control the image, so we will do that in the next program. Here I'm just going to move the image either to left or to the right. Okay. Now after creating the time clock, let's create the variables. So we need to initialize the variable first and dynamically we will update these two variables. So initially I want my image to be at this position which is 405. Now also create one more variable which is done and set it as true. Then now I want background in the black color. So I'll create one tuple and I'll set the color to 0000000 means black. Now let's create a game while loop. So while done. So this loop will run until the value of done changes to false. Okay. And again we have to do the same thing. We have to check all the events which is happening and we have to log all those events in the event queue. Then we will create a for loop. With the help of that for loop, we will iterate through all the events and based on the event type, we will take the required action. So if the event type is quit, we will quit the application, and if the event type is not quit, then we will proceed with the logic which we have written in the while loop. Now we are going to iterate all the events in the event queue. For event in pygame.event.get method. So let's iterate all the events in the event queue. Check the event type. If event.type is equal to pygame.quit. If someone presses the quit button, then we are going to change the status of done and we will set it as false. Okay. So in case if someone doesn't quits the application, then we will write the code. So if Now what we want to do, we want to change the location of the image, or we want to move the image. To move the image, I told you we have to just change the coordinates of x and y. Here I want to move image horizontally, so I will change only the x coordinate. If you want to move vertically, then you have to change the y coordinate. So I'll keep y coordinate as it is and I'll just change the x coordinate. So I want to move the x coordinate. So what I'll do, I will increment or decrement my x coordinate by some parameter. And in this while loop, I'm writing the code, so dynamically it will get updated. So x is equal to -5, then screen. Now let's set the background with the help of fill parameter, and you can set any color. So let's set black color, but you can't directly write the name of the color. First you have to initialize that color. You have to use the color code OR. So this is the color code for black. I have initialized it first and then I'm going to use it. So if you want to use any other color, you can directly use it here. You can just pass the name of the color code. Okay. The next thing is, after loading the image, we need to put that image on the background, and I want to update that image dynamically as well. So screen dot blit. Blit is the method which is used to put the object on the screen. So with the help of blit method, I'm going to do that. So let's put whatever the image we have on the screen and put it on some coordinates, which is x and y. Now let's update the screen. So pygame dot display dot update. Another method to update the screen is the flip method. You can also use that to update the specific areas of the screen. Then you can refresh your screen based on the clock ticks. So that will speed up your animation or it will slow down your animation. If you want to speed up, then you have to give more frame per second, and if you want to slow down, then give less frame per second. Then clock tick is 30, and then let's quit the application pygame dot quit and run the program. And we got the output and it's not moving. Now let's see what is the problem. Because I wrote okay. See, the image is moving now. So this is moving horizontally because I set x parameter. So if you want to move the image vertically, then you need to set the y parameter. So let's set y parameter here and let's check. See, the image is going up. So in this way, you can animate your image, you can move your image. We have learned how to create object, how to move it. Now we will learn how to control the object. Like on the key press, the object should move. Okay, so we will write a program in which we will create one object which is circle, and based on our key press, the object will move left, right, top or bottom. Okay, so for that we first need to import some libraries, then we need to create a display. The third step is we will create the object which you want to move. You can either create circle, rectangle, line, anything, and then based on the key hit, the object will move. Either it will move left, right, top or bottom. So let's create a program and let's move the object. The first step is we will import the libraries. So let's import the first library, which is pygame. After importing the library, we will initialize the library. So let's initialize the library. To initialize all the models in the pygame, we write pygame dot init method. So with the help of this, the models are initialized. Now let's create a display, and on that display, we will also set a caption. So let's create the display. To create a display, we have method which is pygame dot display dot set mode, and here we need to pass the size of the window, the size of the screen which you are going to create now. So here you have to pass the size in the form of a tuple. You can't just pass 1000, 200. So it will not accept. So you have to give it in a round bracket in the form of a tuple. You have to pass it. After creating the display, now we can also give a title to our window. So let's give title. So to give a title, we have to use a method which is known as set caption. And just give the name. Move an object. Okay. So this is the title we have set for our window. Now I have already explained you the logic to move any object. So that's why we will initialize the x and y coordinate outside the for loop, and we will change the position of the x and y coordinate to move the object inside the loop. Okay. So first initialize or set the size of the object. So write x coordinate and y coordinate. You can take any parameter, or you can also give values like 10. So this is the first position. This is the position where we will set our circle. So the position at 10, 10. Now create a for loop. And this while loop will run until the value of running changes. So basically the value is set to true. Then we are going to check all the events in the queue, because whatever the event has happened or happening in the program, all those events gets logged in the queue. We are going to use a for loop to iterate through each and every event to check the type of event. For event in, we have to check all the events in the event queue. Okay. So pygame dot event dot get. Now let's check the type of event. So if event dot type let's check the type of event. If the event type is quit, then we will close the program, and we will, to terminate the loop, we will change the value of running. So first value of running is true, and this loop will run until the value of running is true. So this loop will run continuously. But if some event occurs and if that event type is quit, then we will change the value of this running to false, and in this way we can terminate the while loop. Now we have to check the key press. So we will check which key is hit. So hit is equal to, I'm going to check which type of keys are pressed. So pygame dot key, and I'm going to check the status of the key. So with the help of get pressed, we will get the key identifiers. So with the help of this, we will check which key is pressed actually. Now let's check which keys are pressed. So now we are going to perform action. The image will move to the left side if the L key is pressed. The image will move to the right side if R key is pressed. The image will move to top if T is pressed, and image will move to bottom if B is pressed. So let's create the if and else, if parts, if conditions, and based on the key pressed, we will take the required action. So if keys pygame dot, so let's check the identifier which are pressed, like keys pygame dot k dot l. K dot l is k underscore is the constant identifier, and if you want to identify which key is pressed, then you have to check the identifier. So the identifier is k underscore and then the name of the key. So if the left key is pressed, I'm going to shift the position by 5. So the image will move to left with the decrement factor of 5. So let's copy this and write the code for all the positions. So if R key is pressed, that is the right side key is pressed, then I will increment it by 5. If the key is pressed, if the top key is pressed, then I will change the Y position. And if the bottom key is pressed, I am going to increment it by 5. Okay. And finally, so this is the logic which will move our image. So if left key is pressed, L key is pressed, then it will move it to left side by 5. So in this way, we are going to move the image. Now let's change the background. To change the background, screen dot fill and set the color of background. Then also set the clock ticks. We have not initialized the clock here, so let's do that as well. So let's create the clock first. And set the frame per second ratio. Now let's create the object which we want to move. Suppose I want to create a circle, then pygame dot, in the draw method, in the draw class, you will get all the drawing primitives. And you have to pass the surface on which you want to create a circle. So screen. Then you have to pass the color of the circle. Then pass the coordinates, that is x and y. And dynamically this x and y coordinate will get updated based on the key hit. And then pass the radius. Then update your screen. So pygame dot display dot update your screen. And then finally quit your application. Pygame dot quit. Okay. So let's try to run this program and let's see. Invalid syntax. Yes, because we have not terminated this by colon. Expected an indentation. Yes. Tab is expected because indentation is necessary. We got the output, but again we got an error. Keys is not defined. Okay, so the problem is we have written here hit. So actually I should write hit here instead of keys. Because whatever the key will be pressed, that will be stored in this variable, and in this variable we have to check which key is basically pressed, and based on that we have to take the action. Okay. So we can restart and clear the output. Run this. Still it's not responding because there must be some problem. Okay, so let's go through the code one more time to check what is the problem. Pygame init clock, then mode, caption, true. Then let's see all the events. Let's put some delay here. Let's see. if that works. Okay, then events, get event type running. Then we are going to check the status. Hit. Okay, it's fine. Screen.field. Yes, it should be in the form of a tuple. So restart it. Run this. Okay. So I'm pressing R key. So it's moving to right side. I'm pressing B. Bottom key is not working. Top key is working. Bottom key is not working. So let's check what is the problem with bottom key. Yes, it should be Y. Now let's run the code. Now I'm pressing the bottom B key. It's going bottom, top. I'm pressing the left key. Now I'm pressing the right key. Okay. So now let's change this clock ticks and see what happens. Okay. So this is, in this way you can control your object with the help of event handling, and with this, with the help of event handling and different techniques. So in this way you can create object and move the object, and you can also control the object.